Thank you. See? So hello everyone, how are you all? Here I am Abhishek, your physics faculty, and today together we are going to have a marathon session for 10 hours of revision of PO2 syllabus. Yes, you are listening correct. 10 hours of revision of complete marathon in the complete night. So I am ready. Are you? Show your energy in the comment section. Okay. Answer everything fine. So if I will talk about the exam of boards, there is a little bit difference because every students who are preparing for JEE or NEET, they are preparing along with for boards also. So if I will talk about the difference in the exam pattern or the little bit things, there is a very slight difference. If you are talking about competitive exam, it's more about hard work. But when I am talking about boards exam, obviously without hard work you cannot achieve anything. But it's more little bit about smart work. What how smartly you are managing your studies, it will make a very by slight difference. You can have easily 85-90%. There is nothing tough in that. And for that thing, I have narrowed down everything in a single note slide. Okay, so that it will help you a lot. I've narrowed down every chapter important things that can be predicted in your exam. So it will be very helpful for you if you are just understanding these things that we are going to discuss here. Okay. I will more focus on the derivations. I will explain you the theoretical parts and we will focus on the numericals only. Okay. So firstly, I will talk about the pattern of boards exam. There are, you can see, there are 15 MCQ questions that will give you 15 marks. 5 fill in the blanks that will give you 5 marks. 5 two short questions that will give you 10 marks. 5 middle kind of questions, short answers that will give you 15 marks. And 3 questions long answer that will give you 15 marks. And 2 questions that are numericals that will give you 10 marks. That means complete the paper will be for 70 marks. You already know the patterns, basic pattern. So now we can start. And the first chapter is electrostatics, and for electrostatics this is the first part, that is electric charges and fields. So what we are going to study in electrostatics basically, let's see. See, complete 12th physics is divided in charges and different behavior of charges we are going to study. First part is electrostatics. What do you mean by electrostatics? The name is itself very much clear. Electro plus statics. That means what do you understand from this? Electro means charge and static means rest. That means in this scenario we are going to analyze the cases of when charges are only at rest. And in next portion what will happen? Let's suppose my charge is moving with some constant velocity. Then what will happen? It will generate electric field as well as magnetic field. That is the second portion of physics, complete magnetism, that we are going to study in the latter half. And the final portion is when this is moving with some acceleration, then we will notice that it will emit electric field as well as magnetic field. Along with it, we will have some electromagnetic waves. So this is the major portion of this complete physics, how we are going to proceed. Then we will study about ray optics, and then finally we will end up with modern physics. Okay. So let's start. So firstly, in this chapter, we have to understand the basic behavior of charges. So I am just quickly revising the basic properties that you maybe already know. There are all of two types. First one is positive charge, second one is negative charge. Like charges repel each other. That means let's suppose if positive charge plus q and plus q is kept here, what will happen between them? And let's suppose I am giving you the distance r. Anyways, we will see Coulomb's law. That will give you the proper idea. But what happens, you know, basically they will repel each other. Repel each other, that means they will have the tendency to move away from each other. That means both of them will have a repelling force, changing the one polarity of the charge. Let's suppose I am taking a negative charge here, a negative charge. Now what will happen? A positive, negative, both of them will attract each other. Very basic property. Next thing is charge is additive in nature. That means plus 2 coulomb, 5 microcoulomb, minus 3 microcoulomb. Simply what will give you 4 microcoulomb, 4 coulomb. That is basic addition. Charge is quantized. What do you mean by quantized? Q is equal to plus minus any. That means what kind of charges are possible? Charge can either be 0, either it can be 1 electron, either it can be in the terms of 2 electrons, and this kind of charges are there always. They are always quantized. Fourth property is charge is always conserved. That means what do you understand from charge is conserved? Charges can neither be created nor be destroyed. So if you will have a general confusion that if charges cannot be created, neither be destroyed. So let's suppose I have taken, let's suppose this body is neutral. So if someone asks me how to charge this body, so how will it do? Because we cannot create any charge or neither I can destroy any charge. So there is a different term we use, that is sharing of charges. Now what is the concept of sharing charges? It is given in NCERT. You can read from there. Some basic methods we use like friction, by induction, by conduction. There are lots of methods by which we use to charge. That means basically we can transfer charge. We cannot create charge. That is also called as induced charge. So these are about the basic properties. Now first and the foremost important thing in electrostatics is Coulomb's law. From here our 12th syllabus is started. What is Coulomb's law? A scientist was there, you all of you know, Charles Augustin de Coulomb, and what he have did, he have taken two charges, Q1 and Q2, and he have given some distance R, and he have performed some experiments. And let's see what was the experiment. He have observed that when he have he have kept the Q1, Q2 at distance R, he have founded that this force was coming proportional to charge Q1 and charge Q2 multiplication. Further, when he have changed the distance, then he have founded that force was actually what? Inversely proportional to R square. So when we have we have collected this, what we will get? Force is equal to, whenever you know that whenever we remove proportionality, we will have some constant. So what is that constant? Force is equal to K Q1 Q2 divided by R square, and it is the very important formula of Coulomb's law that always you have to remember. If there are two charges, magnitude is Q1 Q2, distance is R, what will be the force between them? Q1 Q2 divided by R square. One more thing, what is this K? This K is called as Coulomb's constant. What is the value of this K? If I will talk about the value of K, it is written as 9 into 10 power 9, and then you can add the units automatically. What it will be the units? Newton meter square divided by Coulomb square. Okay, so this is about the basic force that I will say. Now force in a medium, you know that K is actually equal to what? 1 by 4 pi epsilon naught. Now what is this epsilon naught, new term? It is called as what? Permittivity. What is permittivity? It a lot sounds like a permission. Let's suppose I will talk about this remote. Okay, what is the permittivity of this remote? Simply I can define permittivity is a kind of permission. Let's suppose this electric field lines are passing from it. This complete medium is filled with electric field lines. Now electric field lines have to take permission from everything in which it wants to enter. So how easily this remote is allowing that electric field lines to enter into it, it is called defined as permittivity. So it is a material property. So this value is always given. You can see here I have mentioned the value of epsilon. Epsilon is equal to 8.85 into 10 power minus of 12. You have to remember this value. This is a very standard value. So fine, we are talking about K. What is K? It is equal to 1 by 4 pi epsilon naught. But let's suppose now I have not taken air. I have taken any medium. Now what will be the effect? Simply you don't have to do anything. Multiply it with epsilon r. Whenever you will multiply it with epsilon r, what will happen? Now this is called as relative permittivity. So let's see what will be the effect. Let's suppose I want to write force in air. Let's suppose I want to write force in air. What I will write? The force K Q1 Q2 divided by R square. Further I can write this also as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. But now I am talking about a medium. When I am talking about the medium, then what I have to write? 1 by 4 pi epsilon naught epsilon R into Q1 Q2 divided by R square. When you will properly notice this, what I have written? Actually, I have written the same force that was in air, but only thing extra that I have added is what? This epsilon r. So what I understood from there, that even I can write this force, that is force in a medium, it is equal to force in air divided by epsilon r. What is epsilon r, students? Again I am repeating, it is relative permittivity. Okay. Epsilon naught is defined for air and epsilon r is defined for permittivity, any medium. So this was about force in a medium. Now about vector form. Started from 11th portion, how we write any force in vector. What are the two things that are important for writing vectors? Always ask you a very basic question. Magnitude, and second one is what? Direction. So how we write that? See, what is the magnitude of Coulomb's law? K Q1 Q2 divided by R square. This is what I have written. This is only the magnitude part. Now how I will write the direction also? It is defined as R cap. What is this cap? What this is called as? This is called as what? Unit vector. And what is unit vector? It is a vector that always used to represent the direction. Further, how I can write what is the formula for unit vector? It is written as K Q1 Q2 divided by R square into R vector divided by mod of R vector. So also how you can write this same force? It is the same formula but written in different forms. You should know all these forms. It can be written as multiplied by R vector divided by R cube. So this is the way how to write the force vector in a vector form. Coulomb's law. Now let's see, here you have to write force. A basic question that we are taking. Take 2 minutes and try to solve it by yourself. Here is a charge minus q, and we are asking that what will be the net force that is applied on this minus q charge. You can read the question. 4 charges are there. All these 3 are positive and this one is negative. And distances are also mentioned. It is kind of a square shape. And you have to write what is the net force on this charge on C. So let's see what will be the behavior. You know, if there is positive, negative, what kind of force will be there? Attractive force. I will represent this force as, let's suppose, F. And distance is A. Charges are all charges are Q. And here what is minus Q plus Q? That means, can I say negative charges? The opposite polarity. That means also it will be a attractive force. This will also be, let's suppose I am representing F. What I can say about the force F? What are the charges? K, Q, Q1, Q2, both are the charges same. That means K Q square divided by A square. A is the distance between them, so I can easily write it. And one more is there. I will represent this as F dash. Again a minus charge and a positive charge. That means again it is a kind of attractive force, and I will represent it by, let's suppose, F dash. Now, how to resolve this 3 vector? Basically, our question is come down to 3 vectors. I am again drawing it. Here it is F, here it is F, and here it is F dash. Now 3 vectors you have to basically resolve. How to resolve 2 perpendicular vectors? What is the resultant of 2 perpendicular vectors? Both are equal in magnitude. Can you say I can also draw this diagram as, it will become how much? Root 2F, and in the same direction what is the force? F dash. So what is the net force you can say that is applied? Net force you can write root under 2F plus F dash. What is root 2F? You have already written this value. How much it is? K Q square divided by A plus F dash. What is F dash? This is the force. How will write the force? Again, K Q1 Q2. Q1 and Q2 both are same. That means you can add K Q square divided. What is the distance between them? Root 2A. So simply I will write root under 2A. So this I can say this is your net force that is applied on the force. Now you can further simplify. You can take KQ square and everything common, and you can finally quote your answer in this way. Okay. So this was a basic application of Coulomb's law. I guess you understand. Now we'll understand electric field. Till now we are discussing about charges. That means now if there is any charge, we are discussing that electrostatic force will also be there. If there is an electrostatic force, that means there is some electric field. Let's suppose what I am trying to say. Let's suppose this is a charge. Okay. What will happen? Electric lines of forces is coming out of it. That means it will create a region that is completely electric field, and that region is defined as, you can see the definition. Electric field is a region of space around a charge or a system of charge within which other charge particle experience a force. What is the meaning? Let's suppose here I have taken a positive charge, and I am saying a region will be around it, this positive charge, which is called as what? Region of electric field. Now how I will identify that it is a region of electric field? Simply I add a test charge. We'll name this as a test charge and I will name this as source charge. Now what will happen with this test charge? If this is positive, what will happen? It will experience a force, and that force I will say what kind of force it will experience? Repulsive force. Reason, same charges repel each other. So this is the definition, and how electric field intensity is represented. It is represented as it is given as electric field is equal to force per unit test charge, and that can also be written as what is force? K Q naught Qt divided by R square, and it is divided by test charge. So test charge will get cancel out, and finally what will be the formula? Electric field is equal to K Q naught into R square. This is the final formula that you have to remember. And what I can say about the units, what is, you can write the units of electric field. In numerator what is there? Force means what? Newton divided by charge. Charge is what? Coulomb. So Newton per Coulomb will be the simple units. Here it is already written. Now, if let's suppose you have to find what will be the direction. So let's suppose a point I have given you, a charge Q, and I have given you a point P at a distance R, and I will ask you a simple question: what will be the direction of electric field? So always remember, whatever the direction of electric force, it is along the direction of electric field. So I will assume that I am always positive. What I will assume? My point that is there, it is always positive. So if it is positive, I am assuming that here I am standing and it is positive, and here source charge is also positive. Positive means what kind of force you will have? Repulsive force. That means force, electric field will be in this direction. And in case if this is a negative, then what kind of force? It will be a attractive force. Where it gone? Let's suppose second case I am drawing minus of Q, and here a point P is there. Distance is R. This time again I will say I am standing here. My point is always positive. Here it is a negative charge. Positive and negative. That means what kind of force there will be? Attractive force. And if this is the direction of force, can I say this is the same direction for electric field as well? And what I can write about the magnitude also, about of electric field? The magnitude already I have told you, it is KQ divided by R square. This will be the simple formula. This is the direction. Both directions and magnitudes are equally important. So see, electric field due to point charge, already I have told you how to write. This is the same explanation that is there. If you are talking about in terms of vector, how you can write? This term is what? 1 by 4 pi epsilon naught Q. This is the force. And how electric field is defined? Force per unit source charge. And here see. Actually, you can write again the same thing. Electric field can be written as magnitude bar K Q naught divided by R square into position vector. Now how you write position vector? R cap. So how you will rewrite this? K Q naught divided by R cube into given vector. The same formula that is written here. It is the same meaning. It is further written, and it is shown about the directions also. Like here, if there is a, how you can see how electric field is varying with respect to distance. This is your electric field on y-axis, and on the x-axis what is there? R square. So what kind of relation you will have? It will be continuously decreasing because it is inversely proportional to R square. This kind of curve will be coming. These curves are important. Now superposition is a very simple thing. What is superposition principle? Let's suppose you are having 5 charges. The effect due to all these things you have to write at a single point. How you will write? Let's suppose you are writing at this point the effects of everyone on the charge Q1. Firstly, I will take, let's suppose, Q2. Now Q2 is what kind of force? Positive. Q1 is also positive. What kind of force? Repulsive. Here it is shown. This is force on 1 due to 2. If I will talk about Q3, Q3 is a negative. It is positive. That means what kind of charge? Force? Attractive. Now talk about Q4. Q4 is positive. This is also positive. That means it will be repulsive. This way it is just representation of the forces. Simple thing, superposition principle. Now we will talk about electric lines of forces. Electric lines of forces are actually imaginary lines that represent the electric field lines or the direction. Let's suppose I will take a very simple example. Let's suppose somewhere here, this is the representation of electric lines of force. So if someone asks you, tell me at this point what will be the direction. I have drawn an electric field line and I am wanting to have the direction. Simply there is no rocket science, just draw the tangent. At any point, if you want to find the direction, draw a tangent. It will always give you the direction for electric force at that point or electric field at that point. So let's suppose if I want to find the direction of electric field at this position, where electric field is going. So I will simply draw the tangent at this point. I will have the direction like this. Same thing is represented here. That tangent is drawn and it has been showing the direction of electric lines of force. Rest of the theoretical things are given. You can study. All these PDFs will be available in your app, so you can check out from there. Now, from point charges, what kind of electric lines of forces are there? Let's suppose two cases are here. One is charge is what? Positive. Second case, charge is what? Negative. Always remember this thing, positive from positive charge, electric field always originate. Remember a term, originate from positive charge, and on negative charge what it is? It always terminates. You can see that some electric lines of forces are coming from some infinite distance and all of them are terminating on the negative charge. This is a kind of negative charge and here electric lines of forces terminates. Basic property you have to remember. Now let's suppose I have taken two charges and now I want to see what kind of electric lines of forces I will get. So basically it is a very simple thing. What I have told you, from positive charge it always originates and from negative charge it always terminates. So what will happen? It will originate from positive charge and it will get terminated on negative charge simply. It is again originating from positive charge and it is terminating at negative charge. You can see the pattern. Here it is originating, all these lines are originating from positive charge and it is getting terminated on negative charge. And rest of the things are going to infinite distance and they are appearing like they are traveling to some infinite distance and finally it is coming to terminate at negative charge. This is the diagram that you have to remember. So this is the basic diagram you can see. Now same way you can go for two positive charge. Now you know the property of two positive charges. Positive charges always originates the electric lines of forces. So you can clearly see all the lines are originating. From here also lines are originating. But what is the difference from previous case? Here we have seen that some lines are directly coming from here, but here it is not possible because both are positive charge and termination is not possible in this case. Why? Lines will be originating and it is terminated at some infinite distance, but it is not the case that some positive charge will be coming from here, electric lines of force, and it will be terminating at this point. This is not practically possible. Basic properties of electric lines of forces, a lot of properties are there. Like, see, the next property is two electric lines of forces can never intersect each other. This is a very important line in a lot of time the question has also been asked. Why two electric lines of forces cannot intersect each other? Let's suppose I am taking two electric lines of forces. This is line 1 and I am taking this line as 2. Two electric lines of forces I am taking. And why I am saying that it can never be intersecting with each other? What I am saying, if I want to find a direction here, how I will find? I will draw a tangent. Simply I have drawn a tangent. But tell me, is only one tangent is possible? No, two tangents are possible. So this tangent is also possible for electric field. So can I say this is possible at a single point, two direction of electric field? No, it is practically not possible. That's why we concluded that electric lines of forces can never cross each other. If they intersecting at a point, that means they have to have two direction at a single point. That is practically not possible. Same thing is represented here also. You can clearly see. All these notes will be available. I am again saying. See, now next property is about the density. How dense your electric lines of forces is, it will represent the where electric field is more, or the intensity. Here it is given that charge capital Q is greater than small charge q. That means it will represent that intensity of electric field is greater from this charge and intensity of electric field will be less from this charge, because you know the formula. What is the formula for electric field? It is kq by r square. So obviously it is dependent on charge. If charge will be more, electric field will also be more, and it is represented beautifully by a diagram. Second property, next property, electric lines of forces are always perpendicular to the body. You can clearly see here, this electric lines of forces and this is a conductor. Let's suppose these lines will always be perpendicular to the electric surface. Here also, let's suppose I have taken some random shape. Here also you can clearly see that electric lines of forces, whatever entering or exiting, doesn't matter, they always be perpendicular. Now number of electric lines of forces is directly proportional to electric field. Let's suppose 4 lines are there. That is the same thing given. Number of electric lines of forces is directly proportional to electric field. That is a property. Next property is, it is a very important one, that electric lines of forces never enters into a conductor. And the reason for that is electric field shielding, or also we call this as electrostatic. The reason is electrostatic shielding. You can clearly see electric lines of forces are coming on the surface, but it is not entering into the body, and from here it is actually exiting to the next further, but it is not entering. This is the very important property. You can see electrostatic shielding is the reason why it is not entering. So these were the properties, basic properties that can be asked in the MCQ question or one word answer. You have to remember. The next thing is electric dipole. Now what is a dipole? Dipole is nothing but a combination of two charges kept very close to each other. Let's suppose this is minus q and this is plus q. Two charges I have taken, and the distance between them we call as 2l. And this distance is actually very less. Here it is shown very large, but I will say you that it is very small. And how it is represented? It is also a vector quantity. What is the definition? Again, see, electric dipole is a pair of equal and opposite charge. Very important point. Separated by a very small distance. These are the two important things in an electric dipole. What is the two important points? Equal and opposite charges, and the second one is very small distance. The electric field produced by electric dipole is called as dipole field. The electric dipole moment is a vector quantity that already I have told you. And now about the formula. What is the formula? It is represented by P, and how we write the formula? It is charge into distance. Distance, what distance? Distance between the two charges. That means this formula, if I will write properly, it is written as Q into, what is the distance between them? 2L. So this is the formula for electric dipole. If I will talk about the units, what will be the units for electric dipole? Q means charge, coulomb, and distance is always represented by meter. So the units will be coulomb into meter. Here it is represented also. One more thing, what is the direction of a dipole? It is always from a negative charge to a positive charge. This is the basic direction of dipole, because it is a vector quantity, so we have to be careful about the directions also. Here again the same things are written. I will rub this. Everything is mentioned here. I am just explaining it. You can read it again. Here SI unit is coulomb meter, and direction is from negative to positive charges. Now let's see what will be the electric field due to a dipole. Two kind of positions we have to talk. Two kind of positions we have to discuss. First one is equatorial position and second one is axial position. Now what is equatorial position? Equatorial position, let's suppose this is the line that is connecting these two charges. Equatorial position is extending the same line, and at some distance, let's suppose this point is P, where I want to calculate what is the electric field. So let's see how we are going to calculate. And the distance given is from this dipole, from the center of this dipole, the distance given is x. We have to calculate what will be the electric field. So firstly we will write, there is nothing special. Again we are going to write the basic electric field. Let's see how. This is charge 1, this is charge 2, and here I have to write the electric field. Firstly write what will be the electric field due to A. What is the formula? KQ divided by R square. That means the distance square. How will write? K. What is the charge here? Q divided by. What about the distance? This is point P. This is distance is x. And what is the extra distance? L. So what you can write about the distance? X plus L whole square. Correct? Now next thing is EB. How will write electric field due to charge B? This is your charge B. This is the point P. Again write the K Q divided by. What is the distance? You can say the complete distance is x and this distance is L. So how you can write x minus L whole square. This was about the magnitude. Now what about the directions? About the directions if I will talk, due to here what I told you, always you will assume that your position is always positive. If your position is always positive here and here what it is positive charge, that means due to B what will be the direction, it will be kind of repulsive force, and due to A what kind of force, attractive force, that means the representation will be in this direction. And whose magnitude will be greater? Of course, the who have the less distance from this point P will have the higher magnitude. That means this charge B will have the higher magnitude. So how I've written the net charge, sorry, net electric field? Net electric field will be written as EB minus EA, because the magnitude of charge B is greater at point P and magnitude of charge A is lesser at point P. And after that, it's just about calculation. Put both these values, it is represented here also, EB minus EA, and when you will solve it, you will have the final result like this. But you don't have to remember the result like this. How you remember? Now notice properly. If you will see, Q into 2L is what? P. And one more approximation we have taken initially, that this distance x is a lot greater than L, the length between the two charges. So how this formula will be written? Electric field will be 2, and this complete value is what? P, and there it is 1 by 4 pi epsilon, that means you can write K also 2. Actually I should rewrite this. It should be written like this: electric field is equal to 2 K P divided by x square. What is the x? Here x, be careful, it is not the distance between them. X is the distance between the dipole and the point. Now next important thing, what about the direction? It is the same direction of the dipole. You can clearly see this is the direction for the dipole. If this is the direction for dipole, electric field net direction will also be in the same direction of the dipole. This is the result, and very important result that you have to always remember. 2 kp by x square. Sorry, x cube. X cube is there. X cube. That means you have to remember that also one question was also asked in previous year, that electric field is inversely proportional to x cube. Why it is, I am telling you, we will discuss it with a question. Here is the complete solution written, then the approximation, and the final result is somewhat like this: 2 kp divided by x cube is the final result. About the direction also it is given. Now the second one is equatorial position. Equatorial position means when you draw perpendicular from the center, you will have a position at point P you have to find. Let's suppose here point is given as Q, the distance is Y, and here are the angles. You have to find what is the electric field at this point. Now see, again I will say the same thing. What you will assume? You are always positive. You are standing here at point Q, you will assume you are positive. Now due to negative charge, what will be the direction? It is a kind of attractive force. This is the force shown for EA. Now what about EB? This is positive, you are also positive, that means what kind of force? Repulsive. You can clearly see this is also repulsive. Now here will be the resultant. Now there will be, you have to resolve two vectors basically. How to resolve? Here I am showing you. See, these are the two vectors. I can say what is the distance between them, this point charge and this one. It will be written as, this distance is L, this is Y, that means it can be written as L square plus Y square. This distance can also be written as L square plus Y square. So I can say one thing, that magnitude of both these electric field is going to be same, E. So take the components. If this angle is theta, this angle is also theta. For EB, what will be the components? This will be EB cos theta. This will be EB sin theta. Now take the components for EA. This component will be EA cos theta. This component will be EB sin theta. And what I told you, that both the magnitudes are actually same. If both the magnitudes are same, can I say they will cancel out each other, this perpendicular components, and I can easily say these two components will get add up and they are going to contribute in the electric field. You can see, and again let's write about the electric fields also. Electric field due to A, what will be there? K Q divided by R square. What is the distance between them? L square plus Y square, and there is under root, but it will get square, so I have written as it is. And due to B, here is your B, what you will write? Again the same magnitude, nothing different, L square plus Y square. After that, once you will simplify it, both the vectors, there also I have drawn it, you will simply get the answer. Here you can see that what I have written, EA cos theta plus EB cos theta, the same components will get, parallel components will get add up, and perpendicular components will get. And finally, when you will solve it, you will have the result somewhat like this. But you don't have to remember this result. You actually apply the approximation that L is a lot greater than Y. This approximation is very important. And finally, result will be coming somewhat like this. But you can remember in a better way. The better way to remember it as equatorial position. The formula is written as this 1 by 4 pi epsilon naught can be written as what? K. This P is already written. K P divided by here R cube you can represent. Y cube was given. So this will be your answer. Last case, what was the result? 2 kp by r cube. In equatorial position, what is the result? Kp by r cube. One more thing about the direction. Let's discuss about the direction also. Here it will see the net electric field is coming in the negative x direction. If I will talk about, this is the direction for electric field. And when you will notice, the direction for dipole was in positive x direction. So always remember, whenever you are writing for electric field at equatorial position, the direction is exactly opposite to the direction of dipole. It is written in statements also here also. The direction of our electric field intensity at a point on the equatorial line due to a dipole is parallel, it will be parallel and opposite to the direction of dipole moment. These are the two important things that you have to always remember. One is what? The formula, how much the magnitude, and second one is direction. Then you can easily solve any kind of question. Now the next thing is torque. You have to understand about torque. Let's suppose I have kept the dipole in some electric constant electric field. Okay. What will be the, firstly talk about the net force. What is force? Force can be written as Q into E, Q into E. One force is in positive x direction, one force is in negative x direction. What I can say about the net force? Net force is going to be 0. But net force is 0, but torque will not be 0. Reason, now this torque will try to rotate this electric dipole in this way, and this will try to rotate in again clockwise direction. So now this electric field actually try to rotate this complete dipole, and we will see what is the net torque acting. You know the basic formula for torque. Torque basic formula is R cross F. That means force into perpendicular distance. If I'll ask you what is the force, what you can say, simple force is acting how much? Q into E. And what is the perpendicular distance? This is the distance. What is the distance? 2L. This component will be 12 cos theta. This perpendicular distance will be 12 sin theta. So what will be your torque formula? You can clearly see force into perpendicular distance. Q is what? Force, and this distance 12 sin theta is what? Force. Distance. So the result that you will find. Fine. Now about energy. If you are keeping any dipole in electric field, what is the work done? There is a you can write work done is equal to, because force is 0, that means you have to write torque into d theta. Torque is what? P sin theta into d theta. Then you have to integrate. Let's suppose you are rotating it from angle theta 1. This was the original dipole. Now you are rotating with theta 2. That means the integration limits will be from theta 1 to theta 2. After integration, you will have a term of cos theta, because integration of sin theta is what? Cos theta. So what is the work done? You will have P e cos of theta 1 minus cos of theta 2. This is a very important formula that you have to always remember. If potential energy is arbitrarily taken 0, so basically the formula that you have to remember is minus of Pe cos theta, and how it is written? U is equal to minus of P dot E. This is another form of cos product. You can write it as cos of theta. If someone asks you what is the total work done or change in energy, you will write how? U final minus U initial. What is the final energy? You can write final angle is theta 2, so you will write minus of Pe cos of theta 2 minus of Pe cos of theta 1. Now this will become positive and you can take Pe common. The final result that you will have is cos of theta 1 minus cos of theta 2. The same formula that you are having here, you can derive it by yourself. The concept is whenever it will be asked, you can easily do final potential minus initial potential. Now, one more important, firstly I will run all this. Three important conditions are there that you have to understand from this formula. One is stable equilibrium, second one is unstable, and third one will be neutral. Okay. So in 11th also we study about this. What is stable equilibrium? Simple definition, if I will tell you, stable equilibrium means minimum energy, unstable equilibrium means maximum energy. So according to this formula, U is equal to minus of P dot E. What do you understand? That when your energy will be stable, you will say stable equilibrium. That means potential energy should be minimum. And when you can have minimum potential energy, what is the maximum value of cos theta? 1. When you will put it 1, what is the potential energy you are having? Minus P. So it is the minimum energy that you are having, and this kind of stability is called as stable equilibrium. Now if I will talk about neutral, that means obviously your energy will be 0, it is called as neutral. Now what about unstable? Unstable is energy will be maximum. According to this formula, what the maximum value you can have? Put cos theta is equal to minus 1. If you are putting minus 1, net it will become how much? Plus of P. Plus of P, and this position is called as what? Unstable equilibrium. Now there is a question, calculate amount of work done in turning an electric dipole. Dipole moment is given, P is equal to 3 into 10 power minus of 8 coulomb meter from its position of unstable equilibrium to the position of stable equilibrium in a uniform electric field intensity. Electric field is also given to you. It is equal to 10 in 10 power 3 Newton per coulomb. Try to solve this question quickly. See, notice this question properly. It is position from unstable equilibrium to stable equilibrium. Now, quickly, just now we have discussed about equilibriums. When at what angle you are having unstable equilibrium? What was the angle? 180. And at what angle you are having stable equilibrium? 0. That means, what is the question asking? Amount of work done. How you have written amount of work done? What is the formula? Pe cos of theta 1. What will write theta 1? 180. That means, can I write this value also as directly minus 1? This value can also be written as directly minus 1 minus cos of 0. Cos of 0 is how much? 1. So how much you can write? This minus 1 and minus 1 will become how much? 2. That means a net answer you can write as 2 into P into E. Now P into E, just put the values. 10 power minus of 8 into electric field is 10 power minus of 3. Multiplication is there. Net you can write 3 into 2, 6 into 10 power minus of 5. This will be your answer. In joules you can put your answer. This will be the solution. The basically question I was asking from the condition of stable and unstable equilibrium. Now the next question. A given charge situated at a distance from an electric dipole in an end of a position experience a force P. Let's suppose a dipole is given to you. minus q charge plus of q charge. And at some distance x, let's suppose this is the distance, the force that is experienced is F. If the distance of charge is doubled, let's suppose if this x is made to 2x in the second case, what will be the effect on the force on the charge that you have to find? Check what will be, yeah, what you can do, how you can write force. See how you will write. Force can be written as what? In this complete topic, whenever I will ask you force, you will write force is equal to Q into E. Now, what is electric field on equatorial position? 2kp divided by r cube. Here it will be r cube. I can say that nothing is going to be changed. Only single thing that is going to change in this complete two cases is r cube. So what I can conclude from here, that my force is actually inversely proportional to what? R cube. So first force is, let's suppose I am saying as it is, force is inversely proportional to r cube, and the second force F dash, I will say it is inversely proportional to how much? 2r cube, because the second case what is happening? Distance is getting doubled. Now this is your equation 1, this is your equation 2. Just take the ratio, you will have your answer. Here I am writing. When you will solve it, you will have force divided by F dash is equal to 1 by r cube and 1 by 2r cube. It will become eventually 8. That means it will become 8 here. That means F dash, new force will be equal to force F divided by 8. That means by doubling the distance, the force is decreased by a factor of 8. Now next thing is relation between electric field and work done. Now see, there is a relation between electric field and work done that is given as work done is equal to force into displacement. This is a very basic thing from we know already from work energy theorem. Work done can be written as force into displacement, and the final formula that you will have is work done with AB is equal to given as Q naught. Actually, it can be more better written as K Q naught divided by R. And if there is a work done between changing the position from one position to another position, it can be, same formula can be written as 1 by RB minus 1 by RA. This is the basic thing that is given. The property of work done by, it is actually what? Path dependent. That means path dependent means if in a complete circle I am asking you, in a complete loop, the work done will be 0. Reason being, you can see from this position. Last case that we have seen here, this is the formula for work done. If I will say I am starting from a position A and I am taking a complete loop and again I am coming back at the same position, that means I can simply say my RA and RB both are same. If both are same, can you say both will get cancel out? If both of them will get cancel out, what is the work done? It is 0. So I can easily say it is a property of conservative force. If those students who have studied about work energy theorem, they know this is a property of conservative force, that work done is 0 in a complete loop. Rest of the things are property you can study. Now the next question is, a uniformly charged conducting sphere is there of diameter is given. That means radius how much you can say? 2.5 divided by 2. See what are the rest values given. Has a surface charge density, sigma is given 100 microcoulomb per meter square. First thing you have to calculate what will be the charge on the sphere. Second one you have to calculate is total electric flux passing through the sphere. Quickly try to solve it. See how to proceed this question. Surface charge density is defined as, actually if I will tell you, there are three kinds of densities, charge densities. First one is lambda, that is charge per unit length. Second one is sigma, that is charge per unit area, and the third one is rho, that is charge per unit volume. Here we are talking about surface charge density, that means we are talking about sigma. So what you can write for sigma? It is charge per unit total surface area. Total surface area for a what we are talking about, sphere. What is the total surface area for sphere? 4 pi r square. That means charge will be how much? The first part that we have to solve is equal to sigma into 4 pi r square. Just put the values, you will have your answer. This is the way to solve the first part. I am not solving. It will take a lot of time for solving this numericals. Now second part, what is the electric flux? Anyways, we have not discussed still about electric flux, but there is a very simple formula for electric flux. You know, for a charge sphere, it is Q enclosed divided by epsilon naught. From here, whatever a charge you will have, you will put the value and divided by epsilon naught. What is epsilon naught? You can write it also as 12. Whenever put the values, you will have the answer. Here is the solution. You can check. Firstly, you have written 4 pi r square into sigma. That will give you the charge. How much charge is coming? 1.96 into 10 power minus of 3 coulomb. And then once you got it, then put the same value here, 1.96 into 10 power minus 3 divided by 8.85 into 10 power minus 12. Finally, you will have the flux as 2.2 into 10 power 8. There is nothing in this question, only calculation part is little bit there. So this way you will approach this kind of questions. Now this was about the electric charges and fields. Now we'll understand about potential. Electric potential and capacitance is also along with it in NCERT. But in competitive exams, we study capacitance as a different chapter. So what is the electric potential? That is the definition firstly here. It is a physical quantity which determines the flow of charges from one point to another point. Electric potential at a point is defined as work done in moving. This point line is important. Without an extra unit positive charge from infinite to a point, that is against work done of electrostatic force. That means what I am trying to say. Let's suppose here is a charge kept and it will have some electric field along with it. And what is the work done in bringing a unit positive test charge? Let's suppose this charge is at infinite distance. The work done in bringing this unit positive test charge to a point P is defined as electric potential. And what is the formula for electric potential? It is represented as V. The formula is K Q divided by R. You can see here. Firstly, it is defined as work done by charge, and then according to definition, RA is infinite. Then when you will put these values, you will have it is defined as KQ. This formula can also be written as V is equal to KQ divided by R, or the same thing can be written as work done from 2 points divided by the charge. This is the formula for potential. What you can say about the units of potential? Anyways, it can be calculated in volts, but if I will talk about the units, what is the unit for work done? It is joule. Unit for charge, it is coulomb. So this can be the units. Same thing it is written. Either you can write it in joule per coulomb and Newton meter per coulomb. Both the units are valid. Now, if I will ask you about a point charge, what will be the electric or potential? It is a one important point about electric potential is it is a scalar quantity. So now we don't have to worry about directions. It is just we have to write the magnitude part. So that is better thing. So here their kind of question is there. How you will write all these points? So see, yeah, this is the point P, and here you have to write the electric potentials due to everyone. So how you will write? The net potential can be simply add up because it is a scalar quantity. You don't have to worry for direction Q1, Q2, Q3 like you have to do for electric field. How you will do it? So start writing. What you can write for Q1? You will write K Q1 because the formula is KQ by R. And what is the distance given? R1. Then what you will do? Come to Q2. You will write K Q2 divided by R2. Then due to 3 K Q3 divided by R3, and so on. You will keep writing. One thing will only be changing. Let's suppose if this is positive charge, then it is fine. It will be simply add up. And let's suppose if this is negative charge, a negative extra sign will be here at the place of positive. It will be always negative. So it will get subtracted. This is the only thing. Otherwise, there is no directions in this case. A general formula is also given here, but it is very common sense question. See, you can see that it is again superposition kind of thing. Electric potential at a point due to a charge is not affected by the presence of other charges, and V is inversely proportional to R. Potential is a scalar quantity. Already I have told you potential is a scalar quantity. That means you don't have to worry for directions. Now Electric potential due to group of point charges. Find the net potential at point, again the same kind of question. How will write at point O, what will be the potential? VO. Due to all these three charges, just quickly write K Q1 divided by R1 plus K Q2 divided by R2 plus K Q3 divided by R3. Simple as it is. The better part of potential is, again I am telling you, it is not vector quantity, it is a simple scalar quantity. Now again we will introduce a dipole and let's see what will be the effects of a dipole on potential, like the same ways we have did for electric field. So let's try to write. This is a dipole. Again I am telling you what is a dipole. A vector that is going from negative charge to positive charge, that is written as dipole. And at point P you want to calculate the distance, will also be given. The distance given is x. So how you will write the net potential at point P? So firstly write due to positive charge. Due to positive charge, what you will write the potential? What is the charge? Positive. How you will write? K Q divided by. Only thing you have to write carefully is the distance. What is the distance? This complete distance is x. This much is L. So how you will write it? It will be x minus of L. Due to negative charge, what you will write the potential? K Q divided by x plus L. And after that, just solve it. How you will write? K. Now just add up both of them. You will have the equation somewhat like this. And when you will solve it, the final result will be coming K. This complete value can be written as K Q into 2L divided by x square minus L square. Again, you don't have to remember this result as it is. You have, you can notice something. This, what is this term? Q into 2L. This is represented as P, and there is approximation that x is greater than a lot than L. So finally this result will become how much? K into, this complete term can be written as P divided by, you can neglect this term, this will be neglected as 0, and here it will become Kp divided by x square. This is the final result that you can remember. Here again it is written the same thing. There, this is the final result. But there is a better way for remembering that I have told you, Kp divided by x square. Now second position is equatorial position. On equatorial position, what will be the potential that we are going to write? See, it is also same. There is nothing special. Just simply write, pick one charge at a point at time and then try to write. Again I have told you the perpendicular distance, this point is called as what? Equatorial point. And distances are given, angles are given. Now let's write again. Due to positive charge, what is the potential? Here is the positive charge. What is the distance? This distance you can write. It is equal to L square plus y square. I will write the potential K Q divided by, sorry, not, it is K, actually should write like this, K Q divided by L square plus y square. And due to negative charge, how much you will write? Minus of K Q divided by, can you say distance will be same. And what is the final net potential you can write? Due to positive plus due to negative. Just write it. K Q divided by, due to positive, what is the distance you got? L square plus y square under root minus. Due to negative, how much you got? K Q divided by root under L square plus y square. Now when you notice it, both the values are actually same. That means they will cancel out each other, and the net potential at equatorial position is always, remember, it is equal to 0. For axial position, what is the potential? Last case, what was the potential coming? Kp divided by x square. At the equatorial position, what is the potential? 0. Same thing is written again. Electric potential due to electric dipole at the equatorial position is 0. Now potentials, if we are talking about potentials, we have to discuss about equipotential surface. What is equipotential surface? It is an imaginary surface. Let's suppose this is electric field. Uniform electric field I have taken, and I want a equipotential surface. Equipotential surface has a very basic property that every point on the equipotential surface potential is always same. That is defined as equipotential surface. Let's suppose I have taken a planar surface, like a page I have taken here, And I will say, let's suppose if at this point potential is 5 volt, that means at every single point on this equipotential surface, potential will be what? 5 volt. It is very much similar like wavefront. If you have studied, wavefront is very much similar like this. Phases are same there. Let's suppose I am saying that here it is 10 volt. That means what I can say, all the positions on this complete surface is called is will be at 10 volt, and these planes I called as, these are kind of planar bodies are there for a parallel lines of electric forces. Plane equipotential surface are there. For isolated charge, what kind of equipotential surface you will have? A spherical body. That means if you are going at the same distance from everywhere from the center, you will have the same potential on each side. Let's suppose if distance is x naught and this position is 5 volt, that means at every single point the potential will be 5 volt. Now there are lots of equipotential properties that we have to study. It is already defined. We have already seen the formula that potential is defined as work done by AB divided by Q naught. So what will be the work done on the equipotential surface? I can easily say 0. Reason? If I am saying, yes, suppose this is the equipotential surface. This is the equipotential surface. This is the point A. This is point B. And what is the formula written? Change in potential can also be written as what? VB minus VA. So when you do VB minus VA, can you say both are actually equal? Reason, it is a kind of equipotential surface. That means VA minus VB is actually same. That means can I say both of them are going to be cancel out. That means this complete term will be 0. That means I can also say work done in taking the charge from point A to B is equal to how much? 0. This is a property of equipotential surface. You can see here this work done will be 0. Second most important thing, the electric field lines is always perpendicular to the element dl. That means, let's suppose again I am drawing a equipotential surface, planar surface, and if this is the line of electric field, there is a property that these lines will always be perpendicular to the equipotential surface. Basic properties. Two equipotential surface can never intersect each other. Reason, again similar. Why two equipotential surface can never intersect each other? Let's suppose this is one equipotential surface, this is second equipotential surface. They can never intersect each other because potential at a single point cannot be possible. Like if I am talking about this point, it is never possible that V1 will be equal to V2. Potential will always. Now electrostatic potential energy. From potential, it is defined as potential energy also. How it is defined? You have seen that definition of potential was given as work done divided by charge. Just few minutes back I have told you. That is when work done can be written as V into Q. And what kind of formula you will have? You can easily derive from here. What you can write for work done? What is this is Q. What you can write for potential? What is the formula? K Q divided by R. So what is the work done formula? You will write. It is equal to K Q small q divided by R. Here it is written equipotential surface can also be written as this complete term. This complete term is K Q1 Q2 divided by R, distance between them. Let's suppose the question will be asked for three charge system, how to write equipotential or the potential energy. Always remember potential to make pairs here also. Of potential potential energy, it is K Q1 Q2 divided by R. And let's suppose here I am taking a equilateral triangle. Okay. So how I will write the potential energy? Net potential energy will be written in pairs. Firstly, I will write due to charge 1 and 2, then I will add up. Then I can write potential also due to 2 and 3. Then I can write potential due to 1 and 3. So always remember, whenever I am writing potential energy, it is always written in pairs. So let's start writing one by one. Due to 1 and 2, what is the potential energy? You can write K Q1 Q2 divided by A plus. Due to 2 and 3, what is the potential energy? You will write K Q2 Q3 divided by A plus K Q3 into Q. What are the last case left? 1 and 3. 1 and 3 divided by A. Very good. Thank you. और आगे बैठ के बात मत करो, ठीक है? मेरे को डिस्टर्ब हो रहा है. So this will be the final answer. Potential energy can be written in pairs. Now flux. The next thing that you have to understand is flux. Flux is simply defined as the number of electric lines of forces is passing any cross section. You have any page paper? किसके पास है? Thank you. See how electric lines of flux or flux is simply defined. Let's suppose I have taken this cross sectional area. So number of electric, let's suppose this kind of positive x direction is the direction of electric field. This is the direction of electric field going. And number of electric lines of forces passing through this cross sectional area. Let's suppose this area is A. So that is defined as what? Electric flux. It is a very simple thing. It is a scalar quantity. It is simply represent the how many number of forces, number of electric lines of forces are passing through a cross sectional area, and it will always be again perpendicular to the surface. क्या क्या वाईफाई से मेरे को बता दिया करो, मैं बिना मतलब का 3-4 घंटे बाद तुम्ही लोग पढ़ाना हो रहा है. So next thing is electric flux. That formula that is directly I am telling you will be E ds cos of theta. And what is this angle? This is the electric field here shown, and I have taken any random body. The angle between the area vector and the electric field is called as theta. Let's suppose here the area vector. Area vector is what? It is a perpendicular vector to the surface, and the angle between them is theta. Here what is the angle between them? 90 degree. If cos 90, what is the value of cos 90? What is the value of cos 90? If the angle between the area vector and the electric field is perpendicular, that means the answer will be electric flux is a scalar quantity, but it is a property of vector field. SI units are also mentioned. Now from electric flux we define Gauss theorem, very important theorem in complete electrostatics. Most of the questions are asked from here, and in boards exam specifically they will ask you the proof of Gauss theorem for any kind of body they can ask. And what is Gauss theorem says? The surface integral of electric field intensity over any closed hypothetical surface is equal to given as Q enclosed divided by epsilon naught. This is very simple and very important term that was given in this Gauss theorem. Let's suppose what is the meaning I will tell you. Let's suppose I have taken any random Gaussian surface. Gaussian surface is an imaginary surface, and let's suppose I have taken 4 coulomb charge, minus 2 coulomb charge, plus 2 coulomb charge, and I am asking you what is the net flux passing through this imaginary Gaussian surface. Highlight what is according to Gauss, what is flux? Q enclosed in the Gaussian surface divided by epsilon naught. What is the net charge that is enclosed in this Gaussian surface? Plus 4 minus 2, that means net it is how much? Plus 2 microcoulomb or coulomb, whatever you have taken, it will be coulomb divided by epsilon naught. This is the flux. Then there is a proof for a spherical body that can be asked in boards exam specifically. Here is a body. This is the area vector, and electric field is also defined in the same direction. You can see it is written E dot ds is equal to kq square by r. Electric field is defined kq by r square, and there is a ds vector that is defined here. Now you can see both are in same direction. That means the directions will be r dot n is going to be 1. Here you can see r dot n is equal to 1. And then further, when you will integrate this complete area, how much the total surface area for this Gaussian surface? It will be equal to 4 pi r square. When you will solve it, electric field is this complete term. The integration of area is 4 pi r square, and it is equal to q by epsilon naught. So this is the proof that you have to remember for Gaussian surface. Simply you can see here this 4 pi r square and this 4 pi r square will get cancelled out. Final resultant will be left only is q by epsilon naught. Now try to solve this question. Electric field is given 2 into 10 power minus 2 into 10 power 3. Find flux of this field through square or side. Square side is there. 20 centimeter whose plane is parallel to yz plane. What will be the flux through the square? The direction for electric field, and the flux through a square of side. This, let's suppose this is the square of side. 20 centimeter is the side, and this is making an angle of 30 degree with the x direction. This is the plane. Assume there is a 3 dimensions x, y, and z. This electric field is going in x direction. This is a plane lying in y and z plane, and it is making how much angle with x direction? 30 degree. And what is the formula for flux that you have studied? It is equal to E ds cos of theta. Can you say you can easily write area for any square? What is the area for square? It will become a square. Electric field, can you say it is already given? Only thing you have to write is what? Cos theta. So can you tell me what will be the cos theta here? That means you are using what? Cos of 30. What is cos of 30? You should use cos 30 or you should use cos 60. Imagine it. This is your x-axis and your plane is making how much angle? 30 degree. Plane is making 30 degree, but the angle that you will have, the area vector, if I will represent it in, this is your electric field, this is the plane. This is making how much angle? 30 degree, but the plane is perpendicular. This is the area vector, I will say. Area vector is always perpendicular to the plane. So once you have put the value 60, you will have the correct answer. Oh, I have to put. So वाईफाई छोड़ो, मेरे गले को क्या हो रहा है? वाईफाई तो आ जाएगा, मेरा गला गया तो फिर कहाँ से आएगा? छोड़ो यार, कैंसिल करते हैं. तुम लोग रुको, तुम लोग बताते हैं. So once you have put the values, a is equal to 20 centimeter and the angle I have told you, the angle you will put is 60 degree. The final answer that you will have is flux is equal to 40. That will be the answer. Now applications of Gauss theorem, you can you know that Gauss theorem is used for finding lots of electric field, like for infinite wire. This is an infinite wire carrying a charge, or current will be flowing. How to calculate electric field due to that infinite wire? So first thing is always assume a Gaussian surface. We have assumed a cylindrical Gaussian surface, and we will see how to find electric field. What is area vector for this surface? If I will talk, this is the perpendicular to the surface is called as area vector. This is the direction for electric field. This is the again area vector for surface B. Although in complete the dimension there are 3 area vectors. So what will be the effect of all these things? You have to add up them. Now see here, what is the angle between area vector and electric field? 90. Here 90. That means can I say both are waste? Answer will be 0, because our formula is E ds cos theta. That means this is 90. That means 0. Only single will be come into use, and that is what? Theta here is what? How much? 0. This is the area vector, this is the electric field. So when you'll add up all those three, the two values are going to be 0. Here you can see 90, 90, and here it will become 0. This value will become 0. This value will become 0. Only addition will be for E ds cos of 0 and ds. What is the total surface area for a cylinder? 2 pi RL. So 2 pi RL will be the final your result for surface area, and then when you will write it, the final result that will be coming, it is in the terms electric field for infinite wire is how much? 2k by 2k lambda by r. You can rewrite the complete term like this. This you can multiply here 2, divide it also by 2. You can also rewrite this as 1 by 4 pi epsilon naught 2 lambda, and in denominator already we have taken, this is 2 lambda by r. This complete term is represented as k. Here it is 2, it is lambda by r. This is the electric field due to infinite wire, 2k lambda by r. So again it is represented in vector form. For vector form already I have told you, you just have to multiply the complete thing by a unit vector, that will give you the result. Direction, if I will talk about direction, direction of electric field intensity at any point will be radially outwards from the position of the line. Now next thing you have to derive this electric field due to infinite long sheet. Let's suppose you are taking a sheet, I can take the reference of this sheet. Let's suppose this is an infinite sheet and you have to calculate what is the electric field at a very close point, I will say, that's why it will behave like an infinite sheet. So again I will take firstly a Gaussian surface. What kind of Gaussian surface I have taken? It is cylindrical, and again I will see what are the angles between electric field and the ds vector. So firstly I have taken a point A. Here what is the angle between them? 0. Then surface B, this is the ds vector, this is the electric field, that means what is the angle between them? Here also it is again 0, that means they are of use. And here this is the area vector, this is the electric field, what is the angle between them? 90. That means this is not going to help in the finding the final electric field. Now if I will write about the equation E dot ds, it will get add up from all these three surface, E dot ds, E dot ds, E dot ds, from all these three surface A, B and C. I can say at C surface the result will be 0. Rest of the points you will write E ds cos 0, E ds cos 0, it will get simply add up, it will become 2 E ds. Now you will integrate this complete term, it will become, this cross sectional area is only contributing for this electric field, that's why this integration will give you how much? Pi r square, and when you will write this complete term, sigma pi r square divided by epsilon naught, it is equal to q by epsilon naught. So finally electric field will be how much? The standard result that you have to remember is sigma divided by 2 epsilon naught. Remember, when I am talking about a conductor, in conductor this property is actually changed, because we will talk about capacitors also in the end, because in the center of the capacitor this net electric field is not q by 2 epsilon. This electric field is due to single parallel plate. So what will be the electric field due to a single plate? Q by epsilon naught. But if I am talking two plates, that is two conductors, this electric field will become q by epsilon naught. Sorry, here, so it is sigma by epsilon naught. 2 sigma by epsilon naught. It is actually from a single plate. Let's suppose, what is the electric field? You will write sigma divided by 2 epsilon naught. But when I am taking two plates, let's suppose this is positive plate, this is negative plate, what is the electric field will become in the middle? Sigma by epsilon naught. The same things are written here. If you are talking about a conductor, what will be the electric field inside? Sigma by epsilon naught in between them. Now next thing is spherical shell. Shell means I am saying that all the charges are only on the surface of the shell. And let's suppose firstly I want to calculate for outside point, any outside point P, that is outside from the center. If I will talk this distance, this small r is greater than capital R. What is the method? Simply draw a Gaussian surface. This is the Gaussian surface, imaginary Gaussian surface, and try to write the equation. What you'll write? E dot ds is equal to net charge, that is enclosed, divided by epsilon naught. Tell me, in this Gaussian surface, what is the net charge that is coming? Can you say total charge is coming inside this Gaussian surface and total charge is given as q. So in this side I will write q divided by epsilon naught. Then you can see there will be coming 4 pi r square, the total surface area of a sphere, and when you will make it, this result will be somewhat like this, and this can also be written as, this complete 1 by 4 pi epsilon naught is how much? K. That means the result will be kq divided by r square. This is for outside point. Always remember, for outside point. That means if I will talk about inside point, what will be the electric field? Inside a spherical shell, what is the electric field? Zero. Reason? Let's suppose I am talking about this point inside. What I will do first step is draw imaginary Gaussian surface to Q enclosed. What is the net charge enclosed inside the Gaussian surface? Zero, because all the charges are only on the surface. That means electric field will become how much? For inside surface, zero. This is the result that is written for the same thing. For at a point inside the cell. Inside the cell, you will say, let's suppose this point is B, distance is R. You will draw Gaussian surface R. This is ds vector E. From Gauss law, you will write the equation, and the final answer that you will have is 0. The final answer is 0 because there is no charge inside a shell. All the reasons are written here. That is what kind of curve you will have. If I will talk about from inside till outside at any point P, what kind of curve we will have? There will be a intermediate point, R is equal to capital R. For inside, what is the electric field you are having? 0. That means, can I say this complete value will be 0? And after that, outside point, what was the formula? KQ by R square. That means at outside point, at surface, how much it will become? At surface, it will be KQ divided by capital R square, and after that, it will continuously, it will start decreasing. This kind of curve we will get. See, it is represented like this yellow line. This kind of electric field will be getting. I want a break. So you are stop करो. मेरा गला. So now we'll have 2 minutes break. Okay, then we'll start capacitance. The next topic is capacitance. Capacitance is basically about a conductor we are talking about. What is the capacity of a conductor to hold charges is called as what? Capacitance. You can see the definitions also. The measure of the ability of a conductor to store charge is called as what? Capacitance. From the name itself, it is very clear. And for the formula, charge in this complete chapter of capacitance, we are only going to talk about charges. There is no current. We are only going to talk about charges. So charge will become very important for capacitance. We define that Q is directly proportional to potential. And when we remove any proportionality, you will know that there is some constant. That means Q is equal to CV. Here C is what? This C is defined as what? Capacitance. And that means you can say about C, what C is equal to Q by V. That means what about the units if you know this formula? Charge can be written as coulomb, V can be written as volt. So this will be the about the units. Here the definitions are there. But the standard units that we use in capacitance is actually what? Farad. And most of the times this value is in micro. Microfarads is the standard value that we always use. Now, the most important kind of conductors that we are going to study is parallel plate capacitor. Parallel plate capacitor means there will be a diagram also. This is the first plate and this is the second plate. Both of these plates are parallel, and now this parallel plate will hold some charges along with it, and that we are going to call it as parallel plate capacitor. The definitions is given here. We are interested in what is the value and what is the formula for parallel plate capacitor. The final result that you will have is C is equal to Q by V, and the final result that you will have is C is equal to A epsilon naught by D. What is A? A is called the cross-sectional area of the parallel plate. For both of them are identical plates. The cross-sectional area is A. Epsilon naught already you know it is what? Permittivity of a medium. D is what? Distance between these two parallel plates is called as what? D. That is represented as D. So finally result will be A epsilon naught divided by D. Let's suppose if you are feeling any medium, like currently it is air, but now I have introduced some medium along with it of refractive index, not refractive, epsilon r, that means relative permittivity I have given you. So what will a dielectric constant also it called? Just multiply epsilon naught divided by epsilon r. So how also it can be written? Let's suppose in air what was the capacitance we have written? A epsilon naught by D. But if I am writing for medium C dash, I can write it as A epsilon naught into epsilon R divided by D. What is this A epsilon naught by D? This is nothing but capacitance in air into epsilon R. So whenever the question is asked for writing in a medium, just multiply the capacitance in air by epsilon R, relative permittivity, you will have the answer. Here it is written directly proportional to the area. You can see I can say that capacitance is directly proportional to area, inversely proportional to deep distance between the plates, some basic properties. Now about the combination of capacitance. If capacitance are connected in series, what is the formula? Bolo. If capacitance are connected in series, the formula that is used is the formula of parallel. So what I can write the net formula? It is equal to 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Always remember this. And let's suppose the same thing will be represented here also. What are the properties I can say? Here we don't talk about, again I have told telling you current, we are talking about charges. So whatever the charge on this C1 will be, it is equal to C2 and it is equal to C3 because the same charge is flowing through all this. So the first property is charge is same on each capacitor. Second one is what? Potential is distributed in inverse proportional of the capacitance. And the next one is, you can see charge Q is distributed on all these capacitors. And the derivation for this same formula 1 by C equivalent can be written as V is equal to V1 plus V2 plus V3, and then I've written the formulas, and the final result will be coming from here 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Next type of combination is parallel combination. That means three capacitors again I have taken, and these three are in this time parallel. This time what I will say, charge is same or the potential is same. I will say this time potential is same. We have the liberty to point any point at zero potential. That means this will become V. That means this will become 0, 0, 0, and this will become V, V, V. That means this time what I will say, whatever the potential difference across C1, it will be same across C2, it will be same across C3. Using this property, the potential is same across each capacitor. Using this property, now this time we will derive the Q can be written as Q1 plus Q2 plus Q3, and the formula for charge is C into V. When we will add up all them, we will have the final result as C equivalent is equal to C1 plus C2 plus C3. Now there is a question, try to solve it. We'll take one session for comments. Now see how to solve this question. You will see there are 4 capacitance. These 3 are connected in what kind of combination? Series. And these 3 series is connected in parallel from this 2 microfarad. So let's solve it. First thing you have to calculate what is the equivalent capacitance of the network. What you can say about the equivalent capacitance? About these 3, how much you can say? What is the equivalent capacitance? 1 by C equivalent can be written as how much? 1 by C1 plus 1 by C2 plus 1 by C3. That means you can write 1 by 6 plus 1 by 6 plus 1 by 6. Eventually this is going to give you C equivalent of these 3 section is equal to 6 divided by 3, that is 2 microfarad. Now I will say that at the place of these 3 I can draw a single capacitance, that is 2 microfarad, and this 2 microfarad are parallel. Parallel, what kind of formula we use in 2 parallel series? That means can you say a final answer that I will get from all these, what will be the C equivalent? Can you say it is equal to 4 microfarad? This 3 combination was 2, this is 2, these 2 are in parallel, that means the net C equivalent will be coming 4 microfarad. So this is the first part answer. Now about the second part. The charge on each capacitor. Firstly calculate what is the net charge. What you can say about the net charge that is flowing? How you can write the net charge? Can you say it is equal to C equivalent into V. What is the C equivalent? 4. What is the EMF of the battery? 6. That means what you can say? What is the net charge that is flown? 24 micro coulomb of charge is flown. Now I can say that this complete system is 2 microfarad and this complete system is 2 microfarad. You know that complete charge that is flown from this system is 24 micro coulomb. So now how it will get distributed? I can say both of them are parallel. That means I will say it will distribute it from here, and how much they will distribute? If 24 microcoulomb is there, that means I will say plus 12 will be going to this section and plus 12 will be going to this section. This way charge will be distributed. Same way you distribute the currents also in current electricity. So the charge on each capacitor you can easily write by this way. Here is the solution. You can see finally the net capacitance is coming 4 microfarad and the net charge on each capacitor is given as 12 microcoulomb and 12 microcoulomb distribution. Now what is the energy in capacitance? Energy is defined as half CV square. The basic formula that you have to remember, the complete derivation and the formulas are also there. So after integration the final result that will be coming is half CV square, and the second formula that is very important also is two formulas that you have to remember for energy in a capacitor. Half CV square is the first formula, and the second formula also that is used is Q square divided by 2C. These two formulas are important. Now there is a question, again try to solve it. First part is all the capacitance are 1 microfarad. All these are 1. First question is find the charge. Second one is energy stored. And before that find equivalent capacitance. Basically the question is asking you 3 parts. What is C equivalent? Second part, what is charge flown? And third part, what is the energy stored? Try to solve it. Pani ka? Water. Oh my god, thank you. So let's see how to solve this question. It is a combination of 5 capacitors. Anyone have the hint how to solve this question? Combination of 5 capacitors is there. How will resolve this? For 5. First step will be anyways find the equivalent capacitance. How you will find equivalent capacitance? What is the equivalent capacitance you can say? That means series combination, parallel combination, what kind of combination? Actually, if you'll notice this is a Wheatstone bridge, correct? Wheatstone bridge have the how many components are there in Wheatstone bridge? 5. And when you'll notice this one, this by the ratio of, let's suppose I will name this C1, C2, this is C3, C4, and let's suppose this name is C5. When you know the condition for Wheatstone bridge is what? C1 by C2 should be equal to C3 by C4, and this condition is also fulfilled, and we call in this kind of cases this capacitor is a base. That means you can simply remove this capacitor. If there is no connection for this capacitor, now what you can say, these two will become in series, these two will become in series. That means if I will redraw this diagram, this is C1, C2, this is Y, and here again it is. Now you have only two capacitors, all the values are 1. What will be the equivalent capacitance of this section? Can you say 1 in series? That means equivalent capacitance will become half. Here also it is half. That means equivalent capacitance again it will become parallel. So equivalent capacitance how much I can say? 1 microfarad. First part answer will be 1 microfarad. Wait. This is in series. That means the formula will be for. The value is given how much? 4 microfarad. This section and this section will be drawn like this. This was the C5, that will be now 0. So simply you can remove this section also. Is it coming correct or not? That means now these two will behave like a, if I am taking this as a parallel, that means it will become, no, answer is correct. C equivalent will be coming how much? 1 microfarad. Now second part is what? Charge flown. If I have to, I am rubbing this for a moment. How much charge is, net charge is flown through the system? Q is equal to C equivalent into V. What is the C equivalent? 1 microfarad into what is the potential difference between X and Y? 6 volt. That means what is the net charge? It is equal to 6 microcoulomb charge that is flown. This is the second part. Now third part, what is the answer? Energy stored. How much energy is stored? It is equal to half C equivalent into V square. What is C equivalent? C equivalent you have calculated 1 into V square, that is 36. That means net answer you can write 18 microjoule. Micro will be there in the answer. 18 microjoule will be the answer. Simply 3 formulas that we have studied according to that question is there. Now the next question, a capacitor of unknown capacitance is connected across a battery of V volts. A capacitor, unknown capacitor is there and it is connected by a battery of volt V. The charge stored in this case is how much? 360 microcoulomb. When the potential across the capacitor is reduced by 120 volt, second case V is reduced by 120 volt. Now what is the condition given in the second scenario? The charge stored, it becomes 120 microcoulomb. The charge that is stored is 120 microcoulomb. Calculate the potential V and the unknown capacitance C. You have to calculate what is C, what is V. What will be the charge stored in the capacitor if the voltage applied increased by 120 volt? Try to solve this question. See, what is the relation you know? How you can proceed this question? First case, what is the charge stored? 360 microcoulomb. What is the formula for charge? Q is equal to C into V. And what is the C? Let's use this. This is C, this is V. Second case, what is given? Potential is decreased by 120 volt. And how much charge is stored? 120 microcoulomb is stored. C is also same. C is same. And potential in this case is decreased by V minus 120. Now it will behave like this is equation 1, this is equation 2. Take the ratio, equation 1 by equation 2, what you will get? Here it will become, I can say it will become 3. On the right hand side, what it will become? In numerator it will become V divided by C. C will get cancel. V minus 120. Now when you will solve it, how much it will become? 3V minus 120 into 3, 360 is equal to V. That means I can say 2V is equal to 360. That means I can also say V is equal to how much? 180 volts. First answer. Yep. Now what is the second question? How much? C, equivalent capacitance. So you can use this relation, equation 1. Now you know what is the value of V. What is the value of V? 180. And here how much it is? 360. That means from here, what you can say about this capacitance? Capacitance can be written as 360 divided by 180. How much it is? 2 microfarad. Second answer. Now the next part of the question is asking what will be the charge stored in the capacitor if the voltage applied had increased by 120. Initially what is the voltage applied? 180. Now new voltage will be how much? Plus of 120. That means it will become 300. And now what will be the charge stored? Simply I can do here also it is written charge, net charge, the second part I am solving. Q is equal to C equivalent into V. C equivalent is equal to 2 and what is the potential? Finally 300. So what is the final charge that will be stored? 600 microcoulomb. You can see here 180 volt was the first answer. 2 into 10 power minus 6 or 2 microfarad you can write, and the final answer is 600 microcoulomb. Correct. So simple formula based questions are there. Now the next chapter is current, electricity. We have studied about charge till now. Charge was at rest. We have seen electrostatics, incomplete electrostatics, charge was at rest. We have seen capacitor. Capacitor also there was no charge in moving. But now we will see current, electricity. How current is defined? What is current? Basic definition of current is what? It is defined as rate of charge of flow of current. That means it is the definition itself. Now charge will start moving, and when charge starts moving, what it will induce? It will bring current into action, and now we are going to understand what is current and what are the effects in any kind of circuit. We will see lots of. Here is firstly the basic definition. Current is defined as the charge flowing through any section of the conductor in 1 second. I is equal to Q by T or I is equal to dQ by dt. Rate of flow of charge varies with time. This is the basic definition. From basic classes we are understanding. Now there are different types of current also. How many types of current are there? 2. One is alternating current. Second one is DC current, direct current. So what is the property of direct current and what is the property of alternating current? Direct current is actually, it is always positive, either it is always negative. Like if I am saying this is a wire and this is the direction for current, then is what you will say that current is always flowing into the same direction, but it is not same with alternating current. What is the property of alternating current? Let's suppose if this is the wire, alternating current will be sometime flowing in the positive direction, sometime it will flowing in the negative direction. It constantly changing its direction. You can see from the here also. I can say current A, B and C, all these three are behaving like what? DC current. And when you notice current D, it is behaving like what? AC current. Because if I will talk about this section, current is what? Positive. If I will talk about this section, negative, again it will become positive, again it will become negative. In alternating current chapter, again there is a separate chapter for it. As of now in this chapter, we are going to understand only about direct current that we have to analyze in the circuits, or also we call it as conventional current. Now one very important formula before starting this topic of drift velocity and the drift current. The definition is given. Drift velocity is defined as the velocity with which free electrons get drifted towards the positive terminal under the effect of applied electric field. What happens actually, there are lots of free electrons are here, and let's suppose you have applied it by battery. What will happen? One will become zero potential, another will become V. That means, can you say this will behave like higher potential, this will behave like lower potential. If there is a potential difference, can I say electric field also will introduce? And what is the direction for electric field? Higher potential to lower potential. It is shown here also. This is the direction for electric field. Now, whenever electric field come into action, it will bring force along with it also. Let's suppose I am talking about any charge. What will be the force? What is the force magnitude? Q into E. That means this is the direction for Q into E. But you have to remember that these are electrons. Electrons means charge is negative. That means it will change its polarity, and the net force, that is effective force that will applied, is not in positive direction, it is in negative direction. If some force is applied on this charge in negative direction, that means it will introduce some velocity also along with it, and that velocity is called as what? Drift velocity. Drift velocity is actually defined as, you know, the formula of v is equal to u plus at, and we assume that average initial velocity is always 0 in a random direction. All the velocity vectors cancel out each other. So final formula that is left is vd is equal to acceleration into time. It is represented as tau, real acceleration time we call it. So how you can write acceleration? Simply, what is the force that you have said? Q into E. And if I will divide the force divided by mass, I can write simply it is what? Acceleration into time. So you can see this is defined as here also it is defined the same thing. Q into E, that is at the place of charge they have written E, and it is defined as divided by mass into tau. This is the definition for drift velocity. And from drift velocity, the current that is defined is very important formula. I is equal to eta A E Vd. Now here what are the terms? What is Vd? Drift velocity. E is what? Electron. A is what? This cross sectional area. This cross section area of the wire that you are taking is defined as A, and eta. Eta is called as charge density. What is charge density? Number of charges per unit volume is defined as what? Eta. Number of charges per unit volume. So this formula is very important. I is equal to eta A Vd. All these representations are written here. Now there is a basic questions regarding that. Two conducting wires I have given you, X and Y, of the same diameter but different materials, joined in series combination across a battery. If the number density of electrons is twice, that means eta is given, eta of X is equal to 2 times of eta of Y. Find the ratio of drift velocity of electrons in the two wires. That means you have to find the ratio of drift velocity of X divided by drift velocity of Y. Try to solve this question. What will be the ratio coming? See how to simple formula based question. What kind of combination is given into the question? Series. You know the property of series combination? Charges that are flowing in series combination is always same, or current flowing into the system is same. So I will say that whatever the current that is flowing through X wire, it is same as flowing through Y wire. What do you know by what you can write the property or the formula? Eta of X A into E into drift velocity of X. It is equal to eta Y A into drift velocity of what? Y. Now what are the things that are getting cancelled? A E will get cancelled. What you have to calculate? Drift velocity of X with respect to drift velocity of Y, and how much I can write? It is equal to drift velocity of X by Y. I can be written as simply eta Y divided by eta X. Now you know what is the value of eta X? Eta X is also is equal to 2 times of eta Y. In numerator what is there? Eta Y. Simply eta Y will get cancel out, and what is our final answer that is coming? 1:2. Now next basic term is current density. Current density means it is represented as J, defined as current per unit area is defined as current density. There is the definition also for current density. Current density of a point within a conductor is the important point is current current through a unit area of the conductor around that point, provide the area is perpendicular to the direction. And the formula is, again I am telling you, J is the representation for current density. It is equal to current per unit area. And what is the formula for I? You know, it is equal to eta A E VD divided by A. So this A will get cancelled out. And what is the formula also you can write for J? Eta E VD. Then there is Ohm's law, basic law that you know already. What is Ohm's law? V is equal to IR. From where it is derived? The equation says that V is directly proportional to current. And when we remove any kind of proportionality, what is the relation we get? When we remove this proportionality, what I will have? Resistance, and that R is represented as for what? Resistance of a body. What kind of curve, if I'll ask you, V versus I? V versus I, what kind of curve I can say? Can I say if it is equal, see, what is that y-axis? V. What is that x-axis? I. This is at y-axis, this is at x-axis. So what kind of curve I am having? Y is equal to mx. Y is equal to mx is what kind of line? Straight line. And if I will ask you about the slope, what is the slope of this line? What is the slope of this line? I can easily say it is R. Same thing, it is represented here also. Now the next thing, resistance, a basic term that we are studying from basic classes. What is resistance? What is resistance? It is the opposition offered for the flow of current is defined as resistance. Resistance of a conductor is the opposition offered by a conductor to the flow of electric current through it is defined as resistance. And we already know the formula, resistance is equal to V by I. Now resistance, basic formula we know, but we have to understand the formula in terms of this physical terms also. That will become a very important formula, and the final result for this term is what? R is equal to rho L by A. So from where it is derived? Firstly we have written I is equal to what? Eta A VD. VD, I have told you how to write VD. Force divided by mass into tau. We have seen from there. That means net I is equal to, I can write with this term. And then what I have taken? I have taken this V and this I as the ratio. V by I, and I have taken this complete term on the other side. What is V by I defined as? It is actually nothing but R, and R is what? Resistance, and it is equal to M eta E square tau. This complete term is called as what? This is represented as rho, and this complete term was defined as resistivity. The property of a material, it is defined as resistivity. So better if you are removing this formula also of resistivity, and the final number is R is equal to rho L by A. Here it is written rho resistivity, or also the different term is also given as specific resistance. It is equal to mass by eta E square T. There the proportionality is given. Resistance is directly proportional to the length, inversely proportional to the cross-sectional area of the conductor, and depends on the nature of the material. Nature of the material means I am talking about this resistivity. This is the property of a material. These are some important terms about it. Now the very basic thing, series combination and parallel combination. In series combination, what is the formula? R1 plus R2 plus R3. But more important than formula, what is the property? Charge flown through R1, sorry, not charge. Now we are talking about current. Now charge was only in the capacitance. Now whatever the current flowing through R1 is the same current flowing through R2, is the same current flowing through R3. And the final result is what? R equivalent is equal to R1 plus R2 plus R3. Second kind of combination is what? Parallel combination. What is the formula? 1 by R1 plus 1 by R2 plus 1 by R3. But more important than that, what is the property? Let's suppose if I will connect this by a battery. Here it is. Let's suppose I have connected this by a battery of voltage V. What I will say, this potential will be 0. This potential will be V. If this is a V, this is also V. If this is V, I can say all these 3 points are also V, and all these points are 0. So parallel combination have the property that potential difference across R1, R2 and R3 is same. This is the most important thing. Now basic question. Two identical slabs are being given of different same material. It is given metal are joined together in two different ways as shown in figure A and B. What is the ratio of resistance of these two combinations? You have to find the resistance of A divided by resistance of B. Try to solve it. This view is visible. आओ तुम लोग भी खाओ. ब्रेक नहीं देंगे क्या यार? See, first case, what kind of combination it is? What kind of combination you say for this one? Series combination. Second one, it is parallel combination. Simply, what will be the, for this section, how much resistance you can write? Rho L by A. Length, let's suppose L, and area is, cross section area is A. For this section also, so what you can say about A? What is the equivalent resistance? Two resistance of equal values connected in series, the net resistance will be 2R. For the second one, what is the R equivalent you will say? It is R by 2, 1 by R plus 1 by R. So just take the ratio. What will the answer come in? It will be equal to 4:1. So this is the answer also given. 4:1 will be the correct answer. Basic formula based question. Now we will talk about EMF. EMF is nothing but the chemical properties of any electrode that you take. Electromotive force is the maximum potential difference between the two electrodes of the cell. Electrodes of the cell, now it is majorly a part of chemistry. In electrochemistry, you understand more importantly about it. We only talk about the what is the effect of those two electrodes. That term that we define here is EMF. Now there is a difference between EMF and potential difference. A complete difference is written here. See, potential difference is the difference of potential between two any points in the closed circuit. It is defined as potential difference. But what is the EMF? EMF is always given for the battery only. So here, whatever the potential difference across the battery is defined as what? EMF. But what is potential difference? Let's suppose I have taken a resistance, and let's suppose this point is A, this point is B. So if I will ask you what is the potential difference across this VAB, it is not EMF, it is actually potential difference. And let's suppose here it is the same point A, here it is the same point B, and if I will ask you VA minus VB, here this VA minus VB is actually nothing but EMF. So this is the basic difference that you should understand between potential difference and EMF. Now every EMF is coming, or any battery is coming with internal resistance. Internal resistance is represented as small r in a kind of combination. Now let's suppose I have connected series combination for batteries. 3 EMF I have taken with internal resistance. This small r is representing what? Small r is representing internal resistance. Here also internal resistance, or here also internal resistance. And all these three are connected in what kind of combination? Series combination. Now the question will be asked, what is E equivalent? What will be E equivalent? How will you write for series combination? What is the formula? It is simply E1 plus E2 plus E3. That means E equivalent can be written as 3E. And if I will ask you R equivalent, what you can say for R equivalent? There is nothing special about internal resistance. It is also a kind of resistance. Simply what is their combination? Series combination. So R equivalent can be written as R plus R plus R. That means net resistance can be written as 3R. Let's suppose if I will connect n number of EMF into series. So what is the resultant? You will write n into E, and for resistance how much you will write? N into R. So simple basic thing in series combination. So same thing is represented here. Total EMF of battery is N into A for n number of identical cells. Total internal resistance of the battery is N into R for n number of resistance. So total resistance, how much you can write? In this circuit, if you will notice, how many internal resistance are there? 3, and it is called as what? External resistance. So total resistance, so how much you can write? N R plus R. Okay. And current, if I will ask you, how much current you will write? What is current? Definition of current? It is net potential. I should write it as potential. Net potential divided by net resistance. What is the net potential of this complete system? It is 3 into E divided by, what is the net resistance of this system? 3R plus capital R. The second part is more important for parallel combination. What is the formula for parallel combination? Let's suppose again the same kind of 3 batteries I have connected in parallel. Now what is the formula? E equivalent. Tell me what is the formula of E equivalent for parallel combination? Anyone? What is the combination of parallel combination E equivalent formula? Along with internal resistance I have connected. The formula is actually E1 by R1 plus E2 by R2 plus E3 by R3 divided by, it is not completed, 1 by R1 plus 1 by R2 plus 1 by R3. This is the complete formula for combination in parallel. And what is the total net resistance, you can say? If I will ask you the net resistance, next question will be net resistance, R equivalent. Highlight R equivalent. See here, these 3 resistances are in series or parallel? These 3 resistances parallel. That means what you can say for a net resistance of these 3? How it will be written? 1 by R1 plus 1 by R3. So R equivalent for this combination is what? R equivalent for this section I can say R by 3. R by 3. And this 3 combination is in with this in external resistance in series or parallel? It is in. At the place of these 3 you can draw single resistance of what is the resistance? R by 3. And this R by 3 is actually in series. So what is the net resistance, you can say? R by 3 plus capital R. So this is about the combinations. Now here is a good question. Try to solve it. ये चैप्टर हम कंप्लीट करके देते हैं. Now let's see how to proceed for this question. The question given is a network of resistance 16 volt battery is connected. Of internal resistance is also 1 ohm as shown in the figure. Firstly calculate what is the equivalent resistance of the network. First step is equivalent resistance. See, these 2 resistance are in series or parallel? Parallel. This 2 with this is in series and these 2 combination is also in parallel. So how will solve this net? Start writing like this. Write the equivalent resistance of these 2, 4 and 4 in parallel. What will be the equivalent resistance? For this combination, what will be the equivalent resistance? 2. Here it is how much? 1. Here it is how much? 12 and 6. How you can solve? 12 into 6 divided by 18. That means what is the net equivalent resistance is coming for this section? 4. Now can you say, oh, now every section is in series. So how much net equivalent resistance? 4 plus 1, 5 plus 2, 7 plus 1, 8. So what is the first part answer? R equivalent? 8 ohm, simply. Now second part. Voltage drop across AB. What will say voltage drop across AB? What is the formula for potential difference across any cross section? Potential difference can be written as net charge current flowing into resistance. Now tell me what is the net current flowing through this circuit? What is the EMF of this circuit? 16 divided by what is the net resistance you have calculated? 8. How much current? 2 ampere. And can you say through this cross section, and through this cross section, current flowing will be same because I have made this 2 as equivalent, this 1 as equivalent, and this 4 as equivalent series combination. So if I ask you across AB, what is the current that is flowing? 2. What is the resistance that is going for this section? 2. So what is the potential difference? 4 volt. First part answer. Now if I'll ask you across CD. Across CD, what is the potential difference across, you can write. What is the net current flowing? 2. What is the resistance across C and D? Equivalent resistance, how much you have calculated across C and D? 4. So what will be the answer? 8 volt will be the answer. If I will ask you across BC, what will be the answer? Let's suppose the third part of the question is asking you across BC. Again the same formula, I into R. What is the net current flowing in the circuit? 2 ampere. What is the resistance? 1. What will be the answer? 2. You can even calculate across 1 and 1 also. Tell me across this portion how much the current will be flowing, and through this portion how much current will be flowing. Let's suppose you know that in parallel combination current is going to be divided. What is the net current flowing? 2 ampere. So if you know the current flowing is 2 ampere, that means up through this how much will be flowing? 1 ampere. Through this how much will be flowing? 1 ampere. In the same way you can calculate for any single resistance of this complete section. Let's suppose the question is asking for this 12 ohm and this 6 ohm also. How much currents will be flowing through this section? This complete section is giving you how much? 2 ampere. Through this how much you will be going? Through this how much will be going? See how you can solve. Through this 12 ohm, what is the formula for current? Potential difference across resistance. What is the potential difference across CD section? 8. What is the resistance for this one? 12. So what is the answer you can write for this 12 ohm resistance? It will be 2 by 3 ampere. And if I will ask you for this 6 ohm resistance, you can calculate across any one. How will you write? What is the potential difference? How much you have calculated? CD 8. What is the resistance? 6. How much the current will be coming? 4 by 3. Again add up both of this. How much it is coming? 6 by 2. Can you see it is coming actually equal to again 2, and it should be coming because this 2 ampere is going distributing in this channel, and again after coming the net current flowing through this is 2 ampere. So you can analyze for any single resistance that you want in this complete system. This question was asking for only 2 parts, so we have analyzed all the sections. Now next 2 important laws, that is Kirchhoff current law and Kirchhoff voltage law. What is KCL? The algebraic sum of electric current at a junction in any electrical network is always 0. The statement always remember, it can be 1 marks question can be asked in board exam. Let's suppose what it is representing. The inward current that is coming, I am representing it by positive, and the outgoing current I am representing it by negative. So what I am writing? Positives. How many positives are there? I1 plus I4 minus I2 minus I3 minus of I5, and this complete sum is equal to how much? 0. This is simple KCL. Here you can see the sign convention. Incoming current is taken as positive and outgoing current is taken as negative. So simple, one more question can be asked. Let's suppose this kind of some cross section is given. From here it is coming 2 ampere. From here it is coming 5 ampere. Here it is, let's suppose 3 ampere. So I will ask you, in this cross section AB, how much current is flowing according to KCL? How much current is flowing from this wire? 5 ampere. From this wire? 2 ampere. For this AB section, how much current will be going? 7 ampere. So how you have calculated it? This is also an application of simple KCL. Now if I will ask you this BC section, tell me what is the current going in this BC section? How you can find? The net current is how much? 7. In this section how much it is going? 3. That means in this section how much it will be going? So how you are calculating all these things? Using KCL, simple. And the next one is more important, that is KVL, Kirchhoff voltage law. What is the definition of KVL? Algebraic sum of all the potential drops and EMF along any closed path in an electric network is always 0. Just remember the formula definition, then I will tell you how to write it. 2 loops are there. How to write in any loop the potentials equal to 0? Let's see. Always remember that whenever you are going from higher potential to lower potential, you will write plus or minus. Higher to lower, what you will write? Minus. And lower to higher? Plus. Only remember this thing. and the direction of flow of current is always taken for resistance is always written as negative, like how much I am telling you. Let's suppose this loop I am taking loop 1 and this loop I am taking loop 2. Just focus here. See, firstly I am writing the equation for loop 1. For loop 1, tell me, I am starting from point VC. What is the potential at point? I will represent it by VC. What is the current going into this circuit? I1. Tell me what is the potential difference across R1 you will write. Potential difference across R1, how much you will write? V is equal to I into R. And I told you in the direction of current always you will take this value as negative. So how much you will write here? Minus of I1 into R1. Fine. Now what is the next thing coming in your way? You have jumped from here to here. Now what is the next electrical component that is attached in your circuit? Battery. Now notice this, this is what? Lower polarity and this is what? Higher polarity. You are moving from lower polarity to higher polarity. Plus or minus? Plus. Lower to higher always it is written as plus. Plus how much it is the potential difference? E1. Fine. You have to complete this complete loop. Now what is the next thing coming in your way? R2. How will write the potential difference across R2? Minus, what is the potential difference? I into R. What is the net current flowing through this cross section? Now it is not only I1, it is I1 plus I2 because there is a current that is flowing in the loop 2 also. So what is the net current you will write? I1 plus I2. And what is the resistance? R2. And till where you have reached again? VC. You have started from VC and you have reached till again VC. Can you say VC will get cancel out and this will behave like your equation 1. Okay. Now let's understand for loop 2. Same equation I am writing for loop 2. Because always 2 equation, 2 variable kind of questions will be there. Now let's again write for loop 2. I will again start from VC. Now let's move. Now what is the current into loop 2? I2. You are firstly crossing this resistance. How will write the potential difference? What is the formula? I into R. What is the current flowing in this circuit? I2. What is the resistance that you are crossing? R3. And in the direction of current, what will take the potential difference? Minus. Minus. Very good. Now what is the next thing coming your way? Battery. You are moving from higher to lower or lower to higher? Lower to higher, positive or negative? Very good. Plus lower to higher it is E2. Very good. Now you have reached till point A. Again you will enter into the same cross section. What is the net current into this cross section? I1 plus I2. What is the potential difference you will write? Minus of I1 plus I2 into what is the resistance? R2. Again finally where you have reached? VC. Can you say VC will get again cancel out and this will behave like equation 2. Equation 1, equation 2 you can calculate anything you want. In this way you will apply KVL. Just remember 2-3 things very important. In the direction of current always conventionally you are taking potential difference as negative. Moving from lower polarity to higher polarity you are taking this as plus or minus plus. In case you are moving from higher to lower, answer will be coming same, only polarity will be changed. Higher to lower, what you will take this same value as negative. That's it. After that you can write the same equation. Now next kind of combination in current electricity is very important, that is Wheatstone bridge. What is Wheatstone bridge? It is a combination of 5 resistance. Here you can easily see resistance 1 I am naming this as P, Q, R and S. And there is a final 5th resistance also. This combination is called as what? Wheatstone bridge. There is complete proof for that. I will attach that. What is the condition that you should check for Wheatstone bridge? Because in the exam it will not be given like this always. So you have to check what is the condition. So what Wheatstone bridge says that if your ratio of these resistance are coming equal, that means what I can say, P by Q is equal to Q by, this is named as Q, this is S. If this condition is satisfied, what you can say, what kind of combination this is? Wheatstone bridge. P by R. This resistance is represented as, that is P by R should be equal to Q by S. If this condition is fulfilled, I can say this combination is what? Wheatstone bridge. And if this condition is Wheatstone bridge, what we know about this 5th resistance? It is actually waste. Okay. The net resistance of this one is 0. It is behaving like a open circuit. That means if you want, you can even remove this wire. There is no difference in the calculation. So if I will talk about the proof, a simple proof, again you will apply KVL in the complete section. I am just rubbing it for a moment. These things are written again. Let's see what kind of proof is there. There again you will make two loops. This is loop 1, this is loop 2. Here it is the movement of current. Again you will write the same KVL equation in loop 1. This will behave like equation 1. This is loop 2, behave like equation 2. And when you will solve it, Ig will become 0 because you know that potential of D is potential equal to B. By solving this equation, you will have this ratio that same exactly I have told you. P by P by R. It can also be written like this. P by R should be equal to Q by S. This is the condition for Wheatstone bridge. Very important condition that you have to remember. This is Wheatstone bridge, and the derivation also is very simple. It is just nothing special. I have applied KVL like the previous question. I have applied it in two loops. Okay. Now next one is very basic question related from power. Just try to solve it. What is the given condition? A light bulb is rated. What is the power given? 120 watt. What is the potential given? 240 volt. Calculate the resistance of the bulb. What they are asking for? Resistance. What is the relation between power, voltage and resistance? P is equal to V square by R. So just put the values. R will be equal to how much? V square. V square how much you can write? 240 into 240 divided by, what is the power rating? 120. Solve it. It will become 2. How much the net answer will become? 480 ohm. This will be the simple answer. Relation, always remember, power can be written as what? V square by R. Either there is one more formula. With current, what is the relation? P is equal to I square R. This is the second formula that is also very important. Now try to solve this one. Two cells of EMF 1.5 and 2 volt having internal resistance 0.2. This is not watt, this is actually ohm. It is misprinted. Write this E1 is given as 1.5 volt. Again I am writing the values. E2 is given as 2 volt. Internal resistance R1 is given as 0.2. R2 is given as 0.3. And the question is asking that they are connected in parallel. Calculate the EMF and the internal resistance. The formula that I have told you, try to apply that formula and have the answer of E equivalent and even R equivalent. What is the formula of E equivalent? E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. And what you will say for R equivalent? 1 by R equivalent will be equal to 1 by R1 plus 1 by R2. Try to put the values and calculate the answer. What is the answer is coming? Anyone got the answer? 1.7 for E equivalent. And what is R equivalent? Let's put the values now. Zero point. Let's check it. E equivalent. What is E1? 1.5 divided by R1 0.2. Better always in solving remove the decimals firstly. Otherwise it will create problem always in calculation. Now then what you will write? Plus of 2 divided by R2 0.3. What is again I will say remove this decimal. This will become 20 by 3. Then what you will write? 1 by R1, that means 10 by 2 plus it is 10 by 3. When you solve it, what is the answer coming? In decimals or in fractions also you can keep the answer, no problem. Just quickly write it. Take the ratio, what it will become multiplied by 3. That means it will become how much? 45 multiplied by 3 plus here how much it will become? 40 divided by 6. Can you see this 6 and this 6 is going to be cancel, divided by. Here what it is? Here we will multiply it by 3. Here we will multiply it by 2. That means in denominator how much I can say? It is going to be 50. That means net value is going to be 85 divided by 50. I can say that this will be somewhere coming 1.7 volt. This will be the simple first answer. For this is the first part. Second part, R equivalent, that is more simpler. How much you can say R equivalent? 1 by R1, that means you can simply write it as 10 by 2 plus 10 by 3. Just take the LCM. What is the LCM? It will become 6. Here how much it will become? 30 plus 20. That means R equivalent finally can be said as it will be coming 50 divided by 6. This will be the second answer. Here you can cross check it also. The answer will be coming 1.7 and the second part will be answer will be coming somewhere 0.12 ohm in roughly around. So this was end of first portion of physics, that is completed by charges, movement of charges a little bit. Now we will start after some time the next part of physics in the 12th portion, that is magnetism and matter. When magnetism is generated? When charge is moving with a constant velocity.
That was wonderful. Big round of applause again for Abhishek sir. Maybe it's not easy, so keep motivating Abhishek sir by writing something sweet for Abhishek sir and stop fighting. I just saw some guys fighting with each other. Right? All of you are wonderful, all of you are superb. So, till the time Abhishek sir recharges himself, he's spoken a lot about batteries and charges. Let him recharge himself. Till that time, we will do some experiment. I need a volunteer. Right? So, the experiment is going to be very, very simple. We're going to take this and with the help of physics, and this is not a mic, this is the mic. With the help of physics, we're going to turn the potato into chips. Do you think it's possible? Eating the chips is possible. So, experiment is going to be very simple. This is the potato, this is a screwdriver, and I want a volunteer to help us take the potato from here to here. That's it, very simple, without touching the potato. Without touching the potato, you have to take the potato from here to here. Any volunteer? Volunteer. If you volunteer, I'll get to eat more chips. My hands will be free. So you have to take the potato from here to here without touching the potato. It is possible. Who is coming? One of you. Why don't you come? Come, come, come. We'll try. Come, come, come. Why? Don't worry. Come. This is your fame moment. Come. Everybody will see you. What's your name? Sudarshan. Guys, round of applause for Sudarshan. Don't worry. If you fail, we will not do anything. Sudarshan. So you cannot touch the potato, but the potato has to come up. You can use the hammer. You can use your brain also. That works more than the not touching the potato with anything. No touching the potato with anything. No touching the potato with anything. Who wants to come and try? No instructions, no subtitles. Please come and try. Try, try, try. I think you are on the right path. Come here and try. Yeah, come here and try. Okay? Just show the camera. Alright, big round of applause for Sudarshan. Sudarshan did it. Now, you guys have to say when we did this, the potato came up, what law of physics was applied here. So comment section में जाकर start commenting if you're the first one to get the right answer, there's an absolute wonderful gift for you by none other than Abhishek sir. My job is very simple, put the blame on others. Right? So be the first one to tell us which law of physics makes this happen, and you will win a lucky prize for sure. Do we have time for another experiment? Do we have time for another experiment? We'll give Abhishek sir a little bit of break. We'll do another experiment. Be with us, guys. Water to the top. We need water. We'll get the other one. Oh, but I don't have something to balance. All right. How do we balance it? We need something to balance it. Okay. So we don't have anything to balance it. Let's see. If we can go ahead, and I'll be the balancing pod. I'll be the standing Buddha for tonight. Not Buddha. Buddha. I think we can put more. Okay, I need one more volunteer. Quick, come, somebody. I need a volunteer. I am the standing Buddha. I can't do anything anymore. I need a volunteer. Quick, somebody. One of you, quickly. It's a simple experiment. I just want you to guess something. That's it. I think we can put more water here. I am sure. Little more. All right. Okay, I think it's enough water. Come, come, come. I think, unless we have a stable surface, we won't be able to. So the water is kind of full. There is no more space left for any more water, right? I want all of you to guess. These are metal pins. Can you open and show the metal pins, sir? Metal pins, right? The water is actually dripping. It's full. Now, how many metal pins do you think will go inside before the water falls out? 1, 2, 3, 4, 5, 10. How many of you say 5? 10. 10. Most of you say 10. Can we move the camera for some time till we stabilize this on something? Is it possible? Just for a quick moment, right? Because we need a flat surface for this. Or do you want to bring? All right, we'll have a podium so that there is no cheating, right? Let's have a podium and let's see how many pins can actually go inside this. All right. Okay. Okay. All right. All right. Okay. Let's stabilize this. Let me put some more water. Can I have some more water? There is. Okay. So if you can see, we're going to. Yep. Okay. I think this is full, right? Everybody? It's absolutely full. So now how many pins can go in? Metal pins. 10. How many of you say 10? Okay. How many of you say 20? No 20? Okay. Let's count the number of pins. Sir, please join me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Guys, 10 is done. How many more do you think can go? Another 10? Okay, let's see. 11, 12, 13, 14, 15, 16, 17,
18,
19,
20,
21.
22,
All right. 23,
24,
25,
26,
27,
28,
29,
30,
31.
32,
Guys, how many more? We are on 34. Okay, we'll go a little faster. 35, 36, 37, 38, 39, 40, 41.
42, 43,
प्यार से
44, 45,
46, 47, 48, 49. Guys, 50. Do you think we can add another 50? Why do you think is this happening? Why do you think is this happening? Okay, so comment and let us know what law of physics is this. The first person to get it right definitely gets a surprise gift from. So not only is he taking a 10-hour long class for you, he is giving out surprise gifts to everybody. There is a trip to Simla as well. That is only for me, right? So with a huge round of applause, let's welcome back Abhishek sir.
Hello, hello. So we are discussing why that was happening. If it was filled, okay. Well, let's check the comment sections also if someone have answered it correctly. Yeah, you can comment it down. Those who have the reasons, please comment down. I want to check. Surface tension is correct answer, but what is the effect of that surface tension? Surface tension is the force of the surface. In surface tension, basically we are studying the surface of the liquid. Due to that, what is happening? Anyone? So it is very obvious. If you are putting some volume, that means that volume should be displaced. Buoyant force says this. That means that volume should be displaced, and water of equivalent volume should come out of the glass. That is a very common thing that we can understand. Because everything is displacing water, that means water is coming out. Then why it didn't happen till now? What? Negligible volume. I can say for one pin it is negligible volume, but for 30, 40, even if it was continued, it can take nearly up to 100, 120 pins easily. Anyone? There is a single term in surface tension, if anyone knows. That single term is exact answer. Buoyancy is never discussed in surface tension. Anyone from online, I'm watching the comment sections. If anyone know the reason, they can tell me the answer. Surface tension, Nagis is saying puja due to force, Shruti, surface tension. Actually, your answers are correct, but not completely definable. See what is happening actually. Density. What do you think about density? What is happening with density? Now see what is happening actually. हाँ, very good. अभी अभी पढ़ाया था ना. Very good. Why it is not working? 11th class students should know this reason because they have studied it till now. शांतनु सर चेक करेंगे. For a moment, let's check this. What is happening? We have taken a glass and that was full of water. If you know the a term meniscus is there in surface tension. What is a meniscus? Shape of the outer liquid, and what kind of liquid have the shape? It is called convex. Okay. And if you are talking about, let's suppose, if you are talking about mercury, mercury is repellent of the surface. So if you watch the drop of a mercury, it is nothing but it is somewhat like this. If you are talking about silver, silver make this kind of meniscus perpendicular. So when you have put it this pins inside it now one by one, what was happening? Why liquid was not coming? Because liquid was slowly making a meniscus, a convex meniscus on the surface, and that volume that you have put it here now, it was formed in the form of meniscus, and slowly if you are putting this water was not actually coming out of the surface. This was the basic reason. Meniscus, I can say, is a proper thing. Anyways, let's come back on the topic. Where is the pen? So now come to magnetism. Now why magnetism is generated, or why magnetic effects are shown? In the starting only I have told you, let's suppose when charge is there, plus Q charge is at rest. What is the effect due to rest? It is generating electric field. But now in this portion of physics, this same charge will start moving with a constant velocity. And when it starts moving with a constant velocity, what happens? What are the effects? It will generate electric field as well as magnetic field. And now we are going to study this portion of magnetic field. Now next complete portion of physics that we are going to study in this section is magnetic field. What are the chapters that are coming? First chapter is magnetism and matter. Second chapter we will study electromagnetic induction. These two chapters are basically covering magnetism of complete portion. So firstly, what is magnetism? The phenomena of attracting magnetic substance like iron, nickel, cobalt, etc. You from the your childhood you are watching magnetism. What are the magnetic properties? If you are bringing same like poles towards each other, it will repel, and unlike poles attract. This is a basic behavior. Any body possessing the property of magnetism is called as what? Magnet. A magnetic pole is a point near the end of a magnet where magnetism is concentrated. We call the end of the magnets as magnetic pole. You know that Earth is also a natural magnet, because that's why we define South Pole, North Pole. These are the definitions. That's why, because it is called as a also natural magnet. The region effects will be present, and that area at the that field is called as what? Magnetic field. Now we will see the properties of bar magnet. Bar magnets are there. Bar magnets are some square shaped magnet. This is called as bar magnet. One pole will always be north, one pole will always be south. And when, let's suppose, like poles are coming towards each other, what kind of force will be there? Repelling force. And let's suppose if south and north are like this, then it will perform attractive force. Same thing is written here. Unlike poles attract and like poles repel. Magnetic poles always exist in pair. Poles cannot be separated. Like, what is the meaning of this line? Let's suppose you are trying to break this bar magnet from the middle. Now maybe you will have a thought that north pole and south pole will be differentiated, but it will not happen. What will happen? It will make two different magnets, where this part will behave like south pole, this pole will behave like north pole, and again it will induce a south and a north. Then a single monopole never exists in bar magnet. These are the basic properties. Obviously, a magnet can induce magnetism in other magnetic substances also. It attracts magnetic substance, simple properties. Now, analogy in formulas of electrostats and magnetism, very important thing. What are the same things that we have studied for electrostatics and magnetism? Some things are there that are very much relatable. For example, what is the representation of electric field in electrostatics? What is the representation? It is represented as E. In magnetism, magnetic field will be represented as what? It will be represented as, board is not working. Switch off कर दे board ना. Now, we are talking about analogy between electrostatics and magnetism. So what are the common things? What is electric field representation in electrostatics? E. What is the representation of magnetic field in this magnetism? B. So wherever you have written E, now it will be represented as B. In electric field, I have represented a term K. What was K? 1 by 4 pi epsilon naught. In magnetism, that K will be replaced by what? Mu naught divided by 4 pi. What is the value of mu naught divided by 4 pi? 10 power minus of 7. Now, if there is a, what is the representation of dipole moment? P. In magnetism, what is the representation of dipole moment? Capital M. What is the representation of charge in there? Q. Here it is represented as small m. For what we call this small m? It is called as pole strength. And this is called as, capital M is called as what? Magnetic moment. What it is called? Magnetic moment. So let's suppose if I'll ask you, let's see the formulas also. There you will understand it in proper way. Here it is represented for a bar magnet. This is south pole. This is north pole. This is the properties written for bar magnet, magnetic dipole moment. A pair of magnetic poles of equal and opposite strength. What is the strength? It is also called as pole strength. Sometimes this board is not working properly. And how magnetic moment will be represented, I am telling you. See, what is the formula for electric dipole? P is equal to Q into 2 into L. And what are the analogy I have told you? Magnetic moment is represented as what? M, capital M. What is charge replaced as? Pole strength, that is small m, and multiplied by 12. So here you can see what is the formula of magnetic dipole moment. M is equal to small m. Small m is what? Pole strength into 12 is the representation for magnetic moment. Magnetic dipole moment. Now Coulomb's law in magnetism. What was the formula of force in electrostatics? K. Force, if I will write Coulomb force, K Q1 Q2 divided by R square. If I will ask you the same thing in magnetism, how will write the same force? At the place of K, what you will write? Mu naught divided by 4 pi. At the place of Q1, what you will write? M1 pole strength into M2 divided by R square. You can see here also M1, M2. These M1 and M2 are representing what? Pole strength. Here you can see F is directly proportional to M1 and M2. Here you can see it is inversely, actually it should be inversely proportional, and net force will be coming equal to K M1 M2 divided by R square, and actually it is not K, it is actually what? Mu naught divided by 4 pi M1 M2 divided by R square. Same analogy that we have used. In vector form, if someone asks you, this complete term is what? Magnitude. If you want to write in vector form, you will just multiply it by R cap. R cap means given vector divided by magnitude of that vector. That means the form will become R cube. Now if I'll ask you the same formula, this board is not working here. See, what was torque in electrostatics? P E sine theta. At the place of P, what you represent here? M, capital M. Electric field is represented as B sine of theta. There also you have written P cross E. Here what you will write? M cross B will be the formula for torque. You can see here it is mentioned. Formula is what? It is derived here. And what is the final formula that you are writing? MB sine of theta, M cross B. formula of torque. Now if I'll ask you about again A cross B, how to do M cross B. This is your M, this is B. What is the direction you are getting? Inside the plane, it is represented for inside the plane torque direction. Next thing is work done. What was the formula for work done or potential if I have potential energy in electrostatics? PE sine theta. At the place of P, what you'll write here? M into B. M into B cos of theta. So see, it is rotated by an angle from theta 1 to theta 2. This is the derivation. Integration from theta 1 to theta 2. Formula will become MB cos of theta 1 minus cos of theta 2 potential energy. And what is the final formula of potential energy you are getting? It is equal to minus of MB cos of theta. Previously it was coming how much? At the place of M it was P. At the place of B it was E cos of theta. Now there are two terms that are defined: magnetic intensity or magnetic magnetization force, that is represented as H. The formula for H is equal to B by mu. Now this mu is a new term that I forgot to tell you about. What is this mu? Mu naught divided by 4 pi that you have written, it is nothing but actually permeability. Same kind of definition like permittivity, but this time we will represent this as permeability. Second thing is intensity of magnetization. Intensity of magnetization is represented as M is equal to M. What is this M? Magnetic dipole. Both things were same, that's why dipole moment divided by volume. Why we are studying? Definition is given. Actually we have to derive the important thing, that is magnetic susceptibility. Magnetic susceptibility is defined as X, represented as X, and the definition that is coming for that is M divided by H. And when you see the relation for mu R, that is relative permeability, it is equal to, finally when you will solve this complete M by H, it will be coming I plus XM. What is the value for diamagnetic substances of mu R? It is less than 1. For paramagnetic substances, mu R is greater than 1, and for ferromagnetic substances mu R is a lot greater than 1, and that means a very bigger value will be coming of mu R for ferromagnetic substances. Now there is a complete chart for diamagnetic, paramagnetic and ferromagnetic. First point is what is diamagnetic substance? Basically what do you understand by diamagnetic substance? Diamagnetic substance, if there is a magnetic field, it will repel the external magnetic field. That field is called as what? That property of body is called as what? Diamagnetic. Paramagnetic substances, what do you understand by paramagnetic substances? They will get attracted to the external magnetic field. And the third one is what? Ferromagnetic substance. Ferromagnetic substances, they are highly attractive towards the magnetic field. So there are basic differences that are mentioned here. See, here you can see there is external magnetic field, but it is not entering into the body. That means it is repelling the external magnetic field. Second one, you can see that some of the magnetic lines of forces into the body, that is called as paramagnetic. And the third case, you will see a lot of external magnetic field is attracted into the body, and that's why it is having the highest magnetic property. That property is called as ferromagnetic substance. A lot of theory is there. You can read it out. Now, next important law is Curie's law. Curie's law tells you about how it is represented, your magnetic susceptibility relation with temperature. And it becomes a very important law. How it is represented? Represented magnetic susceptibility. It is experimental data. It is 1 by T. Always remember, this is called as Curie law. It defines, Curie law is defined as magnetic susceptibility of material varies inversely with absolute temperature. You can see here, finally the relation is coming, X is inversely proportional to 1 by T. Or when you remove this proportion, there is some constant C is coming, and that C is called as what? Curie constant. Now the next portion, that is magnetic effects of current. This is the major portion and most important one in magnetism. Due to current, what will be the effects that will be coming? First law is Biot-Savart's law. Now there is a wire and the current flowing through this wire is I. And now let's suppose some points will be given and you will be asked that what is the magnetic field due to that current carrying wire at that point. Let's suppose I have taken point P and I have taken this is about the derivation dl section you will take, then you will write about the effect of this dl section at point P and then at point P dash. 2 points are there. What is Biot-Savart's law? The strength of magnetic field due to small current element carrying the important points are it is directly proportional to I dl sine theta and inversely proportional to square of the distance. If I will summarize this complete law, it is given as dB is directly proportional to I, proportional to L dl, or proportional to sine theta and inversely proportional to R square. So finally, when you will combine all these things, what it will become? This is given as your magnetic field at any general point I dl sine theta by r square. When this remove the proportionality, you will get what? Mu naught divided by 4 pi. And if I will tell you about an important thing about it, how much it was written? dB is equal to how much? Mu naught divided by 4 pi into I dl sine of theta divided by r square. Formula is easy, but how to find the direction? That will be the actual part. So how to find the direction of magnetic field using Biot-Savart's law? What is the cross product you do usually? How you will do? The result that you will be getting will be I cross R. Simply to I cross R. So we have 2 points. Let's see what kind of magnetic field direction we are getting. If I am taking this point and this value is what? R. What is right hand thumb rule? Take your fingers in the direction of current. Take your fingers in the direction of current. This is the current flowing I. Where is your R? On this side. That means you will show your arm to R. This is I. This is R. What is the direction you are getting? Inside the plane. And you can see here what is the direction represented? Inside the plane. Now again on the some other points P dash. Again do the same thing. Take your fingers in the direction of I. You have taken the direction of I and then curl the finger towards R or P dash. What is the direction you are getting? Outside the plane. It is represented dot. Dot is representing in magnetism as what? Outside the plane, and cross representing what? Inside the plane. So this was about the direction. Directions are even more important. Now magnetic field due to straight wire that is carrying current. What is the formula for straight wire? What is the formula? Mu naught I divided by 2 pi A. It is also derived from the same Biot-Savart's law. See how. Firstly, you will take an element dl. Firstly, you will take an element dl and you will write the effect of that dl element on point B. Firstly, what is the direction? Again, you will do the same thing. This is the direction of I shown and this is the point of R. I cross R. What is the direction you are getting? Inside the plane. And what is Biot-Savart's law says that mu naught I dl sine theta divided by R square. You have to apply some trigonometry here and then you will find the final result as it will be looking somewhat like this. Mu naught I cos phi d phi divided by 4 pi A. Now there will be integration. Integration of cos phi from where to where? You can see the angles that are made from the lowest point and the highest point. What is the angle made for the lowest point? Phi 1 and for the highest point phi 2. So what will be the integration? What will be the limits? Limits will be from minus of phi 1 to plus of phi 2 because phi 1 is calculated in anti-clockwise direction and phi 2 is calculated in clockwise direction. You can see in the next page here. It is integrated from where to where? Minus of phi 1 to plus of phi 2. Now integration of cos phi d phi will give you how much? Sine, and then there is coming a sine term, and then we will put the limits. The final result that will be coming is mu naught sine phi 1 plus sine of phi 2 divided by 4 pi A. And now if I will tell you what is the result? Shit. Now here if I will ask you about the infinite wire, if I am talking about infinite wire, that means it is very very long. That is, in that case what you can say for phi 1, how much phi 1 will be behaving like? That means this point is at very far distance, that means phi 1 will be behaving like pi by 2, phi 2 will be behaving also like pi by 2. Now see, when you'll put these values, check what is the result that will be coming. Here put sine phi is equal to, so what is sine of 90 degree? 1. Phi 2 is also sine of 90 degree? 1. That means how much it will become? 1 plus 1 it will become 2. That means the net result, again this 2 and this 4 will get cancelled out. What is the final result that will become? Mu naught I. You can see the special case. When phi 1 is equal to phi 2, that means for straight wire, the result of magnetic field is how much? Mu naught I divided by 2 pi, a very important result. So this magnetic field is representing what? This with distance, what is the proportionality of this magnetic field? I can say here what is noticing I am that B is inversely proportional to A. That, and here the curve is given between B and A. That means at y-axis what is there? B inversely proportional to 1 by A. This is x. What kind of curve this is? It is very good rectangular hyperbola. If this is a rectangular hyperbola, it will be making somewhat curve like this in both the directions that was represented. Formula is important, mu naught I by 2 pi, and always remember the direction, how you will find the direction. Now magnetic field due to a circular loop, current carrying wire, second formula that you have to remember. Now we have taken a circular loop, some current is flowing like this, and at point P I want to calculate what is the magnetic field that is going to come. Again I will take an element, I will write the effect of that element, direction will be coming somewhat like this, and then again I will make two components. And exactly at the exact symmetric point, again I will take an element, second element, and I will write the effect of that too also. Now when you will notice what will happen, this dB become, I can say this is both these points are symmetric. That means whatever the dB I am writing, both are actually same. Now make the two components. What you can say about this component? Cos phi, this component sin phi. For this also, this component cos phi, this component sin phi. That means I can say this cos phi component is going to be cancelled out, and the net magnetic field will be becoming dB sin of phi. So after integration, what is the result finally you will have is important. The final result for any general point is mu naught I a square divided by 2a square plus x square 3 by 2. And the more important is special case. At the center of magnetic field, what is the final value of magnetic field? At the center of a loop, it is equal to, if you check the formula, here the formula is there. In this formula, if I will ask you at the center, if I will ask you at the center, what is the magnetic field? That means what is the value of x at the center? 0. So put the value 0. Mu naught I a square divided by 2 a square power 3 by 2. That means can I say this two will get cancelled out, and what is the result you are getting? Mu naught I a square and a cube will get cancelled, and what is the final result? Mu naught I divided by 2a. That is the final result that you have to remember. At the center of the loop, and this is for a very infinite distance, the curve is going like this. At the center it is achieving its maximum, and as soon as you are going away, it will be continuously decreasing. Now there is a basic question, try to solve it. There is a wire current going like this. At point O you have to calculate what is the magnetic field. See how to solve this question. See, this is the wire, complete cross section, and firstly you have to find the magnetic field due to straight segment and then due to the semicircular arc. Now tell me what is the formula for straight wire? Due to a infinite state, or what is the magnetic formula? Magnetic field formula? Mu naught I divided by 2 pi a, or r or a, whatever you want to call. But you know that this wire is actually going to pass from the same point, and this wire also going to pass from the same point. There is a property that whenever your wire is passing from the point, the effect of magnetic field will become 0. That means this answer for the first portion will be how much? 0. Due to state segment, the net magnetic field will be becoming is 0. Because you can see also how to find a net magnetic field direction. How you find the I cross R? This is the direction of I. Where you will go for R? Neither upwards, neither downwards. So there is no magnetic field at this point. It is not defined. But you can define for semicircular arc. For semicircular arc, what will be the formula? Actually, it is defined as mu naught I divided by 2a for what? For complete circle. There is, along with it, there is a thing that is theta divided by 360 for any general arc. If I will talk about semicircular arc, what is this angle theta? What is this angle theta? 180. That means this formula eventually become mu naught I divided by 2a into theta divided by 360. Theta is how much? 180 divided by 360. That means it will eventually become 1 by 2. So what is the net answer you can write? Now just put the values and check what is the answer coming. Mu naught can be written how much? 4 pi into 10 power minus 7 into current. Current is how much? 12 ampere divided by 2 into A. What is the radius that is given? 2. 2 into 10 power minus of 2 into half. Now check this 2 will get cancel this 4. Now what are the rest values that are remaining? 12 is there. This can be cancelled at 6. That means you can write 6 pi into 10 power minus of 5. This will be the final. And what is the unit of magnetic field? Tesla. So you will represent the final answer as Tesla. Now Ampere-Circuital's law. Just like Gauss law, there is Ampere-Circuital's law. What is Ampere-Circuital's law? The line integral, that is integration B dot dl is equal to mu naught into I. What was Gauss law? Gauss law was E dot ds is equal to Q divided by epsilon naught. Here Ampere-Circuital's law says that the line integral B dot dl for a closed curve is equal to mu naught times the net current that is present flowing through that imaginary surface. Ampere circuit we call it as. Like let's suppose this is Amperian loop I have drawn. And what is the net current flowing through it? I. So what is the equation I will write? B dot dl is equal to mu naught into net current flowing through this as I. Now there is a proof again for this also. This can be asked in derivation part of your board exam. So you can see finally the result will be coming is B into 2 pi r. Integration of line will be, what is the total if I will integrate? Let's suppose I am taking any cross section. What is the line integral? You will see. DL means any cross section part, I will call it as DL. And now what I am doing? I am integrating that DL portion. If I integrate all these small portions, what will be finally? It will become a complete loop. So if I am talking about the line, that means in a circle, what I call for a length, circumference. What is the total circumference of a loop? I can say 2 pi r. If let's suppose the radius is given r. That means I can write B into 2 pi r is equal to mu naught net current flowing through this is mu naught I. When you took it here, then you will cancel it. The final value will be coming is equal to, it can be proved B dot dl is equal to mu naught into I. So this is about the line integral that you call. Now next thing is solenoid. What is solenoid? A copper rod or any kind of metal. It is this kind of circular rings are made, and this rings, and what is the current flowing through this rings? It is I. And what is the net magnetic field due to solenoid? It is you have to calculate. Here what I have taken, what this loop is called as Amperian loop. You have to calculate what is the net magnetic field passing through this Amperian loop. So you have to apply what is the net Ampere's law? B dot dl is equal to mu naught into I. Now let's focus on one by one. Firstly, focus on the portion PQ. This is the direction of PQ and the magnetic field. What is the angle between magnetic field and the dl vector? I can say this is the actually direction is not represented. For this portion, this is the direction of magnetic field. Because in circular wire, if you want to find the direction, you have to just curl your hand. You can see what this kind of some rings are made. If this is the case, just curl your fingers in the direction of ring. What is the direction you will be getting? It is positive x direction. So angle between PQ line and B is how much? 0. Now, if I will talk about QR section, what is the angle? This is QR and this is the line of B magnetic field. That means angle between them will be 90 degree. Here again, SR section, what is the angle between them? 0. This is the line and this is the magnetic field direction. Already I have told you this is positive x direction. And again, the final through this cross section, it will be perpendicular 90 degree. So when there it will be 90 degree, what will be the result that you will be getting? When it is dl cos of 90 degree, this complete value will become 0. This complete value will become 0. And simply both of these terms BDL will get add up, and finally how much the result? What is the final result of solenoid? Magnetic field. Final result of magnetic field due to a solenoid is mu naught N I. That you have to remember as a result. What is N here? Mu naught is permeability, I is the current that is flowing through the circuit, and what is N? N is number of turns per unit length. It is represented as small n. Finally, you will have the result B is equal to how much? Mu naught Ni. Try to solve this question. Here, what are the values given? A ring is there, a Rowland ring. You don't have to worry for that. Just it is a kind of solenoid. Radius is given how much? 15 centimeter. Number of turns is given how much? 3500. Wound a ferromagnetic core of relative permittivity. That means what is given? Mu r is given how much? 800. What is the magnetic field B in the core of magnetic current? Magnetic field you have to calculate. In the core of magnetic field for magnetic current is also given. It is equal to 1.2 ampere. Try to solve it. Now see how we can do this question. There is a ferromagnetic substance and it is wounded by some rings, this kind of something. What we call this kind of shape? It is a kind of solenoid, and every values are given just for solving this question also. What is the formula of solenoid? Mu naught Ni. Now, but it is given a relative permeability also. So whenever mu r is given, what you will do simply, when there is medium in electrostatics, what you have to do? Epsilon naught into epsilon r. Here what you will do? Mu naught into mu r. This will be multiplied, and then what is N? number of turns per unit length. What is the number of turns here given? 3500. Now about the length, what is the total length? Here length is not given, but I know the circumference of the any kind of ring is also behaving like length. So at the place of length, what I will write? 2 pi r into what is the current that is flowing through the circuit? 1.2 ampere. The system, that is whatever they given. When you will put all these values, you will have the net magnetic field. Let's see what is the final result that is coming. Here you can see r is given, n is equal to n divided by 2 pi r, and when you have multiplied this mu naught into mu r, firstly you have to do mu naught is 4 pi into 10 power minus of 7, mu r is given 800, and number of turns divided by 2 pi r into 1.2 is the current. And when you will solve all this, you can cross check the answer will be coming 4.48 Tesla. Now Lorentz magnetic force. Till now we have discussed only about magnetic field. Now we will discuss about forces due to magnetic force. Forces in magnetic field. Let's suppose a magnetic field is given and a charge is kept, and it is moving with some velocity v. So what is the force that you know? You can write it is equal to q vb sine of theta. What is the formula? Formula is equal to q into v cross b. V cross b can also be written as sine theta. That means this formula also can be written as q vb sine of theta. Again the question will be coming for direction. So what is the direction? From where you can have the direction, that is the important part. For direction, already I am telling you. For force, the direction will be given by v cross b. What is v cross b? Check here. This is the direction for v. Take your hand in the direction of v and curl towards b. What is the direction you are having? Outside the plane, also can be represented as dot. Here it is represented in 3D. This is the basic formula. It is written about theta and everything. One more important thing. Let's suppose it is not given positive charge. It is giving you negative charge. If it is negative charge, what is the formula? Again you will write q vb sine theta is same, but at the place of positive now it will be a negative. That means polarity of the charge force will be different. Previously it was coming out of the plane, that means this time it will be coming inside the plane. V cross B will give you outside, but due to this is a negative charge, polarity will be changed and now it is acting inside the plane. So from that Lorentz force we derive what is the force that is applied on current carrying wire. The formula is force is equal to qvb, same. Now where velocity I will use is vd into b. Now put the values E. Vd how much you know? Vd is equal to E electric field divided by m. Here Vd is here, and then I have replaced these values. The final result that you will get after replacing all these values is equal to I, because here there is a term of, here there you will generate a term of eta A E Vd, and we have seen in current electricity this complete term is called as what? Current into dl into B. So finally the result will be I dl into B, and the finally force will become I dl B. When you will integrate it, the force will become net eventually B into I into L. Bill. Here what is the how you can find the direction? The direction will be given by I cross B vector. When you will do this, will always give you the direction of force. Simple formula, B into I into L. You can see here IL LB, and the formula that the direction you will get from I cross B will always give you the direction of the force. Now a very general question can be asked, what is the force acting between two wires that are given? See how to solve. This is actually a kind of a question. See, Due to B1, this is wire 1, this is wire 2. Due to wire 1, what is the magnetic field is coming? Mu naught I1 divided by 2 pi r at this point. And how I'll write the magnetic force? Magnetic force is defined as, B into I into L. Here I am trying to write magnetic force on 2 due to 1. If I want to write magnetic force on wire 2 due to 1, firstly check what is the magnetic field experienced by this wire. How much magnetic field it is experienced? Mu naught I1 divided by 2 pi r. What is the current flowing in this wire? I2. And what is the length of this wire? Let's suppose L. So what will be the eventually finally formula will become mu naught I1 I2 L divided by 2 pi r. But major time the question is asked force per unit length. So when the question is asked force per unit length, that means you will divide it by L. What is the final result? Mu naught I1 I2 divided by 2 pi r will be the final result. Here you can see force per unit length is defined as mu naught I1 I2 divided by 4 pi r. Now the next part of magnetism is electromagnetic induction, EMI. And the first thing we define is magnetic flux. Magnetic flux is same like electric flux. What is electric flux? Number of electric lines of forces passing through a cross section is electric flux. Now magnetic lines of forces passing through a cross sectional surface area is defined as magnetic flux. Let's suppose this is your area vector, this is the B direction. What is the formula of flux? B dot A cos of theta. For positive flux, theta should be between 0 to 90. For negative flux, it should be 270 to 360 degree. Actually, for these two, both the common are in the fourth quadrant cos theta is positive, and in the first quadrant also it is positive, and in from 90 to 270 it will become negative. It is about the properties, the strength of the magnetic field. Magnetic flux across can be changed by, you can change magnetic flux by changing the B value of B, you can change magnetic flux by changing the area, you can change magnetic flux by changing the angle. These are the things that are dependent on, and these are the values, the properties. Magnetic flux is a scalar quantity. SI unit of magnetic flux is Weber or Tesla meter square. Standardly we use always Weber as a standard unit for flux. Now we will talk about, actually electromagnetic induction start from Faraday's experiment. Faraday have performed some experiment. The first experiment was what? He have taken a bar magnet and he have taken a coil. Due to that, what is happening? He have brought the this bar magnet closer to the coil, and due to that, what happened? When you have closed this, I have said that when it was coming closer, it was noticed that magnetic field was increasing, and when magnetic field was changing with time, when we was bringing it closer, you have noticed one more thing in the coil, current as well as EMF got induced. This was the first experiment of Faraday's. When you introduced a magnetic field and you started increasing the magnetic field intensity, the current and this EMF got induced in the this coil. Here you can see there is current flowing through this galvanometer. Second experiment for this was, here started increasing the cross sectional area. First time what you have increased? Magnetic field. This was experiment 1. Second time what you have increased? Let's suppose if initially this was the value R1. Second time you have increased this value of R2 of the coil. And again in this second experiment also you have observed that some current started flowing. All of a sudden there was no battery involved, nothing involved. But all of a sudden a current got induced, and along with that current a potential is also induced. This was the second experiment. Third experiment says that he has started rotating this coil. Let's suppose, where is the paper? Let's suppose this is the coil, and now he has started, this is the axis of this coil, and he has started rotating this coil with some omega. So due to that, what was happening? Can you say constantly my theta is also changing? In first experiment, magnetic field is changing. Second experiment, area is changing. Third experiment, theta is changing. So when you combine all these three experiments, he have noticed that in first experiment, magnetic field, second experiment, area, and third experiment, theta. So actually he noticed that whenever he is changing the flux, a current got induced, because combining all these three values, what it is makes flux. We have seen about flux. Flux is what? Ba cos of theta. So when you are changing the flux, a current and EMF got induced. So this was a statement of Faraday's, you can see here also, and it was giving you the formula for Faraday's law of electromagnetic induction. First law says that whenever there is a change in magnetic flux linked with the circuit, an EMF and current is induced into the circuit. Second law say give you the formula also. EMF is defined as EMF is equal to minus of d phi by dt. d phi by dt means rate of change of flux is defined for EMF along with a negative sign. Reason for this negative sign? Can anyone explain this reason for negative sign? Why negative sign was introduced? Negative sign shows that because Faraday's law is not complete law. For understanding Faraday's law, we have to understand Lenz's law also along with it. So Lenz's law states that in whichever the reason is to generate this EMF, that means let's suppose you have increased magnetic field, you have increased area, whatever the changes that you have made, this induced EMF will always try to oppose that change. So this sign is actually representing the opposition, negative sign. That I will tell you about Lenz's law in more depth. So the final relation was EMF is equal to minus of d phi by dt, very important relation. Now that's I told you Lenz's law. What is Lenz's law? The direction of induced EMF or induced current is such that it opposes the change that is producing it. That means if the current is induced due to the motion of magnet, the induced coil sets to itself to stop the motion of the magnet. For example, it is one more important thing. Lenz's law is based on the law of conservation of energy. If any time it will be asked, you can answer it. But before that, I will tell you what is Lenz's law. Let's understand. Let's suppose I have taken a cross section area, and let's suppose current is induced into it. Let's remove this as of now current. Now what I did, I have started increasing the magnetic field into this region. Now I will started increasing the magnetic field. Due to this increase in magnetic field, can I say I am changing the flux? Flux is also increasing. If flux is increasing, what will happen? Current will induce, current and EMF will also be induced. Now the question will come that current will support this or oppose this. So what is Lenz's law? Lenz's law states that EMF or current will induce in such a way that it always opposes the generation of the cause. So who have caused it? Magnetic field, increase in magnetic field. So this induced, so current and EMF will also be induced, and these two will always try, they will try to do what? They will always try to decrease the magnetic field, because who have induced this current? Increase in magnetic field. Now this induced magnetic field will try to decrease this magnetic field. So how we can do? Either it will be clockwise direction or anti-clockwise direction. Let's check the directions. I should draw like this. Let's suppose this is the cross-sectional ring, and this is the magnetic field. You can see inside direction magnetic field is increasing. If I is in anti-clockwise direction, what is the direction of magnetic field that is induced magnetic field? Anti-clockwise, outside the plane. So I will say that current will induce in such a way, this is the direction for current. Current will induce such a way in anti-clockwise direction so that it will oppose the cause. It will always oppose the cause. Now let's take the second example. Let's suppose I'm taking the second example. Let's suppose now this magnetic field is not increasing, actually it is decreasing. Now what will be the direction for induced current and everything? This is your loop. This is the direction for magnetic field. This time magnetic field is decreasing. Magnetic field is decreasing. Can I say flux is also decreasing? Flux is decreasing means flux is changing. If flux is changing, current and EMF will also be introduced. Now this current and EMF will introduced, that will try to do what? They will always try to increase this magnetic field, because who have induced them? Decrease in magnetic field. That means they will try to always increase this magnetic field anyhow possible. So I will ask you a very simple question, that what will be the direction in which they will induce? How they wanted to support this magnetic field. For supporting this magnetic field in inside direction, how it will induce? If it is induced in anti-clockwise direction, what is the direction you are getting? Outside the plane. So that means you are opposing this magnetic field even further. That means what is the direction you will induce current? It is anti-clockwise direction. If it is going anti-clockwise direction, what is the direction of induced magnetic field? Inside the plane. That means I can say this induced magnetic field and the original magnetic field both are in same direction, and now you are trying to increase this magnetic field. This is the basic statement of Lenz's law. Now next thing is EMF changing the area of coil A available. I have already told you, if you are increasing the area, flux will be increasing, and if flux is increasing, what will happen? EMF and current will be induced. So let's suppose now I have taken a wire and this wire is moving. You can see this wire is moving with a velocity v. Initially this loop was like this. Now it is moving and it is entering into this magnetic field. Now how much EMF will be generated? The formula for EMF is how much? EMF is equal to d phi by dt. Now what is d phi by dt? Phi is what? Flux. B into A divided by dt. How you can write the area of this wire? Magnetic field is already given B. What is the area you can write? What is the length of this wire? L. What is the breadth it have been covering? Initially it was at this position. Now it have covered this much distance. That means how much distance it has been covering? It is V into dt divided by dt. This dt will get cancelled, and what is the EMF formula that you will have? It is equal to B L V. And if I will ask you about the direction of magnetic EMF that is generated, which one will be at higher polarity, which one will be at lower polarity, you can simply find the direction as V cross B will give you the direction. Let's suppose if this is the direction of magnetic field, you simply do V cross B. What is the direction at higher potential you are getting? This will behave like higher potential, this will behave like lower potential. That means I can say V R dash is greater than V Q dash. In this way, EMF will be induced into the complete coil. Final result here also you can see, here EMF is written, it is equal to minus of BLV, same thing that I have told you. It is also called as motional EMF. The directions will be given by Lenz's law, and it always according to the opposing that cause that I have been creating it. कहाँ पे रखी? Currently I am in 140. 280 is the total. Now EMF by changing the orientation of the coil in the magnetic field. Let's suppose you have changed the angle between them. Now the angle, new angle is theta. So what will be the result that you will have? Flux is defined as B into A and number of turns are given, that's why I have multiplied by N, and the angle between them is theta, so I have written cos of theta. How to find EMF? EMF is simply d phi by dt. Now differentiate it, you can see everything is going to be same, N, B, A. Differentiation of cos theta will become minus of sine of theta. So eventually, and there is an internal, this theta can also be written as theta is equal to omega into t from circular motion, we know. And then there is a chain rule, that means there is a term of omega will also coming inside. So finally it will become how much? B into A into omega into n sine of theta. This is the net EMF. This complete term is represented as E naught. E is equal to E naught sine of omega t is the general result for the EMF. And after some time I will tell you this is actually an alternating EMF, AC EMF. Because there is a sine term, so it will constantly changing its direction. For some portion it will become positive, for some portion it will become negative. Here also you can see E is equal to E naught sine of omega t is the representation. Now again there is a question. A rectangular conductor is there, L, M, N, O, is placed in a uniform magnetic field. Magnetic field is given how much? 0.5 Tesla. The field is directed perpendicular to the plane conductor. When the arm Mn is of length, Mn portion is of length, that means length of it is given as 20 centimeter, is moved towards left with a velocity. Velocity is given 10 meter per second. Calculate the EMF inducted in the arm. EMF you have to calculate given the resistance of the arm to be 5 volt, 5 ohm. Resistance is equal to 5 ohm. And find the value of current in the arm. What is the value of current you will have finally? How you can solve? See, simply how to approach this question. When a rod is there moving in this uniform electric field, that means it is cutting down the electric magnetic lines of forces. That means some current will be coming, and for sure some EMF will also be introduced. That was given by Lenz's law and Faraday's law. So how much EMF is there? We know the formula, that is BLV. But the question is not asking you the EMF, the question is asking you the current. How you can define the current? It is EMF divided by the net resistance. Now, what is your EMF? BLV divided by R. So check the values, find the value of current in the arm. How much the values are given? B is given how much? 0.5 into length, that is 0.2, into velocity is how much? 10, divided by R, resistance, that is 5. When you will solve it, all these things you will have. Here it is 2, 0.5 into 2, that is 1, and the result, final result will be somewhere around 0.2 ampere should be coming. Firstly, we will calculate the EMF. EMF of the rod is given by BLV, and then it is divided by resistance. It will give you the net EMF that is generated. You can see the final result will be coming 0.2 ampere simply. Now eddy currents or fault currents, it is introduced EMF. It is unwanted currents that get induced into the surface of metal conductors, and it is unwanted, that's why it takes the power loss also, it caused in power loss. It is called as, because the result will be I square R. This I is actually what? Eddy current. So he also called a case of power loss. Induced circulating looping currents produced in a solid metal due to change in the magnetic field. That is, when you are doing electromagnetic induction, some current is also unwanted current is also introduced. That unwanted current is called as eddy current. And there is a lot of theoretical things about it. This is the due to induction. You can see here some current is induced on the surface of this metal conductor. This current is called as eddy current, and that causes in power loss. That's why we always wanted to remove this eddy current. Here lots of theoretical things are given about eddy current, how to remove it, and what is the meaning. Now the next portion will be self induction. What is self induction? It is a phenomena of inducing emf in the self coil due to change in the current and hence change in the magnetic flux in the coil. Whenever change in coil, whenever change of current is there in the coil, what happens due to that? EMF is induced, and that automatic induction of EMF of the property of a coil is called as what? Self induction. So how it is defined? It is also defined as inertia of electricity and it opposes the growth or decay of current. You know about the induction property, it always opposes the whatever the cause that you have introduced according to Lenz's law. How the formulas are there? Flux is directly proportional to current, and when you remove this proportionality you will have a constant, and that constant is called as L. This L is called as inductance or self inductance. We define the term self inductance. That means what you can also write about L. L can be written as phi divided by current. And if someone asks you, tell me what is the EMF generated, how you write EMF? The basic formula: EMF is equal to minus of d phi by dt. What is the flux? Phi is equal to Li. Just differentiate this term. I have already said that what is changing? Change in current. That means current is changing with respect to time. That means d phi by dt can be also written as L di by dt. So what is the EMF final formula that you have to remember? At the place of all these things, what is the final result that is important to remember for you is EMF is equal to L di by dt. SI unit of self inductance that we take is Henry. Mostly this value is used in millihenry, and self inductance is said to be 1 Henry when 1 ampere current is. It is the definition for 1 Henry. What is the definition of 1 Henry is given. So it is useful for your board exam or definitions for 1 Henry and everything. Here you can see the finally the result is also there. EMF induced is equal to minus of L di by dt. That whatever I have written here. Now again there is a question. Try to solve it. You have to calculate a steady current is flowing from 2 ampere to 0 ampere. It is decreasing. In what time? Time is given 10 millisecond. If an average EMF is given to you, EMF is given 200 volt. Calculate the self inductance of the circuit. What is the self inductance? That means they are asking for the value of L. Try to solve it. A very easy question if you will see properly. Just I have told you the formula of EMF. EMF is equal to how much? L di by dt. That means change in current divided by change in time. How much EMF is given to you? 200 is equal to L, you have to calculate. Change in current. How much change in current? Initially it was 2 ampere, finally it is 0. That means change in current is equal to 2. In how much time this change is coming? 10 millisecond. That means 10. It is 10 millisecond. That means 10 into 10 power minus of 3 second. That means L can be defined as, here it will become 10 power 2 into 10 power minus of 2. That means L will be equal to how much? 1 Henry as final result. Simple formula application, L di by dt. Now you have to write about self inductance of a solenoid. There is a formula that you have to remember. Here how you can write, flux is equal to L into I. So what is the self inductance you can write for solenoid? It is equal to phi divided by current. What is the flux? Flux can be written as B into A and number of turns, that is N, divided by current. What is magnetic field due to a solenoid? Mu naught Ni into cross sectional area, that is area, it is equal to pi r square into number of cross sectional, number of turns, divided by current. This complete current will get cancelled. This complete term is defined as phi. This complete term mu naught n square I a divided is defined as phi. That means L here defined as phi by a I. This I term will get cancelled and the rest of the part will become formula for L. You can remember also mu naught n square divided a divided by this I will get cancelled actually. This final result I will tell you, mu naught n square a into I. This is the self inductance of a solenoid. Energy in an inductor. The formula for capacitance was how much? Half CV square or Q square by 2C. Here what is the formula of energy? It is equal to half Li square. This is the most important formula for energy in an inductor. Here also it is given half Li square. Now there is a second term that is along with self-inductance, that is mutual inductance. What is mutual inductance? If I will tell you, let's suppose there is loop 1 and a very closed I have taken loop 2, and let's suppose flux is changing in loop 1, flux is let's suppose increasing, and due to change in flux what will happen? Some current will got induced in loop 1. Now I can say that this magnetic lines of forces are also passing through this loop 2 as well. That means I can say there was not its own flux that was changing, but due to flux 1 some flux is changing in either increasing either decreasing in loop 2 also. That means can I say some current will induce in loop 2 also. That property of material is called as, or that property of loops is called as mutual inductance. Now what is the proper formula if I will talk about? Flux on loop 2 is dependent on the current that is flowing in loop 1, and the formula will become flux in loop 2 is equal to M into I1. This M is represented as mutual inductance. It is not that much of important. The most important one is self inductance. It is just an extension of self inductance, mutual inductance. Again the same kind of formula, EMF if you want to calculate, it will be d phi by dt, that means M di by dt. Unit, standard unit always be same because it is just an extension, there is nothing in mutual inductance. Now there is again a question, try to solve it also. A rod of PQ length is given for a rod 0.5 meter, completes the circuit which is placed uniformly. Magnetic field is given as 0.15 Tesla. Resistance is given 3 ohm. What will be the force required to move the rod with a constant velocity of 2 meter per second. You have to calculate, these things are given, you have to calculate what will be the force that is required. Try to solve it. Now see how to solve this question. What is the formula for force? If you remember, it was equal to B into I into L. And how you can write current? B already you know what is the value of B? 0.15 Tesla. Length is also given to you. Length is how much? 0.5. Now how you can write current? Because current is not given. But you know one thing, current can be written as, here resistance is given. So current can, there is one more formula for current. If not directly, you can calculate current. Current can be written as EMF divided by resistance. And what is EMF? BLV divided by resistance. So that means you have to actually, if I will put these values in variables only, this formula, or not a formula, this solution will be somewhat like B into L, and this current will be looking like BLV divided by net resistance R. So this can be also written as B square L square into V divided by R. Now when you will put the values, you will have the answer. So let's see what is the answer. When you put all these values, the answer will be coming. Force is equal to 3.75 into 10 power minus 3. I have written all the variables part. B is also given. B is given. Now this is L square. L is also given. Velocity given, and the resistance is also given. So all the values are given. You just have to put the values and have the answer. Now the next chapter is alternating currents. I have already told you in the starting of current electricity that there are two kind of current. One is DC current, second one is alternating current. Basic difference between alternating current and DC current is a unidirectional and alternating current is constantly changing its direction. And if there is alternating current, that means there is alternating EMF also. So what kind of equations will be there? The definition is alternating EMF is that EMF which continuously changes its magnitude as well as periodically reverse its direction. Same is the definition for alternating current also, which continuously changes its magnitude and periodically reverses its direction. So here you can see about, if I am talking both about EMF and current, in this first section EMF and current are positive, second section negative, then again it become positive, again it will become negative. This kind of behavior is for alternating current or alternating EMF. Basic difference between, and what kind of equations will be there? It will always be sinusoidal kind of equations, because sinusoidal curve has always positive, negative. This kind of curves are always for sine terms, and either kind can also possible for cos theta also. This is the curve you can see here. Some, if I will reverse the, if I will write this equations in cos term, this will be the curve. If I am writing the equations in sine term, this kind of curve will be there. You know the basic curves of sine theta and cos theta. These are the representation, instantaneous value, peak value. This one is important. The representation of source symbol of AC. It is represented somewhat like this. If this is represented, that means it is the source of AC EMF. Now average value of any EMF. Average value, if I will tell you about, you can write average value of any kind of things. It is integration of f of x dt divided by integration of dt. Simply, it is general value. In this chapter, what is the average value of current that you have to remember? It is equal to 2 I naught by pi, average value, and average EMF is equal to 2 E naught by pi. I naught is what? It is peak current, and E naught is what? Peak voltage. Now next and the most important one is RMS. How to calculate RMS values? RMS value of an alternating current is the steady current which would produce the same heat in a given resistance in a given time produced by the alternating current. How to find an alternating RMS value is more important. Let's suppose the equation is given somewhat like this. I is equal to, how to calculate RMS value of any kind of equation you can calculate. I is equal to I naught sine of omega t. So for RMS, always read it in opposite term. Firstly, you will square it, then average, then root. Firstly, square it. What it will become after squaring? I naught square sine square into omega t. Second one is what? Mean. Take the average. When you will take the average, I have told you how that average value of sine square theta or cos square theta is how much? Half. So after this second step, how much it will become? I naught by 2. What is the third step? I RMS, if I will tell you to find, just take the root under. If you are taking the root, how much it will become? Root under. Sorry, here I naught square is there. I naught square is there. So finally it will become I naught divided by root 2. That is the standard formula. I RMS is equal to I naught divided by root 2. In this way, you can calculate RMS value of any kind of thing. Even ERMS. Let's suppose if someone asks you what is RMS value of voltage, that is also E naught divided by root 2. Same thing is given here also. So there is a basic question. A general equation is given for voltage 140 sine of 314t 314t of a pure resistor. Resistance is given 50 ohm. First thing is find the frequency. What is the frequency? And second one is what is I RMS. These two values are given. You have to find these two variables. If you write the general equation, what is the general equation? You can write V is equal to V naught sine of omega into t. And if you will compare from these two equations, what you can say about omega? How much it is given? 314. It is equal to, omega can also be written as 2 pi f. So you can have the first part answer, frequency, from here. 314 divided by 2 into pi. Pi is how much? 3.14. If you will cut this, how much it will become? 100, and there is 2. That means final answer will be, frequency will be coming how much? 50 hertz. Now second part. First part answer is 50 hertz, simple. Second part, how much you can say? What is V naught? See, there are two values. One is, it is called as peak current and it is called as RMS current. How much you can say for peak current? Peak current can be written as V naught divided by R. What is V naught? 140 divided by, what is the resistance? 50. So it can be written as 14 divided by 5. This is I naught. And how you can write I RMS? I RMS can be written as simply 14 by 5 divided by root 2, because you know what is the formula? it is equal to I naught peak current divided by root 2 is the formula. Simply I would firstly calculated I naught and then I have divided by root 2. When you will solve it properly, this value will be somewhere roughly around 2, or also called it is roughly around 1.9 ampere. This will be the RMS value. So what will be the AC circuit with a pure resistor? Let's suppose EMF is given as E is equal to E naught sine of omega t, and the resistance R is there. Current is written as E by R. So what is the EMF? E naught sine of omega t divided by resistance. This will be, so what will be the general equation if I will ask you? I is equal to I naught sine of omega into t. This will be the general equation that I have written here. And the most important thing that is you have to note in current in pure resistor is EMF and current are in the same phase. You know how to represent in phases for current and EMF. Let's suppose if I am saying EMF is represented in x direction, current is also can be represented in x direction, because the phase difference between EMF and current is 0 in case of pure resistor. You can see here, if this is the direction for E naught, the direction for I naught is also same because the phase difference is 0. Now second case, AC circuit with a pure inductor. Again I have taken the same source, E is equal to E naught sine of omega t. Induced EMF can be written as minus of L di by dt. So EMF is equal to L di by dt. E naught is given. When you will try to find, it will become dl can be written as finally what is the final result you will write, I is equal to I naught sine of omega t minus of pi by 2. What is the general equation of EMF? E naught sine of omega t. Final result that you are getting is I is equal to I naught sine of omega t minus pi by 2. What do you understand from here? In pure inductor, current is lagging by how much phase? What is the phase difference between them? Phase here is omega t, phase here is omega t minus of pi by 2. So if I will ask you about the phase difference will be pi by 2. And who is leading, who is lagging? Actually current is lagging in an pure inductor circuit. If I will represent them on phases, if I am representing this as V, that is potential, I have to represent I in downward direction because it is lagging by an angle of how much? Pi by 2. This will be the diagram. One more important thing, this omega L is called as what? Inductive reactance. What is the formula of inducting reactance? It is omega into L. This is also there from the general form. The behavior will be same like a resistance. The unit will be same like ohm. Capacitive reactance. Inductive reactance. And you can see here it is written current lags behind by EMF of pi by 2. Current lags behind EMF by pi by 2 radian. Now next one will be firstly here it is represented. If this is E naught, that is E naught, this voltage is leading, and you can see current is lagging by how much angle? 90 degree. Now AC circuit with a pure capacitor. Again we will calculate current. Q is equal to C into V. That means it can be written as C E naught sine of omega t. What I can say for current? It is dq by dt. Differentiate this equation, you will have I is equal to dq by dt. When you will differentiate it, you will have the final result at I is equal to E naught 1 by omega c into sine of omega t plus of pi by 2. Now what are the things that you have to note it down from here? Firstly, this complete term is called as what? Xc, also known as capacitive reactance. Second thing is what? What is the phase difference between EMF and current here also? Pi by 2. But this time who is leading? Actually current is leading by a phase difference of pi by 2. If I will represent it in phases, how I will represent? This is the direction for voltage. That means this will be the direction for current. Current is leading by an angle of pi by 2. Last case it was lagging, but in capacitive circuit it is leading by a phase angle pi by 2. And I have told you this 1 by omega c is the formula for capacitive reactance. Here also the diagram is representing you. This is the direction for E naught. That means E naught will be lagging in this case, and this is the direction for I naught. I naught is lagging, leading in this case by an angle of pi by 2. Now this time finally we'll combine all these three circuits that you have studied till now: resistance, capacitance and inductance. These three now will come in together, and let's see what is the general equation that you will have. EMF is given E is equal to E naught sine of omega t. Again we will try to draw the diagram. I will be written as, what is general current? In general current, EMF divided by resistance. But in alternating current, you know that this resistance is replaced by what? Z. And this Z is called as what? This Z term is called as what? Impedance. What is impedance? It is same like resistance. The net resistance offered by the combined circuit by resistance plus capacitance plus inductance is called as impedance. And how it is written? This is the direction for representing resistance. In positive x direction, if I am representing resistance, this will be the direction to represent XL, that is inductive reactance. This will be the direction to represent XC, that is capacitive reactance. So it can be also be written as, I will represent Z, I will write the formula of Z. If anyone, let's suppose I am saying that XL is greater, that means I will write this as XL minus XC, and on the x-axis it is R. So the net resistance will be going, these two are in parallel. So what I will write, it is root under XL minus XC into whole square plus R square. This will be the net impedance that will be taken. Here is also given root under R square plus XL minus XC whole square. So important thing that you have to notice from this combined circuit is how to write impedance when all these three things are in combined form. Now there is a question, try to solve this question. Now see, it is a kind of question of combination. Resistance is also given, inductance is also given, and capacitance is also given. And there is a general equation given of alternating voltage E is equal to 140 sine of 100 pi t volts. Okay. See how to solve this question. This is a very long question. If I have to find voltage across resistors, how I will write? I into R. That means the net RMS current that will be coming. Then I will multiply it by R. If I have to write across this capacitance, how I will write? I into XC, that is capacitive reactance. If I have to write across inductance, I will write I into XL. So firstly I have to calculate all the values XL, XC, then I can solve it further. So I will firstly solve XL. How much XL will be coming? What is the formula for XL? It is equal to omega into L. And what is XC? It is equal to 1 by omega into C. You can see here, what is the value of capacity 1 by omega into C? It is coming how much? 200. And then inductive reactance, it is coming how much? 500 ohm. So what you can say about Z? Effective impedance. What was the formula? On x-axis what you represent? Resistance. How much resistance? 400. On positive y-axis what you represent? Inductance. What was inductance coming? 500 after solving. And on negative y-axis what you represent? Capacitive reactance, that is coming equal to 200. That means how you will solve this? On net y-axis what is the inductance you can say? It will eventually become 300. That means Z you can say 300 square plus 400 square. That means net Z will be coming how much? I guess it will be coming 500 ohm. Once it comes 500 ohm, that means now you will use the value of Z as 500. Let's solve it further. Now peak voltage is 140. So can you calculate I naught? I naught can be written as V naught divided by Z. What is V naught? 140 divided by 500. Whatever the answer will be coming, you can write it down. And finally, even you have to reach till RMS value also. So I RMS you will write. It is equal to I naught divided by root 2. Once you got I RMS, now you can calculate any value. What you will do? Multiply I RMS with resistance. How much resistance? 400. Multiply I RMS with capacitive reactance. Capacitive reactance also you have calculated 200. Multiply I RMS with inductive reactance. Inductive reactance you have calculated 500. Eventually you will have all these answers. You can see here also. Firstly you have to calculate I RMS. You will get 0.2, and then VRMS is equal to 0.2 into 400. That will be equal to 800. 0.2 into 500. That will be 100. And RMS across the capacitor is equal to I RMS into XC capacitive reactance. Finally the answer will be coming 40 volt. In this way you can apply all these formulas and have the answer. Now what is resonance condition in LCR circuit? Resonance condition is generated when XL is equal to XC. So what is the resonant frequency also? It is derived from here only. XL is equal to omega L is equal to XC. What is XC? 1 by omega C. So you can write also omega square is equal to 1 by L into C. So resonant frequency is given is equal to 1 by root under L into C. This is the resonant frequency. You can see same thing is written. In this case, some things that are important. Z is always minimum because the what was the term for Z? Z formula that we have written was equal to root under XL minus XC whole square plus R square. Now XL is equal to XC, that means this complete term will become 0 and then minimum condition will be coming. That frequency at that term is called as resonant frequency. Formula already we have seen. The same thing is written here. Now the question regarding that will be, an inductor is given unknown value, capacitance is given 100 millifarad. Second one, resistance is given 10 ohm, are connected in series to a battery. VRMS is given 200 volt along with frequency also given 50 hertz. It is found that power factor is unity. Power factor is unity. Power factor is actually R by Z. That means Z is equal to R. Then if Z is equal to R, that means it will get cancelled. And what is the answer coming? 1. That means I can say it is a condition for resonance. Because when Z is equal to R, when XL is equal to XC, that means I can say resonant frequency is given actually in indirect terms. Calculate the inductance of the inductor and the current amplitude. The question is asking you calculate what is inductance. Second one, question is asking you to current amplitude. That means what will be your I naught. So you know it is a condition for resonant frequency. That means how you will solve it. You will write omega is equal to root under 1 by L into C. And frequency is given, that means you can write omega also as 2 pi into 50 frequency 2 pi f, and here you will take the square on both the sides, and you will take L here. C capacitance is already given to you, and you will use that relation for finding first answer you will get. Like see here, XL is equal to XC, here it is written, and when you have taken this capacitance here, you will solve it. L is equal to, the little bit of calculation will be there. Finally answer is coming how much? 101.2 millihenry. Peak voltage is given. If peak voltage is given is equal to 2M, it is actually RMS voltage. So peak voltage V0 can be written as V0 by root 2 is equal to V RMS. So what you can write for V0? It is root 2 into V RMS. How much V RMS given? 200 into root 2. And if U0 V0, you can calculate I0 also. I0 will be equal to V0 divided by R. What is the value of V0? 200 root 2 divided by resistance. Resistance is given as 10. Answer will be finally equal to 20 root 2 ampere. So this way you can solve. Now about quality factor, bandwidth is defined as 2 into delta omega. A simple thing that you have to understand, the quality factor formula is resonant frequency divided by 2 delta omega. The concept is, the more sharper the curve will be, the more better quality will be there. So I can say here quality factor for 1 will be greater than quality factor for 2, than the quality factor for 3. Definitions are given, you can understand. Now the last and the final thing of alternating current is transformers. Now what is transformer? Why it is used? It is used in near our homes also, and transformer is a device which converts lower alternating voltage at higher current to higher alternating voltage at lower current. So basically the work of transformer is to convert the lower voltage to higher output. Like lower voltage you have taken 220 volt and you have to increase the voltage, or either you can decrease the voltage also. There are two types of transformers, that's why. One is called as step up transformer, second is called as step down transformer. Step up transformers are usually used near industries, step down transformers are usually used near the city areas. So let's see what is the concept of transformer. It is based on actually mutual inductance. What is happening? This portion of this coil is called as primary circuit, and this portion is called as secondary circuit. Also some names are given. This segment is also called as input segment, and this segment is called as output segment. Names are important. This is primary, this is secondary. Now see how the relations are coming. This is number of turns here. Principle is based, it is the principle of this transformer is based on mutual inductance, that I have already told you, electromagnetic induction. How to find the formula? How you will write the EMF? EMF was actually equal to d phi by dt, that we have understood from electromagnetic induction. But d phi by dt along with number of turns are there. Let's suppose number of turns in primary circuit is NP. So I will write the same thing. And what is the EMF generated in the secondary circuit? It will be equal to again d phi by dt. Same flux is transferring to the secondary circuit, and I will multiply it by number of turns in secondary circuit, and then I will take the ratio. When I will take the ratio, some important results are there that you have to remember. For ideal transformer, it is the case that ES is equal to EP IP. Otherwise, the case that you have to remember is EMF of secondary circuit divided by EMF of primary circuit is equal to number of turns in secondary circuit divided by number of turns in primary circuit. This is the first relation that will solve all the questions nearly of transformer. When you will take the ratio, that same relation will give you the answer. Here d phi by dt will get cancelled out, and only thing left is NP divided by NS, EP divided by ES. Same relation is written here also. ES divided by EP is equal to I. It is inversely proportional with current, and NS divided by NP. These two relations that we have proved just now. Efficiency of anything is what? Output power divided by input power is efficiency, and for ideal transformer, output and input both are same. That's why it is said that it is 100% efficient. Now there are two types of transformer that I have told you. Step up transformer, second one is step down transformer. What is step up transformer? Step up transformer is used near the industries where the current is induced, and the property of the step up transformer is output voltage will be greater than input voltage. That means it will kind of magnifying the voltage, it will increase the value of voltage. Step down transformer is used, output voltage is less than the input voltage. These two are the basic properties of step up and step up down transformers. And obviously according to that potential there is some NS-NP relations can also be written. Now energy loss in transformer, there are lots of theoretical things in. One is copper loss, second is flux loss, third is iron loss. In iron loss there is again a term that is eddy current loss that we have studied in electromagnetic induction, eddy current loss. How to remove this? There are also it is usually used to laminated cores. When you remove the surface area, you decrease the surface area, the current will that is inducing is less, and if current is inducing less, that means power loss is also less. There is hysteresis loss. There are lots kind of losses that happens in transformer. So that's why we say that efficiency can never be achieved 100%. The maximum efficiency that we can achieve is still nearly 30 to 40%. Now try to solve this question. The primary coil is given and step up transformer is there, that means has 100 turns. Firstly, write a primary coil of it is given NP 100 turns, and transformation ratio is given also 100. That means N factor that is given is 100. That is what is the meaning that it is saying transformation input divided by output is given 100, or also it can be written as primary divided by secondary is given as 100. The input voltage and the output voltage is respectively input voltage is given how much? 100, this value, this complete value is given as 100. So from here only you can calculate one more basic thing, output voltage, or also can be written as secondary voltage. It can be written as 100 into 100, that means how much? 10,000 volts will be in the output or secondary circuit. So one question is already solved. Voltage across the secondary circuit we have solved already, it is 10,000 volts. Now next thing, number of turns in secondary circuit. How you can find? You know the relation EP by ES is equal to NP by NS. What is the number of turns in secondary circuit we are asking? If secondary circuit is asked, how you will solve it? Do it like this, here NP number of turns in primary circuit into ES divided by EP. What is number of turns in primary circuit? 100. EMF in secondary circuit, how much you have calculated in secondary circuit? You have calculated 10 power 4 divided by, in primary circuit how much it is? Primary circuit voltage is 100. So what is the number of turns for secondary circuit is 10 power 4. Number of turns will be there. So this part is also solved. Number of turns in secondary circuit you can check from here. Number of turns in secondary circuit is 10,000. Third part also we have solved. That was voltage across secondary circuit was given 2200. I guess the relation here it is given 220 volt. The value we have taken is wrong. Now next portion, how I will calculate current in secondary circuit is given by, power is already given. How much power was given? 220. Let's see what is the power given. 1100. This much watt is given. So how I will solve this? Power is equal to V into I. For what portion you are solving? Let's suppose you want current in primary circuit. So how I will write this formula? Vs into Is. Already we have calculated Vs. Already we know V power. That means Is will be written as simply power divided by Vs. You can see here Is can be written as power divided by Vs. When you put all these values, all the values are given, you will find the answer 0.05. Same way you can solve this part also. Current in secondary circuit, for finding D option, how you will calculate? Power is in secondary circuit, if you want to calculate, it will be written Vs into Is, and how you will write the current? It is equal to P divided by Vs. Just put the value. P is equal to how much? 1100 watt. Vs secondary circuit put value you have calculated, that will be just putting the value, that will be equal to 22,000 you will have the answer. Here you can see. This current in primary circuit, just put the values, you will have the answer is equal to 5 ampere. And finally, power, the last portion that has been asked. Power in secondary circuit will be equal to power in primary circuit. Reason being, it is an ideal step-up transformer. Power is always same for step-up transformer and ideal transformer. That's why the efficiency also comes as 100%. So this was about magnetism part, complete magnetism portion. Now we'll enter into the third portion of physics, that is optics. Now we are talking about light rays, reflection, diffraction, and the different phenomena of lights. Thank you.
Cake दो यार सर को. Cake. You coming? Who's sleeping? Sleepy people will come.
Okay.
How's the Josh? Hello, sir. Hi, sir. Okay, fantastic. I need a volunteer before we start the last leg of the marathon. Let's do an experiment. So, who's going to volunteer? Come, Moshes. Give him a round of applause, guys. What time is it? 1:34. Oh, that's it, right? We still have how many hours to go? That's it. Are you guys tired? No? Fantastic. You know there is an exam at 6:30, right? Are you guys prepared? You taking a class the whole night. How more prepared can you be? Right? Fantastic. So this is the experiment which Shreyas is going to conduct. This is a loudly.
Beaker.
This is a
Small beaker.
chota beaker. Correct. Now I want Shreyas to do some magic and disappear one beaker.
Everyone just close your eyes for.
So you have to go ahead and disappear one beaker. Can you guys see the beaker? Yes. Okay. Put what?
Water.
Is it? Will water help? If you put water? Okay, we'll try. Put water. Let's see. So what do you want to just fill it up? Okay. Can you still see the beaker? Yes, no. Okay. Do what you want to do. Can you still see the beaker? You can't? No. Can you see the beaker? Can you do something better to completely make it invisible? Is it possible? Can we use some other substance than water? Yes, no. Yes, no, possible, not possible. What is the possibility then? What is the possibility?
Oil would be better.
Oil would be better. Let's try with oil. We need to clean it off, clear it off. Somebody, please drink the water. Don't waste water. Water is precious. You cannot waste water. Drink it up. Don't drink it. Just throw it somewhere and come. Don't throw the beaker inside it. We just have two beakers. We are on a budget. Shreyas, you're preparing for
J.
JEE. Physics is your favorite subject?
Yeah.
You're saying it because Abhishek sir is sitting here?
No.
No? You really like physics? Okay. Yeah. Teeth. We have NEET student also, future dentists, so he can spoil his teeth a little, no problem. I know. Being a dentist is not so bad. Okay, we need a dentist. His teeth don't work. Okay, we really need a dentist there. His teeth don't work. Okay, I think he wants to wait till 7 o'clock by doing this. You can put in the middle, no problem. Okay, can you see the beaker inside? Yes, right? If you can't, you need an optician too. Guys, where is the beaker? Is it gone completely now?
Magic.
Shreyas is a magician. So if he doesn't get into IIT, what's the next profession? Rabbit out of hat. But we are sure Shreyas will go into IIT. So now quickly comment and tell us what rule of physics was applied here. Or to know more about it, tune into the next segment by Abhishek sir. So give him a big round of applause for doing the marathon and doing a lovely job.
So now we'll start the third portion of physics in PO2 syllabus, that is optics. And in optics also, optics is divided in two parts. One is ray optics, second one is wave optics. So firstly we are going to understand ray optics. That is the behavior of light. We are basically going to talk about light now. We have completed that magnetics, effects and charges, everything is done. Now we are going to talk about ray optics. This complete optics portion and modern physics was introduced just due to a debate in history. Debate was about light. What is the property of light? Either it is wave nature, either it is particle nature. So complete ray optics and wave optics prove that light is actually what? Wave nature. And complete modern physics prove that light is actually what? Particle nature. Not I will say particle nature, but dual nature was adopted in modern physics by some scientists, you know, like de Broglie was there, Einstein was there, Max Planck was there. They have performed some experiments and they have given and they have ended this debate that was light is what? Either wave nature, either particle nature. They are actually dual nature. So in the first section of that, firstly we will understand ray optics. Firstly I will start from reflection. Basic thing that we will quickly cover about reflection. What are the laws of reflection that you know from the basic classes? What is laws of reflection? Let's suppose if I will take a plane mirror, I am starting from very basic plane mirror. Let's suppose this is a ray that is incident and this angle is called as I. Now some important terms that you have to understand. This I is called as what? Angle of incident. This ray is called as what? Incident ray. And the reflection that will happen from this mirror will be called as what? Reflected ray. This angle is called as what? Reflected angle. And this line that I have drawn, dotted line, this is called as what? Normal. Normal means perpendicular to the plane mirror. So laws of reflection says what? All these three, incident ray, reflected ray and normal, all lies on the same plane. But more important than that also, second law was what? Angle of incidence is equal to angle of reflection. Reflection in first case, sorry. So if I'll ask you one more thing, what is the deviation you can say? What is the deviation? In a plane mirror, how much deviation you can say? What is deviation? Angle between the original ray that was proceeding, this I can say this was the original ray that was going, but finally it bent and it went like this. So the angle between original ray and the bent ray, this angle that is created or change created, that is represented as delta, or it is also called as deviation. So how you can calculate this deviation? Let's see. How much you can say for this complete angle? 180. And how much deviation you can say? 180 minus of I plus R, angle of incident plus angle of reflection. So it can also be written as I and R are actually equal. So it can also be written as 180 minus 2i. So standard formula, if I will talk about, angle of deviation is given as pi minus 2i is the deviation for plane mirror. This is the deviation for plane mirror. If I will talk more important things about plane mirror, what is the property of images by plane mirror? Let's suppose this is a plane mirror I have taken. Let's suppose here is my object and this is the distance from the plane mirror. So I will say image will be formed exactly at the opposite side of the mirror, and the distance, this is the distance of object, this is called as what? Distance of image. And plane mirror, the property of plane mirror is distance of object is equal to distance of image. Very basic property but important. Distance of object is equal to distance of image. Let's suppose height of object is HO. That means what is the height of image? It is also equal to height of object. This is also one property. Next property you can say if object is there, suppose coming towards the mirror with 2 meter per second, that is what will be the effect on the image also? Image will also coming towards the mirror with a velocity 2 meter per second. These are some basic properties about plane mirror, reflection from plane mirror. Now let's see for concave and convex mirror. This kind of mirror is called as what? This is called as what? These are the two kind of mirrors, spherical mirrors. What this mirror is called as? This is called as concave mirror. This is called as what? Convex mirror. You know, if you know about the properties, the property of concave mirror is converging and the property of convex mirror is diverging. Some important points if I will talk about. This point is called as what? Pole. This axis is called as what? Principal axis. From pole to this point F, this distance is called as what? Focal length. And this point is called as what? Focus. Then there is a point C. What this C is actually? Center of curvature. And it is represented by a distance that is R. This R is representing what? Radius of curvature. Okay. So these are some basic things that you already know. If let's suppose if this is called as aperture length, what is the radius diameter of this mirror portion that you have taken? So now about the image formation, what is the mirror formula that you know? Mirror formula is what? 1 by V. For example, let's take up fresh page. Here it is reflection of light. Let's wait. So let's take a mirror, standard mirror, concave mirror I am taking. This is pole. Here is the object kept, and somewhere here, let's suppose image is forming. The distance of object to the pole is called as what? U. Distance of image to the pole is called as what? V. U is represented for object and V is represented for image. So what is mirror formula? 1 by V plus 1 by U is equal to 1 by F. So this formula can also be written as V is equal to UF divided by U minus F. Same formula, just the way of writing is different. It will give you the answers firstly. So better you are remembering this formula. What is the formula for magnification in a mirror? Magnification formula is minus of V by U. This is the magnification formula. So let's suppose I will tell you from an example, because the sign conventions are more important. Let's say I am giving you some values. I will solve that question. What are the sign conventions that you know? In sign conventions, remember only one thing, that direction of incident ray is always taken as positive. Let's suppose focal length of the mirror I am giving you 10 centimeter and U is given equal to, let's suppose you can say, let's suppose it is given 20 centimeter, and I am asking you where the image will be forming. What will be the position of your final image? So how you will solve it? What is the formula? 1 by V minus 1 by U is equal to 1 by F. So start putting the values. 1 by V that we want to calculate plus 1 by U. Now this point behaves like 0, 0. Now for calculating U value, you have to go in the right side or in the left side? in the left side, and I am saying that if this is my object, some rays will be coming like this. That means I can say this direction is behaving like positive. That means this direction will behave like negative. For calculating the position of object, I have to come in negative direction. And how much? What is the distance of object? Minus of 20. So I will write it with sign conventions. Minus of 20 is equal to 1 by f. What is the focal length of this concave mirror? It is equal to 10 centimeter. 10 centimeter, it will be taken positive or negative? It will be taken negative, because the center of this complete mirror will be lying on the left side, so it will also be taken negative. Minus of 10. Now let's see what is the position of V is coming. Minus of 1 by 10 plus of 1 by 20. Here you will multiply 2. In numerator also you will multiply 2. So what V you will get? V is equal to, you will getting minus of 20 centimeter. And you know the property, if you know the ray diagram, if object is kept at center of curvature, image is also forming at center of curvature. Because focal length was 10 centimeter, that means object is actually nothing where it is kept at center of curvature. This is a basic application of. Now directly we will come to the these are some basic things that I guess you already know. Now we will start from refraction. Refraction, same like reflection, it will also having some laws. Like, what are the laws of? Firstly I will tell you. Let's suppose this is it is called as interface. This is called as what? Incident ray. This angle with the normal is called as incident angle. Now previously we are watching that it was reflecting back from the surface, but this time I am taking an interface, not a mirror. So I will not polish this side. Now what will happen? This light will bend its path. It was the original ray. Either it will bend towards the normal, either it will bend away from the normal. And this angle from the normal is called as what? Refractive angle. So what is the property? Incident ray, normal and reflected ray, all of them are lying on the same plane. But most important property of refraction is nothing but Snell's law. Snell's law says that, let's suppose this is your incident medium. Again this Ni and Nr is what? These are refractive index. And what is the formula of refractive index? N is equal to C by V. So what is Snell's law says that? Snell's law states that Ni sin I is equal to Nr sin of R. Complete refraction is based on Snell's law. Every equation that we are going to derive is from Snell's law. Ni sin I is equal to Nr sin R. Here the statement is also given for a given pair of media and for a given pair of light. The ratio of the sine of angles of incidence to the sine of refraction is a constant. That is the statement of Snell's law. You can remember it. Basic properties is Ni sin I is equal to Nr sin R. Now through a parallel slab, if you will notice what is the effect that is coming. Let's observe that. Here some angles are mentioned. This angle is I. This angle of this is called as what? Angle of refraction. Obviously if you are coming from rarer to denser, one more important thing remember, if you are coming from rarer to denser medium, light will bend towards the normal, and when you are going from denser to rarer medium, light will bend away from the normal. So this angle is R1. Now again light ray will be reaching here. This was the original path. Now you are going from denser to rarer, that means light ray will bend away from the normal, and finally actual ray will be emitting like this. So from geometry I can say this angle R1 and R2 are actually nothing but same. So if you are writing Snell's law on the first surface, what is the Snell's law? You write N1 sin N2, this medium is given as N2 and that is N1. N2 sin of R1 is equal to, and this is the first equation. Then you will write the second equation. N2 sin of R2 is equal to N1 sin of E. And you will notice that actually R1 and R2 are same. So if R1 and R2 are same, can you say I is also equal to E? That means from here I can conclude that my incident ray and the final emergent ray are nothing but parallel, because both these angles are same. But this was my original incident ray, this is my emergent ray. If they are parallel, but there is a shift coming, and this y distance that is represented, that shift is called as what? Lateral shift. This shift is called as lateral shift. Now we will calculate that lateral shift. How we can calculate? Firstly, you will apply some basic geometry. Let's suppose I am naming this triangle, and no need to name this triangle also. Try to write this angle cos of theta. Let's name these points. Let's suppose this point is A, this point is B, this point is C, and this point is already given M. In triangle ABC, try to write cos of R1. Cos of R1 is what? Base upon hypotenuse. What is the base you can write? T divided by, what is the hypotenuse you can say? A into C. So what is AC you can write? T sec of R1. This is the first equation. Now come in triangle 2. In triangle 2, if this is deviation, what you can write about deviation here? Deviation is equal to I minus R. Deviation will be equal to I minus R. In triangle 2, ACM, try to write sine of I minus R. What is sine theta? Perpendicular upon base. What is perpendicular? CM. Or also I can write this complete shift as a lateral shift. I have named this as lateral shift divided by hypotenuse. Hypotenuse is how much? AC. This is second equation. And can I say I have already calculated this AC? That means, and this complete term is what? Nothing but lateral shift. That means I can also say that lateral shift is equal to AC into sine of I minus R. Now, what is AC you can write? AC from first equation you have written T sec of R1 into sine of I minus R1. So finally this is the final result that you will get for lateral shift. T sec of R1 sine of I minus R1. This is a lateral shift that you will observe. After that, this is the same result that is finally coming here also, T sine of I minus R1 into divided by cos of R1. Now apparent depth of the liquid. What is the effect that will be coming due to this refraction pattern? Let's understand that. See what is happening actually, I will tell you. Understand here. I have taken again an interface, and let's suppose here is the observer. Here is the object. Distance from the interface to the object is represented as, let's suppose, distance of object du, or also called as real depth. You have noticed that whenever you will put a coin in a glass, it will looking like it is closer to you than the actual distance. Let's see why that phenomena is occurring. So for making any kind of image, I need two rays. First is I will take perpendicularly, that is pass on without any deviation. Second ray that I will take it at some angle. Now let's suppose this medium I have not given. This medium is, let's suppose, water, and let's suppose this medium is air. That means I am moving from denser to rarer medium. If I am moving from denser to rarer medium, light will bend towards the normal or away from the normal. It will bend away from the normal. That means light was actually going like this, but it will bend away from the normal. That means if you will observe on one side of the interface, it is never going to converge at a single point. But when you will take this light ray back, it will converge. It will appear to converge at a point, and that point will be called as what? Image. And the distance from the distance from the interface to this image is called as what? Distance of image. Di, represented as di. So some important representations here. D naught is represented as, it is actually the real depth. It is called as what? Real depth. Di is called as what? apparent, it is called as apparent depth. So if someone asks you what is the formula of distance of image is given as distance of object divided by n of incident medium divided by n of refracted medium. This is the formula for distance of image. That means in this case how much you can write? Distance of object is d naught. Incident medium is what? Water. That means I will write n of water. The refractive index of air is what? 1. So finally I can write it is equal to nothing but d naught divided by n of water. Now you can see there is a shift coming between image and the object. This shift in the object and image is called as what? Normal shift. This is called as normal shift. How much I can write for normal shift? Normal shift is equal to the actual distance, real depth d naught minus distance of image. So further it can be written as d naught minus what is distance of image? D naught divided by n of incident divided by n of refractive. Now take d naught common. What is the formula? 1 minus 1 by n of incident divided by n of reflection. This is the normal shift formula. This is called normal shift completely. This distance is apparent depth, this complete real distance is called as real depth, and this shift is called as normal shift. For your eyes that you are watching from here, it will be looking actual the coin. Let's suppose if I am talking about coin, this coin will be not looking here, actually it will be looking at this distance from the interface. Now let's have a question. See how to solve this kind of question. This is your object, this is your observer. That means your eyes are here. Let's suppose you are watching from here and there is the object. First ray again it will go perpendicular and it will reaching to the eyes. Second ray will go at some angle, it will bend again away from the normal, and somewhere it will be crossing at this point. This point will be called as image. Now what you can say about distance of image? It is equal to distance of object. What is the distance of actual object? X, it is represented as x divided by n of incident medium. Which is the incident medium? I can say water is the incident medium and air is the refracted medium. So what you can say here, 4 by 3 divided by 1. There is no need of writing 1. So what will be the distance? You will get 3x divided by 4. But this is not the final answer, because the question is asking you as observed by bird. So what is the total distance you have to write? Total distance that you will write is this, the apparent depth that you got, 3x by 4. And what is the distance from this interface to the bird? Is y. So the total distance you will write is 3x plus 3x by 4 plus y. This is the complete distance as observed by bird. Now those things. मेरा दोस्त है. The apparent depth concept already we have seen. Now the next thing is TIR, total internal reflection. TIR is the phenomena of complete reflection of light back into the same medium for angle of incidence greater than the critical angle. Let's see what is the meaning of TIR. TIR always occurs. There is some conditions for TIR. When the light ray is moving from denser to rarer medium, this phenomena is called as TIR. Here is the object. Here is the. So firstly, let's suppose I have taken at some angle. You know that when if it is perpendicular, I is equal to 0, that means R is also equal to 0. Now I have taken at some angle. This angle is I. Light will bend away from the normal, that means this angle will be R, and I can say in this case R is greater than I. Okay, I will take the next ray. Then I will notice that further R is in increase from the last case also, and this is angle of incidence. If I will take one more ray and if I will increase, I will reach to a certain point where this I will be, I is called as, this angle is called as critical angle. The angle of reflection is becoming 90 degree. This condition, when light ray is not actually coming out of the surface, this condition is called as what? TIR. There is a critical angle condition, and let's suppose if I have taken one more ray, then what will happen? Snell's law will actually fail. Reason being, let's see. Firstly, try to write the Snell's law here. What you will write? Incident medium n of denser into sine of I is equal to n of rarer into sine of R. What is sine of R here? 90 degree. So I can say sine of I, n of denser into sine of I is equal to n of R. So what is the one more thing, important formula also derived from here? Sine of I is equal to, I can say it is actually critical angle. So formula for critical angle will be n of rarer medium divided by n of denser medium. So this is the first thing. Then why Snell's law fails? Let's understand that. This is a general Snell's law, you can say. Now you are saying that, again I will write here, n of incident into sine of I is equal to n of rarer, that is air, into sine of R. I can say that R have already reached to its maximum value. If further I will increase this angle of incidence, now I can say this angle of reflection cannot be further increased because it have already reached to its maximum value. So at this condition I will say that Snell's law fails, and when Snell's law fails, it will start performing the normal reflection that you know. See, in the next time further I will increase this angle of incidence, and when I will increase the angle of incidence from the critical angle, it will start performing normal reflection. You can see angle of incidence is equal to angle of reflection. This phenomena of light in which it comes back into the same medium for angle of incidence greater than the critical angle, this phenomena is called as TIR, total internal reflection. Here it is clearly shown that I is greater than critical angle. So condition for TIR can be, what is what? The incident ray must be in the optical denser medium. Incident ray should be going from denser to rarer medium. This is the first and the most basic thing. Second one is angle of incidence in denser medium must be greater than the critical angle. And how you will calculate critical angle? What is the formula? Sine of critical angle is equal to n of rarer medium divided by n of denser medium. Now relation between critical angle and refractive index, that I guess already I have told you. What is the relation? Sine of C. C is what? Critical angle. It is equal to n of rarer medium divided by n of denser medium. What are the applications of TIR? You know the practical applications: mirage formation in deserts of water. It is the application of TIR. Looming, total internal prism, optical fiber. Optical fiber is very important. It has been asked in competitive exams also. How TIR helping in optical fibers. All these applications are given in NCERT in complete depth. You can read out from there. A very basic question is there, try to solve it. What is the value of critical angle for a material of refractive index is equal to root under 3? So see, very basic question based on the relation that we have studied. What is the value of critical angle? What is the formula? Sine of C critical angle is equal to n of rarer medium divided by n of denser medium. Refractive index is given as root 3. So rarer medium is obviously air. That means it is equal to 1 divided by denser medium is root under 3 sine of C. So C can also be written as sine inverse 1 by root under 3. This answer is roughly around 35 degrees. This is not a very standard angle. So answer will be somewhere equal to 35 degree critical angle. This is not a standard angle. Now spherical reflecting surfaces. Now we will understand about reflecting surfaces, how reflecting surfaces actually work. Not about spherical mirrors, it is about reflecting surface. It is also part of reflecting, it is filled with reflecting material. There are two types of again reflecting mediums. Reflecting surface which is convex towards the rarer medium is called as convex reflecting surface, and reflecting surface which is concave towards the rarer medium, that means towards air, is called as concave reflective surface. These are the two ones, rarer medium, this is denser medium, again rarer medium, and then the denser medium. Same kind of definitions. This line is called as what? Principal axis. This center point is called as center of curvature. P is called as pole, and radius of curvature. Now reflection from convex mirror, convex surface. It is surface mirror name. See how the derivation goes on. I am just explaining the derivation. The final result already I am telling that you have to remember is n of rarer medium divided by V minus n of incident medium divided by U is equal to n of rarer medium minus n of uh, refractive medium minus n of incident medium divided by R. This is the final result that you have to remember. Now see how the derivations goes on. We use the exterior angle property of a triangle. What is exterior angle property? Firstly, I will define angle of I. I can be written as exterior angle property of a triangle as alpha plus beta. Here it is written alpha plus gamma. For this triangle, can be written as alpha plus gamma. Then gamma will be introduced. How gamma can be defined? If you are noticing on this triangle, gamma can be written as r plus beta. R plus beta, or r can also be written as gamma minus beta. Now we will take the tan angles. Tan of alpha I have defined. Tan of and these angles, all these angles are very small, so I can write tan of theta is equal to theta also. Alpha will be defined as me divided by mu. Tan of beta can be written as, this is perpendicular, this is base, am divided by mi, ma divided by mi, same thing. And again I will say this angle tan theta is very small, so that's why I have written beta is equal to ma divided by mi. What is tan of gamma? Say here tan of gamma is perpendicular upon base, again am divided by mc, and again I will say gamma is also very small, so gamma can be written as ma by mc. According to Snell's law, now I will apply Snell's law on this surface. What I will write Snell's law on this surface? If this medium is n1 sine of I is equal to here this is medium 2 n2 sine of r. Now I and r already I have calculated from here. I is equal to alpha plus gamma. I will put at the place of I, and all these angles are very small, so I will write at the place of sin A is equal to I, and at the place of I will replace now alpha plus gamma, and at the place of r I will replace gamma minus beta. And when you will apply all these things, you will have the final result at n of rarer medium divided by v minus n of incident medium divided by u, n of rarer minus n of incident divided by r. This is the final result that you have. So there is a question to apply the sign conventions so that you can be clear about the sign conventions. Light from a point source falls on a convex spherical surface. I suppose this kind of some surface is there. This is the principal axis. Refractive index given is 1.5 and radius of curvature r is given as 20 centimeter. The distance of light source from the glass surface, here is the light source or object, I can say the distance is given as 100 centimeter. At what position the image will be formed? You have to calculate what is the value of v. Try to solve it. Now see how to solve this question. The relation is n of n of refractive medium divided by v minus n of incident medium divided by u is equal to nr minus ni divided by r. Now what is refractive medium? It is equal to 1.5 divided by v, that is you have to calculate position of image. Incident medium is air, that means I will take it as 1, correct. And u, what is our distance of object given? 100 centimeter. Again, I will say this direction will become positive. That means this direction will become negative. So if this distance is coming negative, that means you will be coming as minus of 100 is equal to n of radius divided by n of denser. That means it will become finally 0.5 divided by r. What is the value of r given to you? Radius of curvature is given as 20 centimeter, and the radius will center will be lying on the right hand side. That means it will be given how much? 20 centimeter. Now when you will solve it, all these values, you will have your final answer, and the final answer will be given as it will be coming as 100 centimeter. The sign conventions are important. I have taken this distance of object as negative because I have taken conventionally this direction as positive. Where the image will be coming, that is a different case, but this radius of curvature r also, because the center is lying on the right hand side, that's why I have taken this value also as positive. This was about the sign conventions. Now why we study spherical surface? Just to understand the behavior of a lens. So lens is made up of two spherical surfaces. Basically, image I1 will be forming firstly from surface 1, then image I2 will be forming from surface 2. So let's see how this lens maker formula is derived. Write the equation firstly for surface 1. What is the equation? Again I am writing the same thing, nr by v minus ni by u is equal to nr minus ni divided by r. So what is your refractive medium? It is written for this surface, refractive medium is mu2 divided by v. What is the position of image you have taken? Let's suppose this distance is image 1 v1 minus incident medium is air, that you can take, and take this as general. In general things I am taking here, take this as air. These are the two basic equations that you can write. Now I am interested in the initial position and the final position. So for that, what I will do, I will simply add up both these equations 1 and 2. Due to that, what will happen? I can say simply this term and this term will get cancelled out. What are the rest of the things? Here will be left 1 by v minus 1 by u is equal to mu minus 1 divided by r1 plus 1 minus mu divided by R2. Now I can take common minus, and what I will write, mu minus 1 common, and here it will be left 1 by R1 minus 1 by R2, and on this side you will write 1 by V minus 1 by U. This is the final lens maker formula. This is final lens maker formula. Thank you. In general, how it is written, 1 by V minus 1 by U is equal to n of lens divided by n of surrounding minus 1 by R1 minus 1 by R2. Thank you. This is a formula that you have to remember. And this complete term is called as, this complete term is nothing but 1 by f focal length. So what is lens formula? It is, lens formula is 1 by V minus 1 by U is equal to 1 by f. This is the formula. If it has been asked that what is power, power is equal to 1 by focal length in standard units, that is meter. And what is the units of power? Units of power is diopter. So now there is a question, try to solve this question. Find the radius of curvature of convex surface of a plano-convex lens. This is, let's suppose, plano-convex lens whose focal length is given, focal length is already given 0.3 meter and refractive index is given 1.5. This is R1, this is R2. निकालो. See how to approach this question. You know, 1 by f, the formula is n of lens, that is directly I am putting the values 1.5 divided by n of surrounding is 1 air divided by 1 by R1. What is R1? You can say, from plane surface R1 is defined as infinity minus 1 by R2, that you have to find, and here it is 0. And this R2 is also in negative terms because the center will be lying for this curvature in the left hand side. Now if you will solve it, how much it will be coming? 0.51 by focal length is given 0.3, that means you can write 10 by 3 into 1 by R. So R can be written also as, R can be written 0.5 into 3 divided by 10. That means it can be written as 0.15 meter, or also it can be said that R is equal to 15 centimeter. This will be the final result. This way you can calculate for anything. I'll tell you about some focal lengths also. So how to take the focal length? On one side I have convex lens and on one side I have concave lens. What is focal length formula? 1 by f is equal to n of lens divided by n of surrounding minus 1 divided by 1 by r1 minus 1 by r2. For convex lens, this value is always positive. If n of lens is greater than n of surrounding, this value is also positive. That means focal length for convex lens is always positive. And for concave lens, if I will talk about, this is for convex lens. For second case, for concave lens, this value is negative, this value is always positive. That means focal length for concave lens is always positive into negative, it is always negative. Now if only condition for where convex lens is not positive, when this will reverse, when surrounding refractive index is greater than lens, this value will become negative, this value is always positive. That means focal length for convex lens will become negative. This is the only exceptional case. Second case, again if it will become negative, and here for negative for concave it is always, so focal length for concave lens in that scenario is negative into negative, that is positive. Now magnification due to lens, simply magnification formula is m is equal to height of image divided by height of object is equal to v by u. Here it is clearly mentioned, height of image divided by height of object is equal to v by u. Magnification can also be written as f divided by f minus u. How? V lens formula, it can be written as f divided by f plus u. So just replace it, f divided by f plus u divided by uf, actually uf divided by u. Here it will get cancel out, and when you will put the sign conventions, this formula will become f divided by f minus u, because always object distance we take usually as negative. Power of lens will become 1 by f, unit will be diopter. The question is, the converging lens of refractive index 1.5 is kept in a liquid of medium having same refractive index. That means n of surrounding is also equal to 1.5. What will be the focal length of this medium? Simply apply the formula and have the answer. So when you apply the formula, it will become n of lens divided by n of surrounding minus 1 into 1 by r1 minus 1 by r2. And I will simply say that n of lens and n of surrounding are equal. That means this complete term will become 1, and 1 minus 1, it will become 0. That means focal length can be written as infinite. 1 by 0 will become infinite. The answer will become infinite. Solve the second question. A convex lens is used to obtain a magnified image of an object on a screen 10 cm from the lens. E is equal to 10 cm. Magnification is equal to 19. The focal length of the lens will be. Try to solve this. Actually here it is not u given, it is v given. Distance of image. The magnified image of an object on a screen 10 cm from the lens. That means v is given 10 cm. If V is given 10 centimeter, what you can say about magnification? It is equal to V by U. That means U will be equal to how much? Position of object V, that is 10 divided by 19. Now apply the formula. 1 by F is equal to 1 by V minus 1 by U. What is 1 by V? It is equal to 10 minus 1 by U. U is how much? 10 by 19. Now refraction through prism. Prism is always having two normals. This is normal 1, normal 2. What are the angles here? This angle is called as I. This angle is called as R1. This is called as R2. This angle is called as apex angle. This angle is called as emergent angle. Now how it works? There is simply, it is also same kind of reflection. That means you will apply Snell's law two times. Firstly apply on surface 1. What you will write on surface 1? 1 into sine of I is equal to refractive index of the medium mu into sine of R1. This is the on the first surface. On again you will apply the same thing on the second surface. How will you write? Mu of sine of, this is R1, this is R2, is equal to 1 into sine of E. Now there are some values that you have to remember between relation between R1, R2 and rest of the things. Let's see how these things are coming. See, this angle is I, this angle is R1. What you can say about this angle? This is I minus R1. What about this angle? This angle will be E minus R2. So if I will ask you about R1, what you can say? I minus R1. What is the summation of this complete angle? It will be equal to A plus, here you will write I minus R1 plus the relation that you will write between A and R1 is A apex angle is equal to R1 plus R2 simply. And what is about deviation? You will write, first you will write net deviation is equal to deviation 1 plus deviation 2. What is deviation 1? You will write I minus R1 plus, then you will write E minus R2. I plus E, take minus common, and here it is R1 plus R2. R1 plus R2 is equal to A. That will be the net deviation. I plus E minus A. These are the two important relations that you have to remember for a prism. The minimum deviation case, how minimum deviation case is generated? The minimum deviation occurs when I is equal to E. You know what is the net formula of deviation? It is equal to I plus E minus A. And at minimum deviation, I and E are actually same. That means you can write 2I minus A is the formula for minimum deviation formula. And if this is the minimum deviation formula, what you can say about refractive index? There is a standard formula also for refractive index. It is equal to sine of I can be written as minimum deviation plus A divided by 2 divided by sine of R1. Sine of R1 can be said as A by 2, because in case of, there is one more property for minimum deviation. If I is equal to E, I can say R1 is also equal to R2, and I can also say I is equal to R1 by This is a relation that is also valid in minimum deviation case. This is an important formula. Now here is a question, try to solve it. A ray of light passes through an equilateral triangle prism, that means apex angle is equal to 60 degree, in such a way that the angle of incidence is equal to angle of emergence, that means minimum deviation case, and each of these angles is equal to 3 by 4 of the apex angle, that means 60 degree. That means how much this angle of incidence is equal to 45 degree. Determine the angle of deviation. First part, what is the minimum deviation? Second part, you have to calculate what is the refractive index of the prism. Both these values you have to calculate. So minimum deviation will be equal to, you can see the deviation for minimum deviation formula is 2 of I minus A. What is angle of incidence? 45 degree minus of 60. So minimum deviation will be 90 minus 60, that is equal to 30 degree. This is about the first part. Second part, how you will solve? Mu. Refractive index formula is sine of A plus minimum deviation divided by 2. Mu refractive index can be written as sine of A. What is apex angle? 60 plus 30 divided by 2, and here sine of A by 2. A is apex angle, that means sine of 30 degree. That means what is the refractive index? Here it will become 90 sine of 45, 1 by root 2 divided by sine of 30. Sine of 30 can be written as 1 by 2. Here it will be going and mu will be coming, finally it is equal to root under 2. Here also you can see the sine is equal to root 2, that means also it is equal to 1.4, nearly the value. Now refraction through small angle prism. Small angle means all these angles are very very small. A, R1, R2, all these angles are very small. In this case we say the angle of prism is very very small. So how you will write it? Let's suppose this is my prism, this is apex angle, and here I have taken some angle of incidence. Firstly write the Snell's law on both these surfaces. What I will write? 1 into sine of I is equal to n into sine of R1. This is the first equation. Second equation I will write sine of R2 is equal to 1 into sine of E. Now I can say that all these angles are very very small, so I can also write I is equal to n R1, and I can write R2 is equal to n R2 is equal to E. Now you know what is the angle of deviation? It is equal to I plus E minus A. I is equal to, you can write from the first equation, n R1. Then from E you can write plus of n R2 minus A. Take n common, it will be R1 plus R2 minus A. R1 plus R2 is also A, so take A common from both these terms. What will be left? N minus 1. So this is the case for thin prism deviation. Very important formula, A mu minus 1. This is about the derivation. Now there is a question. A ray of light passing through an equilateral triangle prism from AF undergoes a minimum deviation. Minimum deviation, that means you can write 2I minus A. An equilateral triangle, that means this value is 60 degree, and the angle of incidence is 3 by 4 of the angle. Calculate the speed of light. So easily you can calculate what is deviation. What is deviation? You can see first answer, 2 into 45 is equal to, sorry, minus of A, that is 60 degree. That means 90 minus 60, that is equal to 30 degree. Firstly, you will check what you have calculated. I plus E apex angle, the deviation is coming equal to 30 degree. Then they have applied deviation is equal to A n minus 1. From here you can easily calculate what is the refractive index of the material. Check what is the refractive index in the last question. Deviation you can write here, 30 degree is equal to 60 degree mu minus 1. So here it will become half, that means 3 by 2 is the refractive index, and refractive index can be written as C by V. So velocity of light in the medium can be written as 3 into 10 power 8 into 2 divided by 3. This velocity is equal to 2 into 10 power 8 meter per second. Here you can see 2 into 10 power 8 meter per second. Now the next portion of optics is wave optics. Firstly, we discuss about wavefronts. The concept given by Huygens of wavefronts. What are wavefronts? A wavelet is a point of disturbance due to propagation of light, and a wavefront is locus of all the wavelets having same phase. That means what I am trying to say, let's suppose this is the source, okay, and light is coming. So if I will go at some distance x0 from here, and if I will join all the points on this sphere, I can say that all the phases on this sphere, all the points on this sphere are at the same phase. If this is phi 1, I can say this point is also at phi 1. Every point on this sphere is called as phi 1. So due to a point source, the wavefront, the what kind of wavefront you will have? This is all these are spherical wavefronts. And how they are made? These are spherical wavefronts. Spherical wavefront from a point source. Second kind of rays can be parallel. Let's suppose here infinite long wavefront I have taken. So what kind of wavefront? Infinite long light source I have taken. So what kind of wavefront you will have? It is a kind of cylindrical wavefront for an infinite long source. Cylindrical wavefront. For a parallel beam of light, what kind of wavefront you will have? Planar surface, same like equipotential surface that we have understand. It is about planar wavefront. Now Huygens principle says how it is defined. A point source always make a spherical wavefront, and all the points on this new wavefront will behave like a new point source. And if they are behaving like a new point source, they will make their own wavefronts. And when you will match all these points tangentially, it will give you the position for next wavefront. Same way now again it will behave like, let's suppose, again it will behave like a new point source. All these points on this wavefront, they will have their own wavefront. And when you will join all these points, you will have the position of your second next wavefront. Here it is shown like this. It is the positions of next wavefront. See, for concave mirror, what kind of wavefronts has been shown? The incident mediums are parallel. That means the incident medium will have planar wavefronts. and then the refracted medium that is behaving like this is the point of image that is behaving converging, and this is behaving like a point, so that means it will have a spherical wavefront. This kind of spherical wavefronts will be there for the reflected lights. Now take the second case for convex mirror. How I will draw the again incident ray planar. For incident ray we will have planar wavefronts. For reflected ray we will have spherical wavefronts. This is the point source that is behaving, so for this we will have spherical wavefronts. This way you can draw for anything, like here also you can draw the incident wavefronts will be planar, this will be planar, and this image that is forming, it will make spherical wavefronts. Same for convex lens also you can make. Now theory of interference of waves. When two waves, let's suppose this is wave 1 source 1, this is wave 2 source 2, and they are coming and interfering at point, this point of interference I want to calculate what will be the resultant intensity and rest of the things. So I will write E1 is equal to E1 plus E2, simply add up them. What you can write, A sine of omega t plus B sine of omega t, sine of A plus B formula, into cos of phi in plus cos of omega t into sine of phi. When you will take all these commons and when you will solve this, you will have the final resultant as E is equal to A sine omega t plus phi. Now what is the resultant amplitude? A is given as root under A square plus B square plus 2ab cos of phi, same as Vector's triangles law. The final resultant will be given A square plus B square plus 2ab cos of phi. Now high intensity will be going, intensity is directly proportional to A square. What was the result for A square? I can say A square can be written as A1 square plus A2 square plus cos of phi. So how your intensity will be there? I resultant can be written as I1 plus so final resultant intensity is given as, just try to write it here, I resultant is equal to I1 plus I2 plus 2 root under I1 root under cos of phi. This will be the final result. For constructive interference, now there is the condition, this phi should be maximum, and when it is maximum, when cos phi is equal to plus 1, so general solution will be coming, phi is equal to, should be equal to 2n pi. For example, n is equal to 0, 1, 2, this kind of values. So in that case, phi will become either 0 pi, 1 pi, 2 pi, this kind of values will be there for constructive interference. And what is the path difference? Path difference is equal to phase difference is written as k delta x, that means 2 pi by lambda into delta x. So further, finally path difference can be written as, after applying all the condition, delta x should be equal to n lambda, condition for maxima, and condition for destructive interference. Destructive interference means what? Intensity will be minimum and here intensity will be maximum. What is the formula for maximum intensity also? It is equal to root under I1 plus root under I2 whole square. Formula for minimum intensity is what? Root under I1 minus root under I2 whole square. And what is the condition for part difference? In delta x should be equal to 2n plus 1 lambda divided by 2n plus 1 into pi. This is the condition, and finally you will have it from here. Part difference should be equal to 2n plus 1 lambda by 2. These two conditions are important, n lambda and here 2n plus 1 lambda by 2. Now it's about Young's double slit experiment. We'll start after a short break. recording on. So now we'll see Young's double slit experiment. What is this experiment? Firstly, light will be coming from the source, and what kind of light we take? This is monochromatic light. Okay. This is the experiment. First light will be coming to the single slit, then due to diffraction light will be coming, and then I will make two different slits, because for interference at any point we require at least 2 rays so that we can perform interference. Now here from a single light source I have made two different light sources. I will name these points as S1 and S2, and then there is a screen, and at some point it will be interfering at this point. Somewhere it will behave like bright spot, somewhere it will behave like dark spot. So these are also called as fringe patterns. So how this is analyzed? See, this is S1, this is S2 source, and let's suppose this point P I want to calculate, and the distance between these slits is represented as small d, and the distance between this slits and the screen is capital D. So what is the path difference? First, for writing anything we have to write path difference. Well, I will write path difference. Who is traveling more? S2 is traveling more, so I will write path difference S2P minus S1P. So I will write path difference. I will drop a perpendicular from S1 to S2P, and I will write this distance as d sine of theta. What is path difference? I will write path difference is equal to d sine of theta. And there are two approximations that are very important approximations. First one is d is a lot greater than small d, and second approximation is d is a lot greater than y. Due to this I can say theta is very small. So all the angles that we are going to take in this derivation is angles are very small. So if you will notice d sine theta, in that if I will analyzing this as source 1, this as source 2, this is S1, this is S2, this distance is capital D, this is small d, and let's suppose at this point P I want to calculate. This distance is given as y. So now how I will do? What is tan of theta? You can define here y by d. So what is path difference? In general, path difference by while making approximation to valid, it will be written as dy by capital D. This is the first important thing. Now from path difference, if I have to make it a bright spot, that is a maxima point, what I will write? It will be equal to n lambda. That means equal to dy by capital D is equal to n lambda. That means what I can write for y? Y can be written as n d lambda divided by small d. This is y. So what are the positions? What kind of positions you will have? Put n is equal to 0. What you will get? 0. Put 1. What you will get? D lambda by d. Put 2. What you will get? 2d lambda by d. This kind of positions you will get for maxima point. Same way you can solve for minima also. For minimum, what will the condition you will make? The path difference that you got, that is equal to dy by d, make it equal to, if you remember what was the condition for minima, it was equal to 2n plus 1 lambda by 2. So if you want to try y is equal to, can be written as 2n plus 1 d lambda divided by 2d. That means what kind of positions you will have? Put n is equal to 0. What you will have? D lambda divided by 2d. Put n is equal to 1. What you will have? 3d lambda divided by 2d. Put n is equal to 2. You will have 5d lambda divided by 2d. This kind of values will be coming for minimas. This kind of values will be coming for maximas. Here you can see path difference is also written. Now positions for bright fringes, I have generated the condition is equal to n lambda. The results that we will get somewhat like this. In dark fringes, that means minima point, the condition that we will make is 2n plus 1 lambda by 2, where n is equal to 0, 1, 2, 3, and this kind of values d lambda by 2d, 3d d lambda by 2d, these kind of values will be coming. Now what is the expression for bright fringe? The expression for beta, that is also called as fringe width. Fringe width is defined as distance between two successive maximas or minimas. If you will check what is the distance between them, it is equal to d lambda divided by small d. What is the distance between them? It is also d lambda by small d. So what is the fringe width that we define? It is equal to d lambda divided by small d. This is the formula for fringe width. Same thing is given here, d lambda by small d. So based on this, our question is there. Try to solve it. In Young's double slit experiment, two slits are distance apart 0.15 millimeter. They are illuminated by a monochromatic light of wavelength. Wavelength is equal to 4500 angstrom. The screen is capital D is given 1 meter. Find the distance of the second bright fringe. That means you have to write the distance of the second maxima. Always, if you have to write the positions for maxima, how you will write? There is a simpler way. Simply write n beta. If you have to write second maxima, how you will write? 2 beta. What is the formula for beta? D lambda by small d. Let's suppose if you have to write for position for minima, how you will write? There is a better way to write the position for minima, n minus half into beta. Which minima you want to write? Let's suppose the question is asking you the second minima, for example. So you will write 2 minus half, that means you will write 1.5 into beta for second minima, if I am telling. So first maxima, anyways, what will be the answer? 2d lambda by d. All the values are given, small d given, lambda given, capital D given, just putting the values and having the answer. Now second part is what? Dark fringe from the central maxima. Distance from the second dark fringe, again the same question is asked. Just put n is equal to 2 here, 2 minus half, it will become 1.5 into beta, you will have your answer. You can see here n d lambda by d, 2 beta, eventually they are also writing 2 beta and you are having the answer. And then when you have to write second minima, you will have the 3 by 2 into beta, you will have again y is equal to 4.5 millimeter, same formula you have to apply. Now distribution of intensity, if I will talk about what is the maximum intensity and what is the minimum intensity, let's see about that. I resultant, what was the general formula? It was equal to I1 plus I2 plus 2 I1 I2 root under I1 I2 cos of phi. Let's suppose if it is given, because it is monochromatic light, so I1 I2 is equal to I0. So what it can be written? I1 plus I2 can be written as 2 I0 plus 2 is here I0 cos of phi. Now take 2 I0 common. What is left? 1 plus cos of phi. 1 plus cos of phi can also be written as sine cos square phi by 2. That means it will become, can be written as 2 cos square phi by 2. That means eventually it will become 4 I naught cos square phi by 2. This is the final result. And what is the maximum value of cos square theta? 1. So I max can be written as 4 I naught. What is the minimum value of cos theta? 0. So I minimum will be written as 0. You can see from the pattern, this is the maximum intensity. Maximum intensity, you can see it is equal to 4 I naught and the minimum intensity is equal to 0. Where 4 I naught, these are form of bright spots, constructive interference, and these points are dark spots, also called destructive interference. Here I max you can write it is equal to 4 I naught. Now the second concept is diffraction of light. Diffraction of light, a little bit of things you have to understand. That phenomena of bending of light around the corners, the phenomena of bending of light around the corners and reaching to the geometrical shadow in opaque obstacle is called as diffraction. That means, let's suppose if this is the obstacle that you have created, the phenomena of bending of light like this, it will get splitted into these directions and reaching to the screen. But always remember, in interference, a uniform fringe pattern was forming, but in diffraction there will not any fringe pattern. Maximum intensity of light will be reaching to this area only, and then intensity will be decreasing. If I will talk about the proper intensity distribution, if I am talking about central maxima, it will have the maximum intensity. It is what? First minima intensity is equal to 0. This is first maxima. The intensity is, let's suppose, I naught. If this intensity is I naught, first if it is first maxima, the intensity is I naught by 22. Here also intensity is I naught by 22. If I will talk about the second maxima, it will be I naught by 63. Very least you cannot even see it, watch it from your naked eyes. So intensity will continuously decreasing. The only important formula in this complete section is for finding the position of minima. You can see here the intensity is maximum for central maximum, and then continuously it is decreasing. It is I naught maximum intensity, then it is I naught by 22, then it will again further decrease. So what is the formula? This is a single slit diffraction. Let's suppose light rays, this thickness is given as A, the distance is given as D. Again you have to write the path difference at this position, and this angle is, let's suppose, theta. This is Y. So how I will write it? It is distributed into two different segments. It will be A by 2, and this angle will be named as theta. So what you can write, part difference, previously it was d sine of theta, but here it is d is equal to how much? A by 2 sine of theta. And in this case, let's suppose I want to calculate what is the position of first minima. For first minima I am solving. So I will write what was the condition for minima, 2n plus 1 lambda by 2. For first minima n is equal to 0, that means it will be lambda by 2. This 2 will get cancelled, and what you will get for first minima, sine theta is equal to lambda by a. In general, if I will talk for any number of minima, sine of theta n is equal to n lambda by a. That means if I will ask for second minima, what will be the position, sine theta 2 lambda by a. For third minima, 3 lambda by a. In this way it will be further going. Now if, let's suppose, this is the position for first minima, and on this side also this is the position for first minima. Can you say that distance between two successive minimas is called as fringe width? So I will write fringe width in this one is 2y. Now how I will write y? Because I have calculated sine of theta, and I will say this theta is very small. So I can also define one more thing, tan of theta. Because I can write sine theta is equal to theta is equal to tan of theta. So what I can write for tan of theta in this triangle? It is y divided by d. So what I can write for y is equal to tan theta into d. And since theta is very small, I will write this y is equal to d theta. So what is beta? It is nothing but 2d theta. What is the value of theta you have calculated from here? Let's suppose I am talking only about first minima. So 2d lambda by a. This is the formula for fringe width of the first minima. This is an important formula. Two things you have to understand from here. What is the value of beta and what is the value of sine theta? Sine theta is equal to lambda by a, and beta will be for first only, because the fringe width always also will not same like interference pattern. This will be the result. Here you can see, here it will form a dark spot y1. This is capital D, this is small d. Tan of theta, firstly you will define, then it will become y by d, same thing that we have discussed. D sin theta is equal to lambda, and the results will be coming. Y is equal to, since central maximum is spread on the either side, it will become d lambda by d. And beta, final result, that fringe width is how much? 2d lambda by d. At the place of d we were using a, the thickness, so it will be represented as a. Now here is a question based on the same thing. A yellow light wavelength 6000 angstrom in a single slit, a value that is given is equal to 10 power minus of 4 meter. Calculate the distance between two dark lines on the either side of the central maximum. Same question they are asking for. This distance, this is the first minima on one side, this is the first minima on the other side. They are asking you for the distance between these two first maximas. How we define? Y is equal to 2d theta that we have written, and theta how we have defined? It was equal to lambda by a. So simply the answer will be 2d lambda by a. Just put the values, you will have your answer. 2. What is capital D? It is 1.5 into wavelength. Wavelength is equal to 6 into 10 power minus of 7 divided by a. Distance of the thin slits, it is equal to 10 power minus of 4. 1.5 into 2 it will become 3, 3 into 6 it will become 18, 18 into 10 power minus of 4. It can also be written as 1.8 into 10 power minus of 3, or also can be written as it is in meters, sorry, here it will become 3, that means it can further written as 18 millimeter. This will be the answer. Distance between two dark fringes. Actually in diffraction always the questions are asked from maximum questions are asked from minima's part only. Now some theoretical things are given. In the difference between interference and diffraction, this can be asked in one word answers, or like differences questions in 3 marks. So you have to remember all these differences. Now we'll have a question again. What is this question? Let's see how to approach it. The intensity at central maxima O in Young's double slit experiment is I naught. Here the intensity given is I naught. If the distance OP is equal, this Y is equal to 1/3 of the fringe width, that means beta by 3 is given the distance, so that the intensity at point P will be I naught by 4. Firstly write part difference. What is part difference? It is equal to dy by d. What is part difference from here? You can say what is y? Y is equal to beta by 3. What is beta? It is equal to d lambda by small d, and here it is the factor of 3. When you will see d will get cancelled, this small d will get cancelled. That means you can write part difference is equal to coming how much? Lambda by 3. From part difference can you write phase difference? If you remember, initially we have discussed phi is equal to k delta x, that means 2 pi by lambda into delta x. Delta x is equal to lambda by 3. This lambda will get cancelled. So phase difference is coming how much? 2 pi by 3. Now if I got phase difference, I know the resultant intensity formula, maximum intensity, that was initially 4 I naught, but here it is given I naught cos square delta phi by 2. 2 pi by 3 means how much? 120 degree divided by 2, that means it will become 60 degree. Cos of 60 is how much? 1 by 2, and if I will square it, it will become 1 by 4. So the final resultant intensity will become I naught by 4. Hence proved at point P the resultant intensity will become I naught by 4. The same thing explained here. Firstly you have founded part difference, that is coming lambda by 2, then phase difference 2 pi by 3, then the final intensity is I naught by 4. Now we will enter into modern physics, dual nature of a matter. Firstly we will discuss about photons. In this thing, 3 scientists that have entered, Einstein, have explained that lights are actually in the form of photons. Photons means what? It is a packet of energy, and how much energy it is carrying? You can see a packet of bundle of energy is called as photon, and energy of photon was given as h mu, or also it was called as hc by lambda. Properties of photons. A photon travel at a speed of light, that is 3 into 10 power 8 meter per second. It has zero rest mass, that means rest mass is zero. You cannot use mass of photon. The kinetic mass of a photon is given by E is equal to mc square. The momentum of photon, it is an important one. Momentum of photon was defined by h by lambda, that was further also called as de Broglie. Wavelength was defined also like this. Photons travel in a straight line. These are some basic properties of photons that we have used. Now from this only we have the first question. An electron and a photon each are having wavelength, one the final value, and their momentum. See how to solve this question. From the given only values or what we have studied. Let's try to solve this question. Whatever the wavelength is given, doesn't matter. Find the momentum. Momentum, how much can be written? Momentum was defined as h by lambda. H is what? Planck's constant, and lambda, it is already given 1. I don't know the values, I guess it is not correct. Anyways, what is the momentum? You can write h by lambda. Second thing, energy of a photon. How much energy of a photon you can write? It is equal to hc by lambda. Hc already you know, lambda is given. You can put the value and you can write hc by lambda energy. Kinetic energy of electron. How you write kinetic energy of electron? Simply write, you can write momentum, kinetic energy is equal to P square by 2m. So from this relation you can write kinetic energy. Let's see what is the exact value given here. Here momentum is given as h by lambda. As we have discussed, you can put the value of h 6.63 into 10 power minus 3. You will have the answer. Second part, energy of a photon. Here it is written, energy of photon is equal to hc by lambda. And the third one, kinetic energy is equal to p square divided by 2m. When you will use this, you can have your third part of the answer. So all these three are based on the same. Now photoelectric effect. What is photoelectric effect? When photoelectrons, let's suppose I am taking any metal, this is metal. Let's suppose some light is incident. Light is incident means it is carrying some energy along with it. How much energy? H mu. That is the energy of the incident photon. What happens actually when any light ray is falling on a metal? The free electrons that are present on this metal, they will absorb that energy and they will leave this surface. This complete phenomena is called as photoelectric effect. And what is the kinetic energy? The relation that you have to remember, kinetic energy is represented as energy of the incident photon. What is the incident photon energy? H mu, whatever the frequency will be given, minus of work function. This phi is represented as work function. It is a property, again it is a property of the metal. For different metals it is having different values, work function. So let's suppose if I am saying that what will be the kinetic energy, let's suppose incident energy is 5 electron volt, 5 eV, and let's suppose work function is 2 electron volt. So what will be the maximum kinetic energy you will have? Incident is 5, work function is 2, that means 5 minus 2, it will be eventually 3. Your kinetic energy of the incident electrons that is emitted from here, it will become 3. So here is a question. Monochromatic light represent the frequency. Frequency is given to you 6 into 10 power 14 hertz. Power is also given 2 into 10 power minus 3. Estimate the number of photons emitted per on an average by the source. How will calculate? You can write energy is equal to power into time, and energy of n number of photons can be written as n into E. So, and here you have to calculate number of photons emitted per second. That means basically they are asking you number of photons per second. How much it will become? P power divided by energy. And frequency is also given to you. So you can easily write just put the value of power and energy. Energy can be written as h mu, and power is already given. It is given how much? 2 into 10 power minus of 3 watt. H value you know, and just put the value, and frequency is also given into the question, so it will be easily solved. Here you can see the solving part is here. N number of photons per unit second can be written as power divided by energy, just value putting. The experimental setup, experiment was done on the photoelectric effect. You have to understand a theoretical part is there. Just read this complete experiment, you will understand what are the effects that will be coming due to the changing intensity and rest of the things. One important term is here, threshold frequency. Threshold frequency means minimum frequency that is required for showing photoelectric effect is threshold frequency. Einstein photoelectric equation that we have already seen. This is incident energy, that is h mu. This is the kinetic energy, that is for the emitted electron, and this is the work function that is written as h mu naught. And what is the equation? You can write according to law of conservation of energy. This equation is written as kinetic energy is equal to energy of incident photon minus of work function. Now the next portion is de Broglie wavelength. What was de Broglie wavelength? It was lambda de Broglie is equal to h divided by t. This was de Broglie wavelength. Further it was written as, there are lots of formulas for de Broglie wavelength. It was written as m into v. Further it can also be written as p is equal to root under 2m kinetic energy. There is one more form of this same formula, root under 2m. Kinetic energy can also be written as charge into potential difference, Q into delta V. If you are remembering these the various forms of the same formula, you can solve easily all the questions. Mostly the ratio questions are always there from here. Let's see, for example, here L lambda is equal to h by p, and also it can be written as m into v, de Broglie wavelength. Like this kind of questions are asked. An alpha particle and a proton are accelerated from rest by the same potential. Potential is same. Find the ratio of their de Broglie wavelength of alpha particle divided by a proton. So you know the relation. If potential difference is same, what was the relation that we are seeing? H divided by root under 2mq delta V. So how this is proportional? I can say root under mass into charge. So here I can write mass of proton into charge of proton divided by inversely proportional. Then here I can write a mass of alpha particle into charge of alpha particle. So mass of proton is how much? It will be, here you can write mass of proton, let's suppose 1, and charge of proton also 1. Mass of alpha particle can be written as 4 times mass of proton. Charge of proton can be written 2 times charge of proton. Here charge of proton and charge of proton will cancel out. Mass of proton will get cancelled out. The ratio will be coming 1 is to root under 8. Also it can be written as 1 is to 2 root 2. This will be the final answer that will be coming. Simple formula application of de Broglie wavelength. Here also you can see same kind of ratio of de Broglie wavelength associated with photons accelerated through potential. Again potential difference is given 512, and alpha particles are accelerated through potential, and alpha particle is accelerated here. Potential difference is changed. X is found to be 1. Find the value of x. You can same apply the same formula. You will have the answer. Next question. The electron is in hydrogen atom is initially in third excited state. Third excited state, you know the hydrogen spectrum. This is ground state, n is equal to 1. This is first excited state. This is second excited state, and this is third excited state. So there is an electron in third excited state. What is the maximum number of spectral lines which can be emitted when it finally moves to the ground state? Let's suppose an electron is presenting here and it is moving to the ground state. How many in unique lines emitted will be emitted? So simply the formula for number of lines is spectral lines that is emitted n into n minus 1 divided by 2. Permutations and combinations. What is the value of n? You can write third excited state, that means you will use 3 into 2 divided by 2. The final answer that will be coming is equal to 3. N is equal to 3 will be the number of unique lines that will be emitted. Now the final chapter, that is semiconductor and devices. So firstly, there is a concept of energy bands in semiconductor. Till now we have discussed about shells. Let's suppose a charge is here, nucleus is here. We have said that these are cells, valence cells. And let's suppose if I am talking about this electron in the outermost shell is called as what? Valence electron. And these are called as K shell, L cell, and this kind of names are given. But in modern in semiconductor devices, we say that there is not only one atom. There will be one more. Let's suppose charge will be there. Due to that, what will happen? It will also have its own shells. And I will say that due to these two atoms, some of the portions will get overlapped with each other. So these will behave not like a single line. Actually, we represent it by a band. Let's suppose this will behave like n is equal to 1. This is lowest energy band. Then there will be second energy band. Then there will be third energy band. And the highest energy band is called as what? Valence band. And if some electron is present in this valence band, that electron will be called as what? Valence electron. Same things are explained here. Electronic configuration of here it is written for silicon. How much it is? 1s2, 2s2, 2p6, 3s2 and 3p2. That means which one is the valence band? I can say 3p2 is behaving like what? Valence band. And how much electrons are present in the valence band? 2 electrons for silicons are present in the valence band. Formation of energy band, again it is showing the same thing. Here it is valence band and there is a conduction band. There is a concept of valence band and conduction band. How this conduction is happening in semiconductor? Let's suppose an electron is there in valence band. What will happen when it will perform conduction? When this electron will reach to conduction band, then only it is possible to perform conduction. So what we have to do to make this conduction band, electrons travel in conduction band? When you will give some energy, or when you will heat this semiconductor, it will gain some energy. And when it will gain it some energy, these electrons will try to move in the conduction band. And once your electron moves in conduction band, then the conductivity of the semiconductor will increase. So what is the case? What is the difference between, actually, if I will talk about semiconductors and metals? Why metals are better conductor and why are not insulator and semiconductor? So if I will draw the basic conduction band, let's suppose this is your conduction band. This is your conduction band. For metals I am talking. And this is your valence band. In metals what happens? This valence band and conduction band are overlapping with each other. That means whatever the electrons that are present in valence band are already present in conduction band. So it becomes very easy for metals to conduct electricity. But what is the scenario with insulators, or I will say for semiconductors? Again I will draw conduction band. This is your conduction band. Now I am talking about semiconductor or insulators. This is your valence band. The problem with semiconductor and this insulators is what? Electrons that are present in valence band are not able to conduct electricity because it have to move to conduction band for conducting electricity. So the difference between this energy level is represented as energy gap, and in semiconductors it is less than nearly 1 electron volt, and for insulators it is greater than 1 electron volt. That's why it is very tough to perform conductivity in any insulator, because you have to give more energy on this conduction band, then only these electrons will be traveling to the conduction band. This is the basic difference between metals and the semiconductors. So there are lots of ways to represent this is the conduction band. Energy gap, you can see there is nearly 1 electron volt between conduction band and valence band. So some properties of semiconductors are given here, you can read it. So there are two types of semiconductor: pure semiconductor that are of no use, because for example semiconductor can be represented for germanium. You can see germanium can make 4 bonds, so it will perform very less conductivity. It is less so basically that we use practically is extrinsic semiconductor, that we will see in the next part. This is the intrinsic semiconductor, also called as pure semiconductor. These are valence electrons. These are the bonds that are made. The important thing that we have to understand is extrinsic semiconductor. Extrinsic semiconductor, that means we are actually adding impurities to the semiconductor. The impurities atoms are called as what? Dopants. Doping is the process. The process is called as adding, deliberate addition of small amount of impurity into the semiconductor is called as doping. Using doping we can increase the conductivity. Let's see how I can increase the conductivity. First kind of extrinsic semiconductor is N type of semiconductor. Let's see by help of the diagram. N type semiconductor. Here what I have taken, group 5 elements such as phosphorus, arsenic, or we have taken, and here I have replaced it arsenic. Now there is a property for arsenic, it can make 5 bonds. In the germanium lattice I have replaced one germanium as a silicon arsenic. Now what will happen? It will make 4 bonds normally, like here. It will make normal 4 bonds, but still it is able to make one more. There it will be available one more electron, this lone pair, and now this lone pair will be moving in this complete atom, and then if there is a free electron for any lattice, it will perform conductivity. In this way I can increase the conductivity of the material. Next term, that is germanium. Now how I will increase this conductivity? In this type we use trivalent impurities. Trivalent impurities like aluminum. What is the property of aluminum? Charge is Al3+. That means the property of aluminum, it can make 3 bonds. Normal germanium can make how many bonds? 4 bonds. So it will make 3 bonds comfortably, but the problem will be coming in the fourth bond. It will not be able to make the fourth bond. That will create a positive charge, or also we call this positive charge in semiconductor as holes. And I will tell you, electrons as well as holes both are responsible for having conductivity in a solid lattice of this germanium. So if once positive charge is created, this will also cause to increase the conductivity of semiconductor. So these are the two types by what we can increase the conductivity of a semiconductor. First one is called as N type, second one is called as P type. In N, here we in doped with impurities group 3 elements such as indium, barium, gallium, or also you can use aluminium. There is some difference between intrinsic semiconductor and extrinsic semiconductor that you have to understand. Now you have to understand what is PN junction diode. PN junction diode. PN junction diode is one side you take positive charge and on the other side you take negative charge. What is completely happening in PN junction diode? I will tell you. Let's say this is P side, this is N side. P side means it is filled with positive charge, and N side means it is filled with negative charge. Now, when I will remove this boundary, what will happen? They will start diffuse. Obviously, positive and negative charges will attract each other, and they will start combining with each other, and they will create a region. Here it will be positive charge, here will be negative charge, and they will create a region that is called as, this region is called as depletion region. Depletion region, that will be devoid of charges. Why? All the positive and negative charges have diffused each other, and this charge will this region will behave like there is no charge present here. Now why not, if all the negative charges come here and all the positive charges came here? There is a reason for that also. What will happen when will electrons will start shifting from the N side? This is N side, this is P side. Negative charge will be induced here at this point, and positive charge, a lot of positive charge will induce at this point. Due to that, what will happen? An electric field will be generated. Electric field, direction of electric field from positive to negative. This is the direction for electric field generated. If an electric field is generated, there will be some force also. Let's suppose I am talking about a single electron. What will happen? This electric field will apply some force on this charge. What is the direction? If this is the direction for electric field, I can say this is the direction for force, and how much force will be applied? Q into E. So this force that is derived on this charge, this will cause not to travel further electrons in the P side, and this will stop the movement, and this will create the depletion region. One more important thing, there is a direction for drift current. This is the direction for drift current. Drift current. Why this is coming? This is coming due to the electric field that is present into the PN junction, and this is the direction for diffusion current. These two currents you have to remember. Opposite to the direction for electric field, the direction for diffusion current is there. This is about PN junction diode. Now there are two types of PN biasing. Biasing means adding the potential difference across PN junction. This was P side, this is N side. If this P side is connected with higher potential and this N side is connected with lower potential, this kind of biasing is called as forward biasing. And if this is P side and N side, if this P side is connected with lower polarity and this N side is connected with higher polarity, this kind of biasing is called as reverse biasing. These are the two basic types of biasing. You have to understand this much and it will be sufficient. What is the behavior also I will tell you. If any diode is in forward, and one more representation how to represent these diodes. This is the representation of a diode. This is representing P side and this bar is representing N side. This is higher potential attached. If any diode is in forward bias, it will behave like a straight wire or short wire, And if any wire is in reverse or any circuit is in reverse bias condition, it will behave like a open circuit. Using this, you can solve lots of numericals using. This is a basic property of forward bias and reverse bias. Here you can see forward bias, there is a higher potential connected with positive side and the lower potential is connected with negative side. Some properties are there for forward biasing and reverse biasing. You have to remember all these properties. Reverse biasing, you will connect higher potential with N side and lower potential with P side. Now there is a question, assuming two diodes D1 and D2 used in electric circuit shown in the figure ideal, find out the value of current flowing through this 2.5 ohm resistor. So firstly identify what kind of biasing. This is higher potential, this is lower potential. I can say higher potential is connected with P side, here also P side. That means eventually this is behaving like a straight wire. If this is behaving like a straight wire, then how I can solve? These two are in parallel combination. Now you can remove both of these diodes. You can simply use this is working in parallel combination. That means what will be the equivalent resistance for these two combination? It will be 3 by 2, that means 1.5. And this 1.5 and this 2.5 are in series. That means R equivalent will be how much? 2 plus 1, 3, and it is 4 ohm. So what is the net current flowing? Net current flowing will be EMF divided by net resistance. What is the EMF? 10 volt divided by net resistance is equal to 4. Answer will be 2.5 ampere that will be passing through this complete 2.5 resistor also you can say, and in the complete circuit the current will be flowing is 2.5 ampere. And now the final section of the semiconductor devices are logic gates. Logic gates are based on some logical relations that CS students also study. It is based on Boolean algebra. Boolean algebra works on 0 and 1. Okay. So we have some basic gates that we have to understand. Basically, there are 7 kind of gates that we have to understand. I will tell you about the truth table, and that will be sufficient to solve all the questions. First one is OR operation. OR gate, we call this as, what are the important things? In Boolean algebra, it is represented as y is equal to a plus b. Now, if I will tell you about the truth table, here will be the representations also. See, what is OR gate? The output is a plus b. For example, the truth table, how we will make it? Let's suppose this is a, this is b, this is resultant, y is equal to a plus b. There are 4 possibilities that you can draw here. What are those 4 possibilities? Either both can be 0 0, either it can be 0 1, either it can be 1 0, either it can be 1 1. So what will be the output? When both are 0 0, what will be the output in OR gate? 0, 0 plus 1, 1, 1 plus 1, 1, and 1 plus 1 is 2, but the highest value that we write is 1. You can see here off representing 0 0. So output bulb will not glow, it will always be off. When off on we am doing in OR gate, the resultant will behaving like 0 and 1. What is the output? On. 1 is representing on. 1 0, that means on off, the output will be on. That means the bulb will be glowing. On means the bulb is glowing. Final input is 1 and 1. What is the resultant? On. That means on, the resultant will be on. This is the property of OR gate. 2 things again I will say important. Y is equal to a plus b, and what is the truth table we are drawing. Second one, AND operation. What is the resultant? This is AND gate, representation of AND gate. This is the way, if you are watching this is AND gate. Now what is the truth table? Truth table is the important thing. Now output is given as a dot b, or a multiplied by b. What are the possibilities? 0 0, 0 1, 1 0, and 1 1. When you are doing 0 0, what will be the output? 0, 0 into 1, 0, 1 into 0, 0, and 1 into 1, 1. So it will have only one output where output is high, that is 1. This is the behavior of AND operation. You can see it is given a into b, and all these bulb glow, in which scenario it will glow, in which scenario it will not glow. All the things are shown here by truth table. It represented off is represented by 0 and on is represented by 1. Next operation is NOT operation, very simple operation. What is a logic gate represent the, this is NOT gate. NOT gate simply says that, what is the truth table or the output? Let's suppose if you are putting 1, NOT gate will give you the result 0, and if you are putting 0, the NOT gate will give you result 1. Simply this output, let's suppose if you are taking input, output is given by A bar. A bar means representing that it will change the direction. If it is 1, the output will be 0. If it is 0, the output will be 1. This is the behavior of NOT operation. Same thing is represented here. NOR gate. NOR gate means, just understand it, the reverse thing of OR gate. For example, but how you will understand? This is the representation of NOR gate, but important is truth table. How you will make the truth table? Firstly, make for A plus B, that is OR gate, and then we will make for NOR gate. Now see the behavior of NOR gate. बुला लो उनको, फाइनली कंप्लीट होने वाला है. What are the possibilities? 0 0 0 1 1 0 1 1. Now if I will talk about OR gate, what is OR gate? 0 plus 0 0, 0 plus 1 1, 1 plus 1 1 plus 0 1, 1 plus 1 1. But NOR gate will give you just opposite results, whatever the OR gate will give you. So 0 will become 1, 1 will become 0, 1 will become 0, 1 will become 0. This is the behavior of NOR gate. Exactly same you will have the behavior of NAND gate. NAND gate is actually not plus AND gate. Once you understand this, again you can draw the simple truth table. This is A, this is B, y is equal to A dot B, and this is the NAND gate, bar of A dot B. Again, what are the possibilities that you have? 0 0 0 1 1 0 1 1. Now if I am talking about normal natural AND gate, what will be the result output? 0 into 0 0, 0 into 1 0, 1 into 0 0, and 1 into 1 1. But this is the result of AND gate. NAND gate will give you just opposite, because there is a NOT gate also. NOT gate will reverse all the directions, all the outputs. 0 will become 1, 0 will become 1, 0 will become 1, and 1 will become 0. If I talk about the representation symbol, this symbol of NAND gate is somewhat like this. This is AND gate, and just add a NOT, it will make it NAND gate. Here is the truth table. You can see 1 1 1 0. And the final one is XOR gate. XOR gate, the simple thing is, if input is same, output will be 0. What I have said, if the input is same, output will be 0 for XOR gate. If I will talk about the representation, this is the representation for XOR gate. This is the representation for XOR gate. What I am saying, if the input is same, output will be 0. For example, what are the possibilities? 0 0 0 1 1 0 1 1. Basically you have to remember, what are the inputs? 0 0. That means, can I say both the inputs are same? What will be the output? 0 0 1. Outputs are same or different? Sorry, inputs are same or different? Different. That means output will be 1. Again, input is different. That means output is 1 1 1. That means inputs are same, output will be 0. This is XOR gate. And final one is XNOR gate. It is just opposite to the previous case. If the inputs if the inputs are same, output will be 1 or high output. What are the possibilities that we can have? Output, let's suppose 0 0 0 1 1 0 1 1. Now here again, this is same input or same what kind of inputs? Same input means output will become, now this case 1, previously it was becoming 0. 0 1, same input or different different input, that means output will be 0 0, same input. So this was final thing, that was XNOR gate. So this is the end of complete PU2 syllabus. Okay, semiconductor and devices. Thank you so much. Thank you so much for your patience. It means a lot. It was not an easy task without you all. It, in this cold of this class, you all were sitting and you were trying to sit. It immensely boosts my confidence. I don't know how this session was, but I am proud of you all. Literally, you are sitting now. The time is 4:10. It is not an easy task. Okay, that maybe it is more tough for me, but it is also tough for you also for listening for the complete night. So I literally salute you all. It was incredible. Thank you so much. Thank you.
Good job, sir.
Thank you so much.
Thank you very much.
So last one was